the progress of the nation. These roads are not just built with concrete. They are built with purpose, with planning, with precision, so that your families travel safely and comfortably.
Sure. Namaskar everyone, a very good morning to all the ladies and gentlemen. Would like to welcome everyone on the 84th annual session of Indian Road Congress, and this is the day 3. And we are all set for the technical session 13. So the technical session 13 is on presentation on GRRI road research work done in India. And let me welcome and introduce the chairperson of the session, and he is Dr. Praveen Kumar, Professor, Indian Institute of Technology, Roorkee, and convener, H5 Committee of IRC. Would like to request sir to please come on the dais, and would like to request everyone to please give a big round of applause for Dr. Praveen Kumar ji. Namaskar, sir. Welcome. Now I would like to welcome on the dais our co-chair of the session, Engineer M. Shravanan, Director of Highway Research Station, Tamil Nadu. Let's give a big hand and let's welcome sir on the dais. Namaskar, sir. A warm welcome. And now, of course, as we always believe, Atiti Deva Bhava, so now I would like to request Engineer Shri Trilochan Sahuji, Executive Engineer, Works Department, Odisha, to please come on the stage, and he's going to welcome our chairperson and co-chairperson with the flower bouquet. Thank you so much, Engineer Trilochan Sahu, sir. And now I would like to welcome all our respected presenters to this session, technical session 13. So I'd like to call on stage Dr. Naveed Kaur, Principal Scientist, CRRI. Let's give a big hand and let's welcome Madam. Can we have our next presenter, Shri Satish Pandey, Senior Principal Scientist, CSIR and CRRI. Next, I would like to welcome on stage Dr. A.K. Sinha, Chief Scientist, CRRI. Welcome, sir. Next, I would like to call on stage Dr. K. Ravinder, Chief Scientist, CSIR, CRRI. Namaskar and welcome, sir. Next, I would like to call on dais Engineer Anand Muttuswamy, Assistant Chief Engineer, NH Chennai, HRS. Good morning, sir. Welcome. Next, I would like to call on stage Shri Prakash Kumar Mahapatra, Secretary, Sankhadwani Rashtra Suraksha Samiti, Odisha. Let's give a big hand and let's welcome, sir. Now I request Dr. Praveen Kumar, sir, to start the session with his opening remarks. Thank you.
Sure. Good morning to all. So I always believe that whenever you come to IRC, this is the most important session of IRC. Why I say? Because in all sessions you will find the work of 5 or 6 persons who have done on some specific topic. We all are part of that. We are presenting there also. So normally we present for one topic or the work which is being done in his or her institute. But in this session of general report, this is the work of the whole country. All the persons in the country are working in that area. And of course, all of them cannot be brought here. So that is why they send their work, what they have done during the last 1 year. And the stalwarts in the country, mainly from CRRI, they compile them. They compile the works of these persons from the different parts of the country. And that compiled work is presented here. So if you have not much time to attend all the sessions in IRC, you can attend only one session and it will be on your fingertips that what is going on in the country or what has been done in the country during the last 1 year. What is the direction of the research? What are the new things which are being done? How we are performing in comparison to the other countries. So that is why we have the stalwarts with us. We have with us Dr. Navneet Kaur, Shri Satish Pandey, Dr. A.K. Sinha, Dr. K. Ravinder, and we have Engineer Anand Muttuswamy from HRS, and we have Shri Prakash Kumar Mohapatra, and they will be presenting the works. And in addition to that, my colleague or the co-chairman of this session, Shri M. Sarvanan, he is the director of HRS from Tamil Nadu, Chennai, he is here. So we will all try to make the session live so that you know what is going on in the country in this area. But of course we have limited time. We have already spent some time in waiting of the people. This is the first session. We all have the habit to come late. Though we are the teachers, we have the habit to come in time. The time was 9:30, so I entered here at 9:20 as per my habit of taking classes. But in general, when we go to any session or any conference, we have the shortage of the audience in the first session. So let us hope people will be coming with time when the session is going on. So out of 90 minutes, everybody has been given 10 minutes for that purpose. But already we have lost about 10 to 15 minutes. So I will request all of them to complete in less than 10 minutes. We can discuss the salient points which are there. So complete in 10 minutes only. And before asking the first presenter, I will request the co-convener, Shri M. Sarvananji, to say a few words.
I thank IRC for having given me the opportunity to co-chair with Professor Dr. Praveen Kumar sir, and thank everybody else. Already chairperson has described everything, so thanks.
Thank you. So we will be starting with the scientists from CRRI. I have a special love for CRRI because I also started my career at CRRI in 92. From 92 to 98, I was scientist at CRRI, and still I have the memories of those days. Some of you were there at that time also, and whenever we meet, we remember all those things, we remember the memories. So let us have the scientists from CRRI who are the stalwarts in these areas, starting first with the bridge engineering, and this will be presented by Dr. Naveed Kaur.
A very good morning to the respected chair and co-chair and my fellow presenters and dear delegates. First of all, I would like to thank IRC and Director CRRI for giving me this opportunity to present the research work in the field of bridge engineering across the nation. So this is the brief about the projects which I'll be presenting. So there are a total of 15 projects, out of which 3 are by BRO and the rest are by CRRI. And 7 have been completed and the remaining are ongoing projects in the field of, largely in the field of structural field investigations and laboratory investigations. Complete list of the projects which I'll be presenting, out of which the first 4 are around the structural audit, which are being done conventionally, traditionally. And then I'll be talking about the use of drone technology for doing the same purpose for the condition assessment of structures. And then I'll be talking about how the structures can be protected against the vibrations from the ground waves. And little bit I'll be touching upon the work which we have done in the field of corrosion. And then some guidelines which we have worked around the bridge deck waterproofing and how geopolymer concrete can be used in the crash barriers. Some work in the field of instrumentation of the bridges which we have done. Then expansion joint project, which is a very prestigious project for us, which we have installed in our lab. I'll be talking about that. And then closing the presentation with the 3 projects by BRO in the field of waste plastics, UHPC, and cover depth measurement. So starting with the first project, the Dwarka Expressway project, it's a very prestigious project for us because this quantum of work in this project was very huge. And the strategic importance of this project is that it aims to decongest the traffic in the NCR region. So when you are traveling from, say, Panipat and you wish to travel towards the Mathura or maybe Jaipur, you don't have to go through the Delhi NCR region. So that's the aim of this project. You can travel through EPE, Eastern Peripheral Expressway, or maybe Western Peripheral Expressway, then Dwarka Expressway, or UER, Urban Extension Road 2. The beauty of this project is that it consists of every type of structure in it. So we actually consider this as our classroom for the trainees who come to CRRI for the training programs. So you whether name the type of bridge, including simply supported, continuous, box girder, PSC girders, deck slabs, and even the most innovative design which has been first time implemented in India, the use of single pier for 6 to 8 lane carriageway. So that has been first time done in India. And also use of box string girders, which is comparatively very challenging to implement. That has also been there. Tunnels are also there. So every type of structure is included in this particular project. And there are 4 packages for expressway, 4 packages for UER2, and including all the length of the elevated structure. So 30 kilometers of length was to be investigated by us in this project. Typical distresses which we observed in this expressway were, there was distresses in the bearings, the elastomeric bearings were used, cracks were there in the pier head and girders, leaching was there. Apart from the structural defects, there were a lot of water seepage issues also which were observed in this particular project. So overall, construction quality of this whole project was given by CRRI because the testing and investigations were done on the representative basis. And it was suggested to NHAI to do the detailed investigation later on with by establishing some mechanism. Next project is similar, Yamuna Expressway. It was again a very huge project where 165 kilometer of road from Greater Noida to Agra was to be investigated by CRRI. It consisted of 195 structures, including VUPs, vehicular underpasses, minor bridges, pedestal underpasses. And the investigation was done by all the means possible, including mobile bridge inspection units, man lifters, and also drones in this particular project. Typical distresses, exposed reinforcement, cracks on the abutment walls. That was a very common thing which was in almost all the structures which we observed. Then the vehicular impact was also there, and cracks in the deck slab, girders, shear cracks, flexure cracks, exposed reinforcement, leaching, and many locations the bearings were not, these locks were not removed in the bearings, and strainers were also not properly installed. There was a gap to be maintained. Vegetation was also observed. These are the typical observations for that project. The next bridge is the Yamuna Bridge and Ganga Bridge in Hamirpur and Kanpur. This bridge came to CRRI because a lot of structural issues were observed, and this bridge was built in the year 1980. And it typically consisted of 20 spans simply supported, and the bearings were rocker roller bearing, which was because since it was very old type of bridge. And some of the bearings in the gap slab, they were replaced from rocker bearing to elastomeric bearings by raising the pedestal height. Typically, the issues which we observed there, the bearing actions were restricted, expansion joints were damaged, and there were cracks in the girders. And also the pier head, it had 4 cantilever arms. Due to the passing of overloaded vehicles on the bridge, there were a lot of cracks in the cantilever arms of the bridge. So based upon the investigations, the rehabilitations were measured. For the girder, FRP was suggested, and for the pier head rehabilitation strengthening, depending upon the distress level, FRP was suggested, and also the jacketing was suggested in this project, and the pier was also suggested to be strengthened. Next project is on the distresses observed in the pier caps in Ratnapalli, Madhya Pradesh. This project came to CRRI in its under construction stage. And it was observed that this kind of cracks were appearing in the pier head. So why it was happening, if you see closely, there is a step here. So these piers were resting on the super elevated part of the bridge, and to ensure the profile of that super elevation, instead of raising the height of the pedestal, they added a step in the pier head. And that was actually causing the issue. When it was properly checked, it was found that there was an issue of detailing in the drawing, because this is how at the step the reinforcement was provided. Even in the drawing, LD was written, so that is a very kind of bad practice, because actually it is suggested not to write LD but to give the actual length of the reinforcement, because the people who are really executing the project on the site there are large chances that they miss this length as such. So even this length was to be actually provided till this point, and this may be designed as an additional beam, and this pier height should have been designed properly. And also when we checked the design of the spearhead, it was found that there was barely any difference between the required AST and the provided AST. And even you can see here in their design itself, it was coming to be revised, but there was no safety margin, and the LD detailing was also not properly done. That was causing the cracks in the pier head. Accordingly, external pre-stressing was suggested for the pier heads, and this is the photograph of the pre-stressing which has been now executed on the site. Of course, it is under observation by CRRI. Next project is on the use of drone technology, because till now what we have seen, we have been doing with the conventional ways of MBIU man lifters. But now also in CRRI, we are using the drones for doing the condition assessment, because for the inaccessible bridges, it is very cumbersome to do the condition assessment with the help of conventional ways, including the ladders, rope access, or maybe even mobile bridge inspection unit, because it's very tough to move such a big vehicle all across the India. And also it's comparatively slow, because you have to, every time, for every span, you have to open and close the arms of the MBIU. So we have used the drones for doing the condition assessment. And this is the typical video to show you how the data is captured. So basically, the drone is fly in a particular path, and the georeference photographs are captured with a particular overlap of 70 to 80%. So in that way, when these photographs are combined together, they are stitched together, they will help us to create a 3D model of the structure. So here you can see overlapping photographs are being captured with the help of drone, and then they are stitched together in the software, and then that will result in the 3D model of the structure. So this is the typical bridge which we considered for our study on the Western Peripheral Expressway, and this is the 3D model of that particular bridge. So this 3D model can be used for creating the inventory, structural drawings of the bridge, and also as a replacement of the visual inspection. As you can see in this case, restricted bearing action can be seen, seepage can be seen at the drainage pipes. And apart from the visual inspection, at CRRI, we are also doing the non-destructive testing of the structures using the drones. So this is the device which we developed in CRRI. We have called it as Vibro Integrity Sensing Device, WinSD. So we started from this version, and this is the version 1, 2, and then 3, and then finally it was first calibrated and tested in the lab with respect to the conventional alternatives, like we are measuring the natural frequency with the help of accelerometer and the WinSD device, and the results are quite similar. And then we check the wave velocity in the concrete to check the homogeneity with respect to UPV and our device WinSD. And you can see a very good sensitivity in the case of WinSD with respect to the UPV with different grades of concrete. And also we measured the crack depth by inducing a known depth, and the results were quite appreciable. And then this is the first version when the WinSD device was installed in the drone, and we named it as VIU, WinSD Aerial Inspection Units. But the version 1 and version 2, they were really not very cumbersome. We rejected, and then we started working on version 3, which was again giving a lot of noise, and the signal was not appropriate the way we were expecting. And this is the final version of the VIU, which is now being tested in the lab as well as in the field conditions. So it has 2 sensors and 1 impacting system. It will go hit the structure.
Dr. Kaur, please try to wind up in 1 minute now.
So in this next project is the protection of these structures with respect to the vibrations coming from the ground waves. So in this project, we have tried to create a trench wave barrier, and this is the typical source of vibration which was used. And in this trench, we compared different cases. We put the sawdust, rice husk, and crumbed tire rubbers to check the efficiency of these 3 materials with respect to the open trench. And of course, open trench is the best source for the wave barrier, but the thing is it's not practical as such. So these infill materials have to be there. So when we compared the the results for these 3 materials, rubber tire was coming to be the best in reducing the wave amplitudes. And accordingly, the work can be further done for the pile barriers as well in the future. These are the papers based on this project. And next is the project funded by the MORTH, where we have tried to measure the corrosion in different scenarios. In this project, we compared the behavior of 6 different types of reinforcement bars with respect to the conventional TMT bar. So we used fusion bonded epoxy coated bar, hot dip galvanized stainless steel bars, CRS, corrosion resistance, and zinc aluminum bars. So these were first tested in the field, in the lab, in the bare condition, and then they were embedded in the concrete samples like beam, cubes, pull-out tests were done, and also for the concrete we tested some coatings as well. When we put the coating, 3 types of coatings, and how they are behaving with respect to the corrosion, and also some steel sections, they were hot dip galvanized, and the results were compared for these cases. So these are the typically tests which we did for the bare bars when the concrete was embedded, for the flexure testing, and also bending test on these type of bars, slabs when they were exposed to the wetting and drying condition. And also this project, one field test was also done for one particular bridge. And overall it was found that the SS stainless steel bars was the best performing bars, and followed by zinc aluminum and hot dip galvanized, and then fusion bonded, and then last was of course the CRS. Results, they were not really very good. Then finally the TMT bars. Next is the bridge deck waterproofing. Well, in bridge deck waterproofing for the buildings, it's very common, but the thing is that when the same product is used for the bridges, it's not really appropriate. So every type of bridge deck waterproofing which is available in the market, it has to be tested, because it will undergo under several type of operating conditions, which include the shear adhesion, tensile adhesion. So all these tests have to be done before they are put on the bridge deck as a waterproofing membrane to avoid the distresses. So this project aims to develop the design and implementation methodology for the different type of waterproofing membranes which are available in the market, because there's a huge gap. IRC need to come up with some guidelines for the testing as well as for the recommendation of a particular product. These are the different tests which were done in the lab, including the durability and the mechanical tests. Durability tests are important, shear adhesion test, tensile adhesion test. And also one of the project in Mumbai Expressway, we tried to test the performance of the bridge deck on the real life bridge as well. In this project, we considered 3 type of liquid type and 1 MMA type of coating. And in the next project, we also compared the results with the crystalline
Dr. Kaur,
waterproofing
please
admixtures.
complete in next 20 seconds.
Yeah, so in this with crystalline waterproofing, it consists of 0.8% of cement, which is added during the casting itself. And these are the tests where we compared the chloride measurement and the corrosion test. And also we are working on use of geopolymer in the crash barriers. This is an ongoing project. Not much has been done in this particular project, but mixed design has been done. The idea is to promote sustainability by use of materials. And then one instrumentation is also done in the ROB bridge, where we used different type of sensors, including strain, temperature, deflection, accelerometer were used to measure the different conditions. There are typical photographs for that and some of the results for that project. We also did the load test and measured the variation of strain before and after the test, and accelerometer to measure the acceleration of this particular bridge. And bridge expansion joint, this is another project by ministry, where we are trying to build up a unique facility in CRRI for testing the expansion joints. And this project is also almost in its completion stage. Test rigs have been installed in the lab, and the final stage of commissioning is already been done in this particular project. And then these are the 3 projects by BRO, where they have tried to use the waste plastic fibers in structures for checking their improved seismic performance. This project they are doing with NIT Meghalaya. The idea is to come up with some mixed designs and test these designs in real life field condition in northeastern and western regions of country. Another project which BRO is doing with IIT Roorkee, where they are trying to come up with some models for measuring these cover depth and foundation depth in bridges. And that project they are doing with IIT Roorkee. And then finally, last project is on use of UHPC, which BRO is doing with the IIT Delhi, where they are planning to come up with the UHPC of 150 to 200 megapascals with 6 different grades of concrete, and then test them in the lab and the field conditions and come up with some guidelines. So thank you very much. This is all from my side.
Thank you, Dr. Naveed Kaur, for nice presentation. We will take the questions in the last, after all the presenters are over.
Thanks.
I understand bridge is a very important sector. Nowadays, people are saying that many bridges are collapsing in our country, but we have to see it from the other angle also. The number of bridges which are being constructed is now also manifold, and the time taken is very less. Earlier, I remember that there were many bridges which were taking the time more than 10 years, and nowadays bridges are being constructed even within 1 year also. So we have the stalwarts here. Tandon Sahab is sitting here. He is the base Pitame of bridges. So we will take the questions a little late. So I am requesting the second presenter, Shri Satish Pandey, to please come. He will be presenting the papers on pavement engineering. Shri Pandey, please take less than 10 minutes so that we can accommodate
yes, sir,
all.
Definitely, sir. So, very good morning to esteemed dignitaries on the dais and delegates in this session. I have been given the opportunity to present the general report on road research on pavement engineering area. So under this particular area, around 62 projects has been reported as ongoing and completed by different leading research organizations, academic institutes, and private industries. So there are ongoing 24 projects, and the completed projects are around 7 projects. So I will highlight few of the projects during my presentation. So these are the list of the completed projects. So it includes the projects from CSIR Central Road Research Institute, BITS Pilani, SRM University, IIT Bhubaneswar, like that. So there are very diversified projects involving the different types of road material development evaluation, including the recently highlighted topic by Honorable Minister of Road Transport and Highway, the utilization of steel slag in road construction. And there are the performance related projects also, like the soil stabilizers, terraceil evaluation, and the nanotech additive for bitumen emulsion in tack coat applications. Besides that, the influence of reinforcement on cracking and rutting performance of bituminous concrete mixes is also studied. Laboratory study on stabilization of bases and sub-bases using FDR, full depth reclamation technology. This project is completed by the CSIR Central Road Research Institute. There is a great impetus on the development of biochar and biobitumen. So the CSIR CRRI along with the Indian Institute of Petroleum has recently completed this particular activity. We are also studying the influence of cement addition method and degree of compaction, the performance characteristic of full depth reclamation. So this project is also reported under the completed academic studies category. So this is the list of the different academic projects which has been accomplished in CRRI as well as in different academic institutions all over India. This is the list of the different ongoing projects. So few of the major projects which is going to be highlighted into this presentation is the development of fatigue performance model for full depth recycling of pavement layer. So this project is currently under ongoing stage in flexible pavement division. We are also studying the cold application of engineering muck in road construction. So during the tunnel construction, the huge quantity of muck is produced. The CSIR CRI under the NHMS sponsored study is evaluating this particular material and its suitability in road construction aspect. Along with the IIT Delhi, we are also developing the performance grade asphalt binder specification and recommendations for different climatic regions. So this project is sponsored by Ministry of Road Transport and Highway, and it is in ongoing stage. Development of cement asphalt mortar for application as a damping material is another important project. This particular material is utilized in high-speed railway construction projects, particularly the bullet train projects as a damping course material. So besides that, there are the different projects which is reported by the IIT BHU Varanasi, including development of design mix for dense graded cold emulsified asphalt mixture used for BC work, along with GR infra projects, the performance evaluation of TAC coat. So the trackless track coat is also underway, developmental stage, the life cycle cost analysis framework for flexible and rigid payment in different geographical and climatic conditions based on existing field performance data is reported by IIT Kharagpur. This particular project is sponsored by Ministry of Road Transport and Highway, and it is currently under ongoing stage. The Border Road Organization has reported a project along with IIT Delhi, which is on derivation of design mix for dense bituminous mixes using emulsion and PME separately with cold mix technology suitable for use in various bituminous layer on BRO roads and their field performance evaluation. So this project is under ongoing stage and likely to be completed by the end of this year. The feasibility study of using module developed from end-of-life waste plastics. So this project is initiated by CSIR Central Road Research Institute with BPCL. So this is an ongoing stage. In the similar domain, like in the road asset management domain, we reported a project on condition assessment using modern data collection technique and preparation of annual maintenance plan using SDM4 of Odisha PWD road. So this present annual IRC session is in Odisha, and this is a major project which the CSIR Central Road Research Institute is doing for the government of Odisha and developing its maintenance manual for SDM4. Then besides that, on northeastern region, like we are carrying out the performance assessment and strengthening assessment of different roads in Mizoram, Assam, as well as in Tripura. So these projects are also reported into the ongoing stage. Performance evaluation of road constructed using brick aggregate and subbase and 4 bitumen is initiated by the CSIR CRRI under an NHI DCL sponsored study. So in Tripura, there is an acute shortage of good quality natural aggregate. So how these marginal aggregates can be utilized and what is its performance, it is to be studied under this particular projects. And on academic research front, like there are different academic studies which is reported by the leading academic institution, including IIST Sibpur, NIT Durgapur, IIT BHU, the performance assessment of bioasphalt prepared using pitch oil and crumb rubber and like that. So there are list of couple of projects into this domain, so which you can access into the executive summary of this payment evaluation area. So now one of the projects which I would like to highlight, which we recently completed, is the development of design guidelines and a specification for utilization of steel slag in road construction. This project was initiated by the CRRI in 2020 under the major R&D funding provided by the Ministry of Steel. The major objective of this study is to facilitate the utilization of waste steel slag in road construction. So in India, around 20 million ton steel slag is produced annually, and this quantity is expected to reach 60 million ton by the end of 2030. So the majority of steel slag after partial metal recovery ended as a landfill. So how we can sustainably utilize this material as a substitute of natural aggregate in this particular project, we studied it in a comprehensive manner. And under this particular project, we developed the comprehensive customized steel slag valorization technologies to convert different type of steel slag as a processed steel slag aggregate. So in India, the 3 types of major steel slags are produced from different steel industries, which is basic oxygen furnace steel slag, Konark steel slag, and electric arc furnace steel slag. So all these steel slags were utilized and translated into the form of a processed steel slag aggregate, which can be utilized as a substitute of natural aggregate in road construction. So extensive field trials were carried out all across India, covering different geographical regions. So first steel slag road we built in April 2022 at Hazira, Surat, Gujarat. So this particular road was remain in performance monitoring continuously for 3 years, and it is remain completely distress free. There is not even a single pothole after three and a half year of performance evaluation on the road. The second project was completed in Arunachal Pradesh in high rainfall area regions, so where we built this 1.2 kilometer long steel slag road using BOF steel slag. The third project is on NS 66 Mumbai Goa, where we built 1.4 kilometer long 4-lane steel slag road. So the cement, concrete and the bituminous slag road were built at an identical location. The design traffic was around 82 MSA, and this project was completed in June 2023, and since then we are continuously monitoring its performance, and the road is found completely distress free. The major conclusion which has been drawn through this particular study, like steel slag can become a possible substitute of good quality natural aggregate for road construction after necessary processing. So it can be processed in the form of a processed steel slag aggregate. And in order to do that, the CSIR CRI in collaboration with Ministry of Steel has prepared the detailed guideline for processing and utilization of steel slag as a processed steel slag aggregate for road construction. There are overall road thickness reduction of 30 to 40% can be utilized by utilizing the steel slag as a substitute of natural aggregate. We can conserve 80 to 85,000 tons natural aggregate for a 1 kilometer 6-lane road construction by substituting this industrial waste with natural aggregate. In 100 kilometer radial distance, there is even a significant cost reduction in the tune of 40 to 45%, as the processed steel slag aggregate is at 1/3 cost of the natural aggregate. In terms of road durability and stiffness, there is a significant improvement in the overall stiffness of the road by 4 to 5 times. Besides that, there are added advantages like the reduction in the greenhouse gas emission, and at last but not least, like the steel slag can become a cheaper economical option of natural aggregate for road construction. The next project which has been reported by the BITS Pilani is the AI-enabled drone-based remote health assessment for PMGSY road. So under this project, the UAV-based road inspection system is evolved with a high-resolution
Please
image
complete
capturing
in next
system.
1 minute, Sri
Yes,
Pandey.
sir. So the major finding of this project is that it has developed a user-friendly design support dashboard that integrates GIS-based damage localization and severity classification, which can assist field engineers in prioritize maintenance activities. The third project is the development of waste plastic and asphalt mixture. This particular project is reported by the IIT Roorkee. So this project is initiated with NRRDA. So under this project, the recycled waste plastic addition by the tune of 2% by weight of bitumen has been recommended, which is basically improving the overall bitumen performance and ensuring storage stability, besides enhancing resistance to deformation and thermal cracking. The third project is that performance evaluation of cement concrete pavement in rural roads. It's a multi-institutional project which is reported by the IIT Bhubaneswar and IIT Rourkela, BITS Mishra. The finding of this project is that the pavement condition index graph shows that the newer roads generally have better condition with PCI value above 70 for road less than 4-year-old. However, as road ages, so there is a reduction in the PCI value. So the major recommendation which emanates from this particular study is that, like in case of cement concrete road, the design cement concrete grade should be M30 in place of M25, which is normally under utilization in different rural road projects. The another project which is reported by the CRI is the development of cement asphalt mortar for application as a damping material. So this particular material is suitable to facilitate the damping in high-speed rail projects. So it is developed under this particular study. So we carried out the comprehensive material and laboratory evaluation of this on different parameters. So the major key finding is that the emulsified cement asphalt mortar can be utilized in a ballast slag track construction placed between the top track slab and the lower track bed as a dampening medium to facilitate the damping in high-speed rail projects. In area of completed project, there is another projects like ongoing projects is the cold application of engineering muck in road construction. So this project is initiated by the CSIR CRI under NHMS. So under this project, the muck material which is generated during the tunnel construction, its utilization is explored as a substitute of natural aggregate in bituminous pavement. The major interim conclusions are that like the engineering muck material is technically feasible in granular layer and bituminous wearing course. So few of the field trials are carried out into high altitude areas under the CSIR CRI supervision. The another important projects which is under ongoing stage is the development of recommendation for appropriate performance grade asphalt binder in India It is started by the CSIR CRRI in collaboration with IIT Delhi. So it is Ministry of Road Transport and Highway sponsored research projects. So under this particular project at 10 locations, the instrumentation is carried out into the bituminous pavement in order to observe the temperature profile and to assess the performance of different types of PG grade binder to formulate a comprehensive guidelines into it. So there are the couple of projects recommended into the different fields, but due to paucity of time, like it is difficult to cover all the projects related to it. But the another study which with that I would like to conclude my presentation is the use of end of life waste plastic modules, which is started by the CRRI with BPCL. So under this project, we recently laid a test section on DND flyway, where these waste plastic modules are utilized underneath the bituminous layer as well as in the granular layer in the form of a geocell as well as an interlayer. So if this particular project is successful, then it can provide a gainful utilization of waste plastic in the form of a product in road construction application area. So that's all from my side. Thank you very much.
Thank you, Mr. Pandey, for very nice compilation of the work. I understand that it is very difficult to complete in 10 minutes because it is the compilation of all the projects going in the country on pavement engineering. But thank you, you did it. Now I am inviting Dr. A.K. Sinha, again from CRRI, to present the area geotechnical engineering.
Thank you, sir. Good morning to all delegates present in this campus. So now I am going to present general report research from the geotechnical section carried out by CRI, other institutions. So these are the list of organization institutes which worked in this domain. Mainly CRI and Highway Research Station has reported the work, and other very limited institutes has worked in the geotechnical engineering area. So this is the list of completed projects. We will not go into the details, just for reading purpose. These are the list of a completed project, and these are the list of ongoing projects. Highway Research Station has reported 2 projects, and another one, Zydex Industries Private Limited, has reported 1 project, and all projects are reported by the CRI only. So this is the details of academic studies carried out in MTech dissertation and as well as in the PhD course. So now here construction supervision and performance of red mud. Construction was carried out as a pilot project using red mud in the construction of embankment as well as in the subgrade, and systematic study was carried out regarding environmental assessment, economical assessment, and then the development of construction methodology. It was carried out by jointly CSIR, CRRI and IMMT, Bhubaneswar. 4 sections were laid, 2 sections were laid in construction using conventional materials, and 2 sections were laid by using red mud in the embankment and in the subgrade along the Kalia Angura Bansura section at Korapur district along the National Highway 130. So this is the completed section, and during the construction and after the construction, performance study was carried out by using different equipments. And another waste material, gyro fixed slag, was used along the National Highway 76 as a pilot study along National Highway 76 and along the National Highway 148 in Kota district of Rajasthan and Udaipur to Bhilwara in Rajasthan. And based on this study, a conclusion we can say red mud gyro fixed slag can be used in the construction of embankment as well as in subgrade also, and it is a silty type material, it is non-hazardous materials. There is no any special equipment is required for using these materials. Based on this study, IRC guidelines has been published, and now bulk utilization of geodesics is going on. So another one is quality audit approaches of flyovers Dwarka Expressways. In the Delhi, you see nowadays very several retaining walls are being constructed either in national highway or state highway, and several projects we are auditing regarding the failure of RE wall. Most of the case we are finding regarding two types of failure we are observing regarding the construction materials as well as the construction technology also. So another one is investigation remedial measures of Ariwal, Indore. Here the same case failure pattern was like that. Fine material was used in the retaining wall. Degree of compaction is less. Another one is investigation of failure of pavement and structure in Delhi Vadodara. Delhi Mumbai Expressway. We have audited this one. Technical audit was carried out, and it was found that regarding the material quality, regarding the construction quality, was not up to the mark, or we can say not as per the IRC guidelines. So regarding slope materials, regarding backfill materials, regarding water absorption of the fascia panels, regarding the degree of compaction, wide gap between the fascia panels, these are the few causes of failure was observed in all retaining walls. Another typical project was carried out, failure analysis and remedial measures of RE wall at Srinagar. In Srinagar, we see on the hillock, CRPF camp was there, and along the boundary of that high retaining wall, 7 meter, 10 meter height, varying from the 2 meter to 7 meter, 8, 9 meter was constructed without technically examination of foundations wall, and it was failed. And then CRI has approached by the CRPF department, and solution was given. Another one is development and field demonstration of natural PVD. You see, for ground improvement, synthetic PVD is being used, and you see, after several years, these synthetic materials is polluting, like micro plastic it is generating. So novel type of PVD, natural fiber coir jute PVD is being developed at CRI, sponsored by NTTM, and this was carried out jointly by CRI and NIST. Another one is assessment. It is also a peculiar project, assessment and recommendation for the water logging along the National Highway 11 and 148 in Mahendragarh district, where some underpasses were constructed, and all you see both sides, from the both side high level of the ground, and all water are coming to the underpasses. So CRI has given some solution regarding that one. Another one is very prestigious project regarding the skill development, sponsored by Ministry of Textiles. This is the 5-day training course on the application of geosynthetic to create the awareness among the undergraduate civil engineering. These are the list of content of course. And already in this project, 1,000 undergraduate students, BTech students would be trained. Already around 400 students has been, training has been given at different engineering college at Bhimwara, Greater Noida, NIT Goa, and Hyderabad. And another 5-6 engineering college has been targeted and planned in near future, and 600 will be, undergraduate will be trained. Some of the photograph of which has been training, during the training it has been taken. Another project is a stabilization of clay soil using nanotechnology approach, carried out by Highway Research Station Chennai. A scope was improvement of weak and problematic soil through chemical stabilization, and it was found that addition of NOH significantly increased the CBR value, shear strength parameters, and another one important conclusion was derived that the use of nano stabilizer did not lead to any noticeable improvement in the CBR. So these two conclusions are very important regarding the nanotechnology. And another one is ultrasonic characterization of subgrade soil, a non-destructive approach of geotechnical evaluation. It is also carried by Highway Research Association Chennai, and it was found that ultrasonic characterization is one of the alternative classification to diagnose the density of the compacted materials. Another one is performance simulation of TerraSeal additive in base stabilization application, which was carried out by Jadex Industries Private Limited, and it was examined in this scope. It was to examine the moisture-induced progressive damage in stabilized layers, leading to deformation and durability of this. This is reported, but still project is going on, so there is no any conclusion was reported. And that is this is the last slide for the regarding the geotechnical area presentation.
Thank you, Dr. Sinha.
Thank you, sir.
Geotechnical engineering projects are important from the point that any project, maybe roads or buildings, it starts with the foundation only. For the roads, we can say it is the embankment or stabilization of embankment and then the subgrade. So these are important. We will take the questions later. Now we are going for the fourth presentation by Dr. K. Ravinder, who is the Chief Scientist in CRRI, and he will be giving the idea of projects being done in traffic and transportation engineering.
Yeah, thank you. Respected Chair, Co-Chair, and my fellow presenters and all the delegates, very warm good morning. And my presentation is related to the traffic and transportation studies. Under this, there are two sub-areas, planning and management and safety and environment. Under planning and management, there are 4 completed studies are reported, ongoing are 5. And theses are 17. Total is 26 studies reported under the planning and management. Under the road safety as well as the environment, there are 25 studies are reported. Being a member secretary for the IMRA committee, this time there are 15 institutes have reported all the studies. It's a very unfortunate. Every year gradually the number of institutes are reducing. So I appeal all the institutes, colleges as well as the PWDs to submit their work done. And these are the completed projects related to the e-micro mobility in the rural India and exploration of the psychological benefits due to the PMGSY. And one is the intersection development, Kalindi Kunj intersection near Okla Barrage, and integrated transport network development plan for Meghalaya. These are the 4 studies which are reported under the completed projects focused on mainly micromobility and the impact of PMGSY roads and the traffic management plan. And in this, I would like to present 1 or 2 studies because of the time constraint. The main objective of the study by MNIT, which is sponsored by NRIDA, so to assess the transformation in the psychological wellness of rural women lives due to PMGSY roads. So this is the methodology, and the key findings are improved psychological well-being. 83 are reported easier access to healthcare facilities due to PMGSY implementation. 98 participants were told in social and cultural activities have improved due to the implementation of PMGSY. And the impact of quality life, the respondent told better access to essential services and improved safety, enhancing the daily life quality. The next studies which reported under the completed studies is integrated transport network development plan for Meghalaya. Mainly these are taking into consideration of the tourism, agriculture and industries and the mining. So The recommendations are systematically design the transformational regeneration and integration of the network, climate resilience and alternative routes in case of any emergency closure of the roads, integration of stakeholders consultation and identification of missing links and connectivity to each habitation and tourist agriculture clusters. So these are the recommendations arrived given from the study, and provide the solution to ropeway, waterway, bus, railway connectivity and EV charging stations. So the ongoing studies reported are next generation traffic flow models for sustainable, safe and smart cities, and developing a data-driven practice guidebook for the midterm and long-term freight demand modeling, comprehensive traffic studies of Ahmedabad city, and the comprehensive traffic and transportation studies of Ajmer city, comprehensive traffic and transportation studies of Bharatpur city. So these ongoing studies mainly reported on sustainable smart cities, freight demand modeling and the comprehensive mobility plans. So this is the ongoing study. The objective is to develop the intersections. So this the field studies are completed. This is Ahmedabad city. The second one ongoing study is the comprehensive traffic and transportation study of the Ajmer city. There are two phases in this study. One is the short term intersection improvements as well as the city logistic plan for Ajmer region development. So the second phase is the future network development. So in this, this is the area covered, total Ajmer region development area, which consists of Kishangarh as well as the Ajmer, then Pushkar. So these are the plans were given as a part of city logistics, like a peripheral ring road and the peripheral logistics hubs and the urban consolidation centers, distribution centers and the storage and dark stores, improvement of road safety and introduction of small freight distribution vehicles, electric freight vehicles, technology based freight vehicular movements. So these are the locations of the freight terminals, urban consolidation centers and distribution centers, and the ring road improvement as well as the new links. The comprehensive mobility plan for the Bharatpur city, which have the long-term plan as well as the short-term. Under short-term, we have the intersection improvements and the long-term road network improvement. So the recommendations given by the study is a corridor improvement plan and road safety audit of the identified corridors and signal phasing design. So these are the Bharatpur city. Then academic studies from the planning and management mainly concentrated on mode choice, hazardous material transportation, impact of parking and the access roads on signal performance and the pricing mechanism and the driving behavior. So this is from the academic studies. The second part is the safety and environment. There are 3 studies reported under the safety and environment. Generative causal AI-powered digital twin with a reinforcement of the learning for the sustainable urban transportation. Studies on retroreflectivity properties of the pavement marking. Transport Sustainability Index software for the Indian conditions. These studies are mainly concentrated on driver rating system and socio-economic impact. So these are the ongoing projects mainly concentrated on carbon footprints, conformity of HSRP plates and headlight beam on the traffic safety and road safety audits and road safety audit of Dwarka Expressway and the driver behavior analysis. In addition to, there are some studies reported for the noise mapping of Goa state and Rajasthan and Gujarat and human drowsiness system applicable to the drivers. Then the evaluation and testing of SPG drivers. So this is the one study relating to the Odisha state, which consists of 4 objectives. One is the conduct of road safety, about 6,600 kilometers of the road network consists of state highway as well as the MDR, and 49 vulnerable black spot locations, and review of road safety evaluation for the 250 kilometers, capacity development for the PWD engineers Odisha. So this is the methodology, and this is the road network of the Odisha. Then these are some of the findings of the road safety audit. These are the intersections where you will find open area without any physical channelizers, and the shoulders without any proper maintenance. Dilapidated signboards, you can see, you will not able to see the signboards are clustered in the tree branches, and there is absence of road markings. Then you can see here there is a nice road overlay is laid, but there is no road markings as well as the signboards. You can see the parapet already hit, many accidents have been taken place, so which requires painting of the parapets, and the proper shoulder maintenance are required. And you can see the signboards. It's very difficult to see, comprehend what are the directions and the pavement issues. There is a issue here, we can only, the gantry is only in the single language, so it should be a bilingual. So these are the some of the findings. You can see this is the barrier where the forest area and also the police use, but visibility during the night is very difficult. So these are already rusted. In case of any accidents, the accident severity will increase. In urban area, we always suggested go with the covered drain. Open drain always the prone to accidents. So these are the some of the findings. The black spot locations, one such improvement is the Ichapur intersection. So these are the improvements given under this study. Under the Human Resources Improvement Program, capacity building, we have conducted one program. Similar one we are planned in the month of December. And similarly, the one study sponsored by ministry, impact of speed limit on roadway capacity and safety. These are the preliminary results. The speed studies were conducted Delhi to Meerut or Meerut to Delhi. And these are the dynamic speed limit estimated at different timings for the car as well as the heavy vehicles. So the other study is on the headlight beam impact on road safety. When we travel, the other side traffic during the night, how the headlight impact will be there. So this is the one study reported. And the last study was SPG drivers diagnostics. So at CRRI, we do conduct the SPG drivers evaluation, how they are performing in terms of their visual activity, reactive capacity, fatigue test,
Please
driver
compile
behavior.
in next 1 minute.
Yeah.
Please.
So this is
try
the
to
one
wind up.
Goa noise mapping study. And due to time constraint, I am just going on speed. These are the instruments used and the recommendations suggested. These are the skill development programs conducted at CRRI, where in addition to, we also conducted one Jigyasa program for the Kendriya Vidyalaya students. So these are the academic studies reported, and planning and management studies are 17, road safety environment studies are 9. And these are the institutes reported. I would like to take a few seconds here. I given in the order of number of studies reported. NIT Tiruchinapalli reported 20 studies. CSIR CRRI reported 20 studies. IIT BHU reported 3. NIT Calicut 3. BRO and IIT Delhi 1 study. IIT Jodhpur is a 1 study. And MNIT reported 1 study. RV College of Engineering Bangalore 1 study is reported. So these are the silent points for the discussion. So thank you. I would like to request all the institute to submit their work done 2004 to 2005 at the earliest to IRC. Thank you. Thank you very much.
Thank you, Dr. Ravinder. So these were the four presentations by CRRI, and they have compiled the works being done throughout the country. And now after the four presentations by CRRI, we have one presentation by Engineer Anand Muthuswamy. He is Assistant Chief Engineer, NH Chennai, HRS. So he will be presenting on combined acoustic emission wave and piezoelectric sensing framework for progressive damage monitoring in concrete under monotonic loading. So you may please present, and please take within 10 minutes.
Thank you, sir. Good morning all. I am Anand, working as Assistant Chief Engineer in Highways Department, Government of Tamil Nadu. First, I sincerely thank my Chief Engineer, Director HRS, and the IRC for this wonderful opportunity. I would like to start with a quote, Kural 435. Varumun Kavadan Valkai Erimun Vaituru Polakidum. Varumunar Kavadan Valkai Erimunar Vaituru Polakidum. Which emphasizes we need to start the things before it occurs. Across the world, a large number of bridges and concrete structures have surpassed their design life, yet remain in service. That's why the structural health monitoring is gaining its popularity and importance. Today, I will share a study that combines acoustic emission wave sensing and piezoelectric transducer sensing into a single hybrid system to monitor progressive damage in concrete under monolithic loading. This is the outline of my presentation. In concrete, damage does not happen all at once. It progresses through distinct stages. It starts with a microcrack initiation where very fine cracks form at the cement aggregate interface, causing only slight stiffness reduction, no visible damages. As loading continues, these isolated cracks begin to collapse in, link together, they form as small fracture networks. At this point, stiffness loss and AE activity becomes noticeable. And after the continuous loading, these micro cracks, they collapse and they form a fracture network. And there the structure fails. And these are the continuous structural monitoring techniques which are conventional. To summarize the table, the traditional inspection methods and discrete periodic meaning that only the checks and structures at the specific intervals and not continuously. They also have a sensitivity to early microcracks or interface transmissions, level damages, so they miss the first sign of deterioration. Most of them are surface-based techniques, detecting only the large visible scale defects, and they often depend on the human interpretation, which makes them subjective. As a result, by the time such cracks or such failure is identified, it's a long way gone. The acoustic emission wave sensor essentially listens to the concrete. It picks up the tiny sound waves that are released whenever the micro crack forms inside the material. Every time a crack appears or grows, it produces a short burst of stress waves that travel on the structure, and the AE sensor captures these events. From those waves, we extract the several parameters: amplitude that tells us how strong the event is, counts that show how many crack activities occurred, energy indicates the total intensity, and the frequency helps us to understand what type of crack it is, whether tensile or shear, like that. In short, AE works like a seismograph of a concrete. It gives an instantaneous record cracking as it happens. The piezoelectric or PSAT sensor behaves like a smart strain gauge. When the concrete deforms under the load, PSAT pads bonded to its surface experiences strain and produces small electric voltage. This response makes it highly sensitive to gradual stiffness changes, meaning it can detect the slow weakening of the concrete well before the crack becomes visible. In addition, when used in impedance mode, the piezoelectric sensor shows how much this material can resist the electrical excitations. which decreases as the crack grows. The AE sensor is dynamic and the pseudotic sensor is static. Together, they allow us to track yearly crack onset, monitor the growth, and map the failure history in time. This slide shows AEZ and pseudotic complex, how they are complementing each other in monitoring the concreting damages. By combining both instantaneous AE and cumulative pseudotic data, we get a full spectrum of understanding of the damage, from early crack detection to the tracking of the progress deterioration, even predicting of the structures remaining live. This synergy forms a robust framework for real-time damage reduction and prognosis. The first objective is to create an integrated AE pseudotic sensing framework, a combined monitoring system that brings together acoustic emission wavelet and piezoelectric transducer technologies. The idea is to make use of both their strengths. The second objective is to monitor how the damage evolves when the structure is subjected to steadily increased load. In simple terms, we wanted to continuously capture how the concrete transits from its initial elastic stage to cracking and finally to failure. By using this hybrid framework during monotonic compressive tests, we were able to record both microcrack activity and gradual stiffness loss in real time. This helped us to trace every stage from first invisible crack on the set to the major structural degradation. Finally, the third objective focused on the analysis of AE and pseudotic data together to identify the parameters that are strongly correlated with the actual failures. Here we applied signal processing and statistical techniques to determine which feature could reliably indicate the damage. The parameters like AE amplitude, energy, frequency were compared with the pseudotic impedance and voltage shifts. These results were a set of correlated indicators that can predict the failure before it happens, essentially moving from simple damage detection to true conditional prediction. And these are some of the basic theories what our experiment went on. The acoustic emission technique, this works on basically on the principle of elastic wave propagation, described by the basic equation shown here. When the stress inside the concrete exceeds the local strength, microcracks starts to form and release small bursts of strain energy. These bursts travel, and this travel is in the range of 10 Hz to 1 MHz. The pseudotic sensors work on the principles of electromechanical impedance. As the crack forms or stiffness produces, the concrete mechanical impedance changes, and this alters the electrical impedance and measured by this pseudotic. So by tracking impedance response, we can sense how the structure stiffness integrity are evolving in real time. By synchronizing these both systems, we can link instantaneous events captured by the AE and pseudotic for the gradual stiffness trends that can be sensed by the pseudotic. Mathematically, this relationship is expressed through this cross correlation function that's shown here. And we did an experiment for that. We used this acoustic emission sensor.
Mr. Anand Muthuswamy, please complete the work in 1 minute. Yes. 1 minute, please try to complete.
No. I'll just 2 minutes.
Okay, 2 minutes, yes. Okay.
And we used these sensors and we experimented in the lab, and we applied a monotonic loading under the sensors. And we captured these signals in the same oscilloscope, using an oscilloscope in the 2 different channels. And we used these for analyzing these, and we analyzed these data using these Fourier transformation and short Fourier transformation, wavelet decorrelation, etc. And these concludes the FFT we used for identifying the frequency identification, SFFT for time frequency evaluation, and Wavelet for the multi-scale categorization and this thing. What we actually got is that, and you can see in the slide, that at first the structure is in the undamaged condition and the elastic or in the elastic condition. There is no activity. And secondly, as the load increases, the first microcut starts and there is a sudden burst, spikes in the amplitude, and there is a dip in the piezoelectric sensors. That is the onset of damage. With the continued loading, these cracks propagate and coalescence. There is a high energy burst that was observed in the AE sensor, and there is a progressive impedance shift in the piezoelectric sensors. At the last stage, there was no signals. That AE got saturated, and there is a sharp drop in the piezoelectric, showing that this structure has failed. With these 222 data which we observed, we found a mathematical way to correlate all these things, and we found correlations, and we have mapped all these things. And you can see the blue curve. AE rises sharply around 122, 150, showing that multiple AE bursts. These correspond to the crack initiation propagation of the events. The orange, that is the piezoelectric energy that shows a similar rising trend, slightly delayed, meaning that the crack releases AE energy and piezoelectric sensors simultaneously detect the global impedance. At 150, both the curves fall back to zero, saying that the structure has already failed. And these are some correlations we arrived. And finally, this correlation were mathematically analyzed, and we found this R square for amplitude and RMS voltage. It was around 0.84 energy, and this impedance it was 0.88. Peak energy and resonance it was 0.79. Duration and phase it was 0.7. Averagely, it was about 0.85, confirming a strong couple between the sensing systems. As a summary, the combined AE and piezoelectric sensing, this approach effectively captures the progressive transition from elastic to failure in the regimes. AE features represent the dynamic side of the damage. In contrast, piezoelectric sensors capture the static and mechanical things. This statistical correlation confirms the hybrid system provides both temporal precision and mechanical context in making it a powerful diagnostics tool for the next generation structural health monitoring. With this, I conclude this presentation, but our research is going on. We are trying to find a damage index which can, by using this hybrid sensor, with that index, we will be able to say that what type of damage it is coming. That is our next stage of things. Thank you, sir. Thanks.
Thank you, Mr. Anand Muthuswamy, for the nice presentation. Now, the last presentation is by Shri Prakash Kumar Mohapatra. He is Secretary Shankhdhwani Rasta Suraksha Samiti of Odisha, and he will be making the presentation on road safety initiatives. So, Shri Mohapatra ji, please take about 10 minutes because it is already 11. Our time of this session is over, but we will try to complete in next 10 minutes. You may please start.
Thank you very much to all, with the panels and all, Mr. Praveen Kumar ji, and all technical personals of the Road Safety, IRC Road Safety Congress, 84th Road Safety Congress being conducted over here in the state of Odisha. It is a pleasure on the part of the state of Odisha to conduct fourth edition of this 84th. Earlier 3 editions has already been concluded in the state of Odisha with various ministry and all. I am really thankful to Mr. Praveen Kumar and the committee of Manoranjan Parida and Dharmanand Sadangi, who was an NHI head earlier in the country. Why the road safety is a part and parcel of the road construction and road owning authority and road using authority and road making authority. I am really surprised 84th edition has been taken place, but the road user are not being taken as a priority in this sector. Why it is not there? I am really surprised. I am hampering over my mind. When the roads are to be made, it is made to be for the public, for the logistics, for the pedestrians, for the people, for the family, for the ladies and all stakeholders. but this road Congress is not taking care of these people who are really using the road. I am Prakash Kumar Mahapatra, working since last 22 years in the road safety in the state of Odisha, catering to the safety awareness program, care, sensitization and technical subject and road audit also. Next. ठीक है, आगे next. In the country, road conditions, you know, I have brought out a small film on the subject of what is the condition of the road and how the roads are being behaved. Next, chalo, sit down. Jao, modu jao. Film ta. Video ta. How our Indian roads are being behaved. Sound.
स्पीड लिमिट से ज्यादा स्पीड बढ़ाना नहीं, स्पीड लिमिट से ज्यादा तेज चलाना नहीं, गलत तरह से कभी गाड़ी न चलाना, तुम गलत साइड से ओवरटेक न करना, ऐसे तुम कभी मिस्टेक न करना। रोड के जहाँ नो एंट्री लिखा है उसमें न गाड़ी को मोड़ न देखो, ट्रैफिक रूल्स न तोड़ न देखो, उल्टा जो ऐसा कोई काम करोगे ट्रैफिक की सारी तुम जाम करोगे, इसलिए ट्रैफिक रूल्स को मानो, इसमें तुम अपनी सुरक्षा जानो, समझे? ए भाई जरा देख के चलो।
My India, my road owning authority, my road maker, my road user, the status of in India. This is the presentation.
समझो के होगी फिर सबको परेशानी, लाल हरे सिग्नल देख के चलना, वरना पड़ेगा तुम्हें हाथ ही मलना, पुलिस ने पकड़ा तो होगा जुर्माना, चलेगा नहीं देखो कोई बहाना, सिग्नल तोड़ने का काम न करना, ट्रैफिक तुम कभी जाम न करना, महसा जो अंधेर करोगे, जल्दी के शौक में देर करोगे, जल्दी पहुंचना है तुमको कहीं तो देख के चलना तुम सिग्नल को, समझे? ये भाई जरा देख के कितनी है कारें और कितनी है ट्रैफिक, कितनी है पैदल और कितनी है पब्लिक, सड़कों पे हर बल मेला जैसे, लोगों का रेले पे रेला जैसे, गाड़ी चलाना आसान नहीं है, ऐसे में गाड़ी चलाते में फोन पे कोई बात करे तो समझो कि ड्राइविंग में उसका पूरा ध्यान नहीं है, गाड़ी चलाते हुए फोन पे बात करे तो और को खतरे में डालेगा और खुद किसी रोज परेशान भी होगा, फाइन भी होगा, चालान भी होगा, कोर्ट में सजा भी वो पा सकता है, अब जो बना है कानून है ऐसा, गाड़ी चलाते में फोन पे बात करे जो पकड़ा गया तो जेल भी अब वो जा सकता है, काम ये बना है फजूल न करना, देखो तुम ऐसे कभी भूल न करना, समझे? ए भाई जरा देख के चलो। स्पीड लिमिट से ज्यादा स्पीड बढ़ाना नहीं, स्पीड लिमिट से ज्यादा तेज चलाना नहीं, गलत तरह से कभी गाड़ी न चलाना, तुम गलत साइड से ओवरटेक न करना, ऐसे तुम कभी मिस्टेक न करना। रोड के जहाँ नो एंट्री लिखा है उसमें न गाड़ी को मोड़ न देखो, ट्रैफिक रूल्स न तोड़ न देखो, उल्टा जो ऐसा कोई काम करोगे ट्रैफिक की सारी तुम जाम करोगे, इसलिए ट्रैफिक रूल्स को मानो, इसमें तुम अपनी सुरक्षा जानो, समझे? ए भाई जरा देख के चलो। स्पीड लिमिट से ज्यादा स्पीड बढ़ाना नहीं, स्पीड लिमिट से ज्यादा तेज चलाना नहीं, गलत तरह से कभी गाड़ी न चलाना, तुम गलत साइड से ओवरटेक न करना, ऐसे तुम कभी मिस्टेक न करना। रोड के जहाँ नो एंट्री लिखा है उसमें न गाड़ी को मोड़ न देखो, ट्रैफिक रूल्स न तोड़ न देखो, उल्टा जो ऐसा कोई काम करोगे ट्रैफिक की सारी तुम जाम करोगे, इसलिए ट्रैफिक रूल्स को मानो, इसमें तुम अपनी सुरक्षा जानो, समझे? ए भाई जरा देख के चलो। सड़कों पे सब जो करेंगे मनमानी, समझो कि होगी फिर सबको परेशानी। लाल हरे सिग्नल देख के चलना, वरना पड़ेगा तुम्हें हाथ ही मलना। पुलिस न पकड़ा तो होगा जुर्माना, चलेगा नहीं देखो कोई बहाना। सिग्नल तोड़ने का काम न करना, ट्रैफिक तुम कभी जाम न करना। तुम ऐसा जो अंधेर करोगे, जल्दी के शौक में देर करोगे। जल्दी पहुंचना है तुमको कहीं तो देख के चलना, तुम सिग्नल को समझे।
ए भाई जरा देख के
कितनी है कारें और कितनी है ट्रैफिक, कितनी है पैदल और कितनी है पब्लिक। सड़कों पे हर बल मेला जैसे, लोगों का रेले पे रेला जैसे। गाड़ी चलाना आसान नहीं है, ऐसे में गाड़ी चलाते में फोन पे कोई बात करे तो समझो कि ड्राइविंग में उसका पूरा ध्यान नहीं है। गाड़ी चलाते हुए फोन पे बात करे तो और को खतरे में डालेगा, और खुद किसी रोज परेशान भी होगा। फाइन भी होगा, चालान भी होगा, कोर्ट में सजा भी वो पा सकता है। अब जो बना है कानून है ऐसा, गाड़ी चलाते में फोन पे बात करे जो पकड़ा गया तो जेल भी अब वो जा सकता है। काम ये बड़ा है फजूल न करना, देखो तुम ऐसे कभी भूल न करना, समझे।
ए भाई जरा देख के चलो।
दारू पी के गाड़ी जो चलाओगे, कभी न कभी तो ऐसा होगा कि कहीं न कहीं पे तुम किसी न किसी से टकराओगे। कोई या तो घायल होगा या मरेगा, या तो फिर तुम ही होके घायल दुनिया से जाओगे। और ये भी सुन लो कि अब एक कानून ऐसा भी है कि पुलिस ऐसा नहीं कभी गाड़ी चला तो जो पकड़ा गया तो उसे पूरे 6 महीने को जेल में जाना ही होगा, जेल में जा।
I think where we stand, my engineers, my technocrat, my researcher, my road maker, my footpath maker, my pavement maker, my bridge maker, my tunnel maker, my hill road maker and borders. Everybody knows about the condition of the road. They are the gem of our country who make the road for us to use the road. But the thing is that we are not that capable, not engineers, to go how to use the road. This is the things which I had not able to comply within 22 years of my sign. My age was 25 years, and this is now 68 years. I could not make the people disciplined because the government of India has not brought road safety as a most priority requirement of his department. I feel extremely sorry. I am not going to tell anything negative, sir. I beg apology before you. I am not telling anything negative, not anything to any engineer, not fault of any engineer. Road markings are being made. Road zebra crossings are made. Road zebra crossings are not made as per the need of the people. Zebra crossing made as per the need of the roads. So that is a very big question. People are not disciplined. People are not educated. I have already told many times, when you want to make the Indian road and Biksit Bharat, Biksit Odisha and American roads, but you know what the American people, they learn from class 3 the road discipline, how to cross the road, how to watch both sides. Then only these things will take place and we can reach to American road. It is not that giving a liability on the road maker. Recently, the news has come, the road maker has to pay all the compensation on the stretch of road where the road accident takes place. I am really sorry. I am really totally sorry. Do not agree to this Government of India perception in regards to loading on the engineers and the all engineers and all. So, why the road will get damaged? Road accident, why the person who makes the road, he will be responsible? And what is his fault and all? Yes, if the defective on the road it brings a black spot, then only it can be find out that roads are really needs to be attended. Why? These things has really shocked me, because also yesterday, just before on inauguration, last Nitin Gadkari ji said, I have failed in road safety. I think Mr. Pavin Kumar must have been heard about this. He has never said in 84 edition of anywhere, I have failed. I have made the road, but I have not made the people under the discipline of the road safety. Road safety If it is not there, no road will be useful, no road will be that beneficial to the economy, that road economy will not be there. Do you know, per day, I am giving you a simple example over here, sir, before you are the chairman over here, this preliminary session and all.
Please
Last
complete
10
in
years,
please complete in 30 seconds.
last 10 years, Government of India has given a crime record bureau given 1,50,000 people are dying every year. When I raised this question, sir, every year 150, not 151, not 60. Then suddenly they felt it that I am telling wrong and all. That is now, he said that 1,80,000 people are dying on the road every year. It means during the tenure of the entire government, nearly, around 15 lakhs people have died on the road. Economic loss is 5,000 crores. How many amount of spend on the roads? But the economy has already gone into that dock. So this is my subject matter. I may request, I have brought a presentation over here. In Odisha, what I wanted to have, what I want to give a message to the country, that road safety directorate has to be formed, sir. If a road safety directorate is not being formed, no state is being brought under the road safety directorate, I don't think a comprehensive assimilation of various departments, from education, from health, from rural sector, from human life, all has to be brought into one component. Municipality said, road is not ours. Block say, road is not ours. Why should you do the road safety? Why should the road people will be safe on the road? Their chairman is telling. If the mindset of the IS officer, is such, I am really last man to say so.
Please complete in 10 seconds now.
Yeah. I am Prakash Kumar Mahapatra, Secretary Sankhaduni Rasta Suraksha Samiti, and also I am the member of the District Road Safety Committee and also Council member of the Odisha Road Safety. The topic I have brought it out, adequate administrative road safety reform. First, I have been communicated at 11 o'clock yesterday that kindly bring out a presentation. I could not have a time because I have to simply type it out. 4E is the first engineering system. Road safety to whom the Government of India needs to seriously attend to it. Golden hour of accident on the highways to save the life. The golden hour definition is only rest with the doctors. If the doctors are not there, golden hour cannot be there. Heat and run compensation. Heat and run compensation has been limited up to 2 lakhs rupees. But it is within 48 hours, Government of India said that all the expenses has to be borne by them. Trauma care availability, it is not available in the trauma care center. I have requested last 5 years back, the national highway were given the huge amount of road, but roadside amenities of the road trauma center, drive-in trauma center has not been provided. But yes, plantation are being given, all the facilities are being given, but not the trauma.
Okay, thank you, Mr. Mohapatra. Thank you very much. We will listen to you again. Let me take 1 or 2 questions so that
I'll take only 2 seconds, 2 minutes and all, sir.
Okay, 2 seconds.
NHIA, SHIS roadside 25-kilometer trauma center has to be brought, providing space to the hospital for the land being provided to the plantation and trauma center, and formation of road safety directorate to assimilate a department of responsible from education to the healthcare awareness and reaching to the door of the house. 2030, my vision is that a road accident will touch each and every house. I do not know how many people are there who has really experienced the road accident disaster in their family. The disaster in their family will not reach to the person who are making the road or making to the government. All that mobility, all infra are not available. Road safety infra is not available. Focusing on the country's interest on the road safety in all Independence Day and Republic Day. No Republic Day or Independence Day, road safety is not there.
Thank you,
Road safety concern
Mohapatra ji, thank you. So we will take now 1 or 2 floor intervention because the time is already over. Next session has to start at 11:30. So 1 or 2 quick questions from the audience if any is there. Yeah, Tandon Sahab, though he himself is the answer also for all the questions of the evening, but I will ask, request him to say one or two lines only, question only. थोड़ा माइक दे दीजिए उधर जाके, माइक दे दीजिए वहां जाके, यहां से ले लीजिए, माइक नहीं है तो यहां से ले लीजिए. Only one question, and after that the answer by his question will be on bridges, of course. So Dr. Naveed Kaur may answer for that question.
Hello.
High tech. Thank you, sir, for giving me at least the opportunity to ask one question. There were, of course, 6 presentations, and I think all 6 were fantastic. I mean, it was really a learning experience sitting here and hearing these 6 persons or scientists. I have one question for Naveed Kaur.
Sir.
Bridges. She has talked about the use of stainless steel bars, duplex type, as being the most effective use in, replacement of reinforcement bar by a stainless steel bar. The question is that the Ministry of Road Transport and Highways has taken out a circular 2 years ago that within a distance of 20 kilometers from the shore, you should use stainless steel bars without defining what stainless steel bars to use. So I would like to know, what about the use of stainless steel bars? There are so many types and so many specifications. What do you have to say about that?
Very good question, sir, because when this project was granted to CRRI, this circular was the main reason behind giving this project. That's as per my understanding. Because at that time in Hari Bhari, this circular was just came out with mentioning only SS. But now, after so much of time, it has been found that since it's only SS mentioned in the circular, OM of ministry, people are using, the stakeholders are using any type of SS. But given the fact, this project which was given to us, it was really not mentioned in the project itself that what type we should be using. At that time, we procured something from the market and it was duplex, and it was of course the highest grade of SS, and it was supposed to be the best among all the type of different type of rebars. So our study is only for the duplex in the SS type of bar. Other types, when we are now submitting the report to ministry, they are coming up with this thing that you should have used the lowest grade of SS. But this should have been informed in the very beginning, and now it cannot be done. Of course, it can be another study as an extension of this project itself. So this is what we had proposed to them, that if you really want to check the different types of SS, let's do another project. Because at this stage, it's not possible to include all of them. Of course, duplex was the best among the SS, and of course, coming up as the best among the different types of rebars which we considered in our study.
Okay, thank you, Dr. Naveed Kaur. So now those who have the questions may just tell their names and give the questions in writing. We will include them, and the persons will answer to you in writing. So just tell your names who are interested to give the questions.
Myself, Dr. Narayan. So I have a different kind of question. Basically, it is to Mr. Mohapatra from Safety Society, Cuttack. So my question is, Mohapatra sir, during hazard, how do you manage the road safety? And what are the steps taken by your society till now in managing this during hazards?
Yeah, you want to answer?
ଶୁଣି ପାରିଲିନି ଆଉ ଟିକେ ମୋତେ ଯଦି କ୍ଲିୟରଲି କହିଦେବ ମୁଁ ନିଶ୍ଚୟ ରିପ୍ଲାଏ ଦେବି.
Sir, I have a question.
Yeah.
Your society is managing road safety in the state highway as well as in national highway. My question is, during hazards such as accidents, all that, how do you manage road safety? And please explain till now what kind of measures has been taken by your society for efficient management during hazards.
My dear friend, in regards to hazard situation, it is the police who has to bring out all the discipline of the road. It is not the road safety organization who has to drop out on the hazard time to bring out a safety, because the road safety people are extremely less. It is not being funded like Government of India roads are being funded. So the limitations are absolutely less, and we have to work under the certain guideline and framework. We are not like Government of India. We are not like toll collection and all throughout the country and all. We have got limited resources, limited manpower, limited technical people. That's why the hazards responsibility has been given to Fire and Disaster Mitigation Authority of Government of Odisha. They are supposed to do it, and they are doing it. They are excellent in all components. Thank you.
Thank you, sir.
Actually, their organization name is Shankhdhwani Rasta Suraksha Samiti. So I believe that their work is to highlight the things, what is going on the road. And finally, the call is to be taken by we people who are here in this hall, those who are the real constructors, the police, all they have to take. They are the persons who are highlighting the issue. So if anybody is there who wants to ask the question, please tell your name only and give the question in writing. Yes, tell your name.
My name is Atop Lego.
Yeah, okay, you give in writing. We will take into account that one. So now session we are going to complete now. We have 4 presentations by CRRI, and as I said that CRRI has done a wonderful work by bringing all the projects in the country to a single session. Those who want to know what is going on in this country, what has been done during the last 1 year, they can attend this session and they will be knowing everything about that. Then we have, and that is why this session is traditionally chaired by the Director CRRI. You might have seen that traditionally Director CRRI chairs this session, but I don't know why Dr. Parida asked me yesterday only to chair this session. He is having some other work. So that is why I am chairing this session. And we have one presentation on this damage monitoring in concrete, and many other projects regarding drones also were discussed here. And then finally we have the presentation by Shri Mohapatra, a wonderful and thought-provoking video he has shown. As his name says, Shankhdhwani. So he is trying to, Shankh is a instrument through which we try to jagrat the audience. So that is why he is saying it is Shankhdhwani. Thank you. And in the last, before we conclude, I am handing over the mic to my co-convener of the session, Shri Sarvananji. He is Director of HRS Tamil Nadu, to give his concluding remarks.
All presenters have given nice presentations regarding I think we have a very wonderful session, guided by Chairperson Professor Ayati Roorkee.
So thank you. We conclude here, and because the next session has to start in this hall only, so organizers can do the remaining work.
Thank you so much, sir. Requesting everyone to please stay back with us for a few more minutes. Thank you so much, the chair of the session, Dr. Praveen Kumarji. Thank you so much, sir. The co-chair, Engineer M. Sharvanan, sir. Thank you so much. Thank you so much, all the presenters. So now it's time to felicitate all our respected presenters. So requesting the chair of the session, Dr. Praveen Kumar, is going to give a moment to Dr. Naveed Kaur, Principal Scientist, CRRI. Expecting some clap from the audience, definitely. Next, requesting Shri Satish Pandeji, Senior Principal Scientist, CSIR, CRRI, to please come forward and receive the memento. Next, requesting Dr. A.K. Sinha, Chief Scientist, CRRI. Thank you so much, Chairman of the station. Thank you. Now I request Co-Chair of the station, Engineer M. Sarvanan sir, to please come forward and present a moment to Dr. K. Ravinder, Chief Scientist, CSIR, CRRI. Now requesting Engineer Anand Muthuswamy, Assistant Chief Engineer, NH Chennai, HRS. Sir, please come forward. And requesting ladies and gentlemen, let's give a big hand. Now requesting Shri Prakash Kumar Mahapatra, Secretary, Sankhadwani Rashtra Surakya Samiti, Odisha, to please receive the memento. Now I thank you so much, Chairman of the session and co-chair of the session. Thank you. Now I request Engineer Purnachandra Dalai, Additional Chief Engineer, Works Department of Odisha. Sir is going to felicitate the chair of the session and the co-chair of the session. It's our absolute pleasure to having both of you, sir. Thank you so much, our respected chair of the session, Dr. Praveen Kumarji. Thank you so much, Engineer M. Sarvananji, the co-chair of the session, for the awards. Thank you so much, Engineer Purnachandra Dalai, sir. Thank you. Thank you so much, respected chair of the session, co-chair of the session, along with all the presenters. Thank you so much. So we are winding up this session here. The next session will start within 5 to 10 minutes, so requesting everyone to please come back here. Thank you. Ladies and gentlemen, we are starting off the technical session 15, presentation on papers published in IRC journal within few minutes. So requesting all the presenters and everybody in this hall, please get ready. Within few minutes, we'll start this. Thank you. Sure. Requesting ladies and gentlemen to kindly sit down so that we can start the technical session 15. We're just about to begin the technical session 15. So requesting ladies and gentlemen, kindly please settle down. And the technical session 15 is on presentation on paper published in IRC journal. So let me take the honor and let me introduce and welcome on the dais the chairman of the session, Shri I.K. Pandey, former Director General, Road Development, Special Secretary, Minister of Road, Transport and Highway. Let's give a big hand and let's welcome sir on the dais. Namaskar and welcome, sir. Now I'd like to welcome on the dais our co-chair of the session, Engineer Dukhavendu Behera, former Engineer-in-Chief, Works Department of Odisha. Let's give a big hand and let's welcome sir the dais. Namaskar and welcome, sir. Now I request to welcome our chairman of the session and co-chairman of the session with the flower bouquet, requesting our executive engineer civil, Mrs. Ashmita Mahapatra, madam. She's going to welcome our respected chairman and co-chairperson with the flower bouquet. Thank you so much, Ashmita Mahapatra, madam. Thank you. And now I would like to welcome all the presenters to the dais. So can we have on stage Jairam Krishna Loya and Professor A. Veera Raghavanji. Let's give a big hand. Our next presenter is Sri Nadeem Khan, Dr. Rakesh Kumar, and Professor M. Parida from CRRI. Namaskar and welcome, sir. Our next presenter is Radhika Parthasarthi, Team Leader, Special Transformation Cell, Indian Port Association, and Dr. V. Rangarajan, Director Research, Evan Pune. Namaskar and welcome, madam. Our next presenter is Professor S. Shankar, Shri Pavani Che, and SSB Gopal Rajuji. Namaskar and welcome. Our next presenter, Dr. Etoff Ligo, Director, Seismic and Structural Consultant Private Limited, Itanagar. Let's give a big hand for all our presenters. Welcome, sir. Now I request the chairman of the session, Sri I.K. Pandey, to start the session with his opening remarks. Thank you.
Good afternoon, ladies and gentlemen, fellow participants, co-chair and respected speakers. In this session, we have 5 research papers to be presented. Research papers and gives a insight into the various methodologies, various technology which can be
employed to improve the highway construction and operation. The work done by the researchers is commendable and has to be appreciated, and they are the torchbearers to give us some information how we can proceed in the future and further improve our construction and operation methodologies. Today we have 5 papers, and we will invite one by one. And during the course of the presentations, I will introduce the papers. There are 5 papers. Paper number 738, the forensic investigation on premature failure of a highway payment. Another is paper number 742, time to adopt integrated advanced construction technologies for enhancing the riding quality. Paper number 746, highways, humans and hardwares. Paper number 748, influence of cement content in curing technologies and soil structure interaction modeling of integrated abutment bridge in cohesionless soil and practical implementations. So these are the papers will give you an insight. And before going further and inviting the speakers, I'll request my co-chair to give his comments. Thank you.
Good afternoon, everybody. Today's presentation is basically our research papers published in our journal. So already Chair Sir has told about these papers. So as time is short, let us proceed with these papers, and during the presentation, we'll have discussion on these papers. Thank you.
So first of all, I will invite Professor A.V. Raghavan for the paper number 738, the forensic investigations on premature failure of a highway permit, linking theory to practice. The paper is written by Jaya Ram Krishna Loya and Professor A.V. Raghavan. Over to Sri V. Raghavan. Thank you, sir.
Thank you. Thank you, Chairman, Mr. I.K. Pandey, former DGRD, Co-Chair, Mr. Behera, former Engineering Chief, Works Department of Odisha, co-presenters for this session, dear participants. What I'm going to present in the next 12 minutes or 15 minutes is on the forensic investigation of premature failure of a highway payment, linking theory to practice. Why and these payments fail? What is the need and importance of the study? We should understand that payment is a system. Many of the researchers study the binder, mixes, or the granular layers or stabilized layers, and then predict the payment will fail. It's one of the component layer of the payment system, but it is not the entire payment system. So if you want your payment has to perform, or you should have an idea about the material that are used in different layers of the payment and how they perform. And more importantly, the engineer who is responsible for the performance should also understand the various factors that influence the performance. The question arises at this point of time, what is the good quality construction that we are talking about? If we talk about good quality, it is not a rocket science. We should have an adequate compaction of all the layers from embankment, fill, subgrade, subbase, base courses, as well as the bituminous layers. The granular subbase should have adequate permeability. The pavement thickness should be adequate. The bituminous layer should be constructed at the right temperature to the right density to the right air voids. And you should also ensure good quality of the construction. But more importantly, why the pavements do not last as we design is because there's a lot of differences between the material that we test in the laboratory to what is used in the field. So how do you bring this gap, match this gap? It's a question that has to be answered. Finally, it is a construction that translates design into a reality. So this project which I'm talking about is a 4-lane highway, about 120 kilometers. The pavement prematurely failed after a few monsoons. Traffic was around 50 to 85 MSA. As usual, they normally feed any consultant for that matter, input the numbers, you get some thicknesses. GSB was 200, wet mix macadam was 200, DBM varied from 85 to 120, and the BC was 50. So as on paper, the payment satisfies all the requirements. The payment should not fail before the end of the design life. So design period as per IRC 37 is the period when the payment should not warrant major rehabilitation, but none of the payments last. So I always ask my young researchers, what is wrong with that? Is it because of the poor material characterization, or the design, or the construction? What went wrong? Why none of the payments last for 15 years without warranting a major rehabilitation is a challenge. The payment developed premature distresses. When you try to analyze what went wrong, the objectives were to quantify the impact of the constrained quality on the performance. Secondly, what went wrong? So there are different tasks. We carried out the laboratory tests, collected samples from the field as constructed, conducted laboratory tests on the materials, then tried to relate the quality of the construction on the strength of the different layers, and use that strength of the layers as constructed. We predicted the performance, and then we tried to match the predicted performance with as constructed quality data vis-a-vis as per the DPR. So that is the as constructed vis-a-vis as it was designed. The methodology is that we found that degree of compaction or subgrade has a significant factor influencing the strength. You have to use the laboratory data and the field test for the sample analysis. Subsurface drainage is found to be the most important factor influencing the performance. We computed thickness of the pavement with the as constructed material properties and as per the design. We tried to compute the strain values under both scenarios and tried to predict the performance, and found definitely there's a linkage between theory to practice. I'll show what it is. When you try to test the subgrade was classified as SCR SCI. Density varies from 1.98 to 2.16. CBR value varies from 3.54 to 6.57, whereas as per the DPR, that CBR of soil as designed is 10 to 12%. The OMC varied from 5.2 to 10.3. Liquid limit varies from 35 to 61. And the plasticity index varies from 14 to 38. This clearly indicates the soil as used is not as per the specifications. Therefore, one of the reasons for the premature failure is that the soil did not meet the requirement. So you can find from this graph that the top green line indicates the 97% density, whereas the density varies along the length of the pavement section. Once you compute the CBR, for the CBR, you compute the resilient modulus, input the IIT PAVE, compute the strain values. We found that the strain values as per the constructed strength values exceeded some of the strainages wherein there were distresses. More importantly, it's a radial tensile strain that plays an important role. Even if you use IIT PAVE, the pavement will not crack, will not rut. The rutting life will be few hundred MSA, but pavement ruts. Why? What went wrong? Here again, we found most of the distresses are in the form of cracks. If you look at the design life as per the design, as per the DPR, vis-a-vis the design life as constructed parameters, you find the pavement life, which was 50 to 90 MSA, drastically comes down from 15 MSA to 30 MSA. So subgrade compaction becomes the most important factor influencing the performance. When you look at the compacted thickness between as designed and as constructed, the pavement still warrants an increase in the thickness of DBM. This is because of inadequate compaction of the lower layers. The pavement warrants an increased thickness. If you look at the moduli of the granular layers, at different saturation levels, 25%, 50%, 70%, 100%, we find the moduli value significantly reduces. If you use this fully saturated GSB value moduli, you'll find that the green line indicates the allowable value, but the red line indicates the strain values exceed the allowable value, resulting in the failure. If you use these strain values as per the saturated condition and then predict the radial tensile strain, you will find the radial tensile strain significantly higher than what is designed. So there's a lot of difference between design and practice. On paper it works, but on ground it does not work because the constraint quality is not as per the design. If you look at the life of the payment with the GSP saturated condition, vis-a-vis the design values of model A value, you find the life significantly is lower. It is as low as 3 to 4 MSA. So more than the subgrade, it is the GSB that plays an important role. The drainage, saturation level of the GSB plays an important role. If you look at the Marshall flow, again you find there's a wide variation along the chain edges. It is between 3 to 5, 2 to 4, but you find that values are higher. Air voids, wide distribution in the air voids. Binder content again between different chain edges it varied. The stability values again varies for the BC sample, and air voids also varies. So therefore, quality plays an important role. There's a linkage between theory and practice. Design values does not mean the payment will perform. Similarly, the binder content of BC values also exceeded. So to summarize, the field density of the subgrade soil was lower. CBR value was 12 as per the design, whereas it was 6.42. We don't have any method by which you can consider the CBR of the soil as constructed. We assume CBR is 10 and 12, but it is not constructed to the required density. You will not get the required CBR. CBR as constructed was low, that resulted in increased vertical compressive strain and the radial tensile strain, and the pavement prematurely failed. The predicted life was lower than the design life. There is an increase in thickness that is warranted if you want the design life to be met. Air voids and binder content did not meet the specifications requirement that resulted in, we tested the core samples for the resilient modulus, used that number to compute the strain values. Again, it proved that the strain values are higher than the design values. The compaction is found to be the single most important factor that affects the pavement performance in terms of durability, fatigue life, resistance to deformation, strength, as well as moisture damage. So to conclude, the lower density of the subgrade layer resulted in the reduction in the CBR value. Gradation of GSB did not meet the requirement, resulting in poor subsurface drainage, and hence the life of the pavement was much, much lower than the design value. Air voids and binder content in the DBM and the BC did not meet the specific requirement that resulted in cracking, raveling, and potholes. So just if somebody wants to find out a solution, a remedial measure, providing an overlay will not work. When the lower layers have deteriorated or not constructed as per the specifications, providing overlay is just like putting a makeup. After the monsoon, your true colors will be seen. After washing your face, you know what is the true colors. Therefore, this pavement warrants major rehabilitation. I suggested that you have to resort to in-place recycling or central plant recycling, cold recycling can be adopted, but there's a costly mistake because on the poor constraint quality that was involved. So every discussion paper should have some points for discussion. It's not that asking clarification, but there should be food for thought. When you go out, you should have something to think over, brood over, and take forward. So the points for discussion from this presentation is that, should we relook at the core samples? What we say is one set of 10 samples for 2,000 square meter, or DB on BC, one set of 700 meter. At some spot levels, you take the density. Is it an indicator for ensuring the quality of the entire pavement length? Cores do not measure the density continuously. So what is to be done? What is to be done is, it is time we adopt intelligent construction technologies. It's possible that we can have a dielectric profile system DPS. We can have an intelligent compaction. We can have a paver mounted thermal profiler which tells us how the temperature varies. This will enhance quality. The future of Indian highway construction should be to adopt this innovation in ensuring construction quality. Second, how do you check the CBR as constructed is the same as the design CBR? This is a point, food for thought. Should the density be, I think it's time, we don't use density for pavement thickness determination. We use modulus. So is it possible for me to define the quality in terms of modulus? Yes, possible. I think the future area of research should be to define the modulus value of different layers, which will be an indicator for the quality. Last point. How to ensure that the MR of the GSB as constructed is the same as that used in the design? how to ensure the minimum permeability value of 300 meters per day, how should the lab performance test be mandatory, how to check that laboratory performance tests indicate the field performance, how to final point is that the proof of the pudding is in the eating. How do you know the pavement as constructed is what is designed? Can I use the deflection as a measure of the constraint quality of the pavement system as a whole? Is again a food for thought. Again, lastly, should we adopt a digital twin framework, whether we can achieve, retrieve the data, facilitate the payment in a real dynamic system, understand the payment performance. I think it's time that we move forward with the conventional methods to automation, intelligent compaction, methods, digital twins, BIM modeling that will ensure a better quality construction. Thank you very much for the opportunity.
Thank you, Professor Raghavan. It is a wonderful paper which has given an insight how the payment quality can be ensured by adopting modular space design and digital twin framework. And till then, at least we have to ensure that what we design is also reflect in the construction, and for that soil parameters, the design mix values, and the strict quality control has to be ensured. I invite questions from the audience, if any. Please give mic to him.
Hello. Myself is the Deputy Director from Highway Research Station, Chennai. So I am actually a doubt I am asking. So we are having the cracks on the top surface of the pavement of this BC course. How to identify it is a crack developed from the bottom up due to the subgrade failure, sir?
There are two ways of finding it out. If the pavement prematurely fails, what I mean by the term there are two types of failures. One may be because similarly there can be different types of rutting. You can also extend the question to rutting also. How do you know the rutting is the bituminous mix or due to the entire pavement system? So if there is a rutting for the entire lane width, then it is due to inadequate compaction of subgrade or inadequate subsurface drainage. If the pavement develops cracks, you can take a core and check. If that core is to in the top few millimeters, it is due to aging of the binder, or your mix has aged longer, or the choice of the binder is wrong. And you can also check it with the deflection test. If the deflection is more and there are cracks, then it needs an overlay. It needs rehabilitation and strengthening. If it's a full depth core, you can again go for recycling. So don't go for overlay in all cases. Investigate, find out the mixes as constructed, meet the requirement of binder content, gradation, density, and air voids. And still if there are cracks, then it may be from the bottom layers. If it's a full depth crack for the entire layer, the bituminous layer, then something is wrong with the design thickness. Full depth crack cannot occur prematurely. If it occurs prematurely, your design is wrong. As constructed is wrong. It needs a major rehabilitation. Providing overlay will not work.
Thank you, sir. Thank you for an excellent answer.
Yeah.
Sir, one question from me. Would you like to suggest any instrumentation during construction for measuring the tensile strain and radial strain so that we can make an assessment on time, with a time period, whether the construction has been done properly? For each contractor, this can be suggested that at least one or two such locations he should identify and should put strain gauges or whatever it is.
Yeah.
And we can go on, at least for these perpetual payments, we can suggest certainly.
Yeah, right.
Okay,
Yeah.
thank you.
Yeah. Steve was also present.
Yeah, thank you, Professor. Very wonderful presentation on forensic investigation. So my only question is, you suggested that FDR can be provided as a substitute for the reconstruction purpose.
Tell again.
FDR has to be done because overlay you suggested that it is a cosmetic treatment, so it will not work. So instead of this, you should go with an FDR. But the inherent problem is, I think, the CBR of the soil was 10 to 12% was desired, and you got only like 3 to 6%. So would FDR be able to, because inherently the foundation of the payment is weak. So how FDR would be able to strengthen or enhance the foundation of the soil?
Yeah, you are right. You are very right. In fact, if you read the paper, the solution given is a FDR. Solution, if you read the paper, my recommendation is on a full depth reclamation. When the lower layers are not inadequately compacted, providing will not work. But again, it was FDR was not in the ministry specification. Now in the 6th revision, we have included FDR. So when the lower layers are poor, then ideal solution is a full depth reclamation. Again, I would prefer to do a recycling of the bituminous layer. I will not use it for the granular layer. Recycling of the bituminous layer, and the lower layers of a base and sub-base can be recycled, used to the FDR, and then this can be brought back and constructed. So alternate rehabilitation should be there. FDR is a good solution. I agree with you.
Thank you, Professor. I think we should move to the next paper now.
Thank you, sir.
This is paper number 742 to be presented by Professor M. Parida, I think. Is there, I think? Nadeem, Sri Nadeem will do it. The paper was written by Sri Nadeem Khan, Dr. Rakesh Kumar, and Professor M. Parida, right? The paper is on time to adopt integrated advanced construction technologies for enhancing the riding quality, durability, and sustainability of national highways and expressways. Over to Mr. Nadeem.
Mic on. Change it on. Good morning, everyone. This paper focuses on the riding quality and durability and sustainability of national highway and expressway using the advanced technologies. As we all know, Indian road network span approximate the 6.5 million kilometer, forming the backbone of national transport. India government has given the project like Bharatmala Pariyojana and Gati Shakti and NIP. The conventional labor-intensive construction method struggle to meet the modern demand. Issue like surface irregulation, poor geometry control, and inconsistent material placement reduce the payment life and increase maintenance. So adaptation of advanced technology, robotic slip paver, automatic slope control, laser profilometer, and 3D imaging can vastly improve the accuracy and efficiency and longevity. Embracing automatic and smart quality control offer long-term gain, better quality roads, and reduce cost and enhance the stability. The performance gap in conventional construction, inconsistent surface smoothness. When the road are paved manually, even a small thickness difference create wave and dips. The only not affected comfort but also reduce the vehicle life and fuel efficiency. Poor geometric control, there are not real data. There are no automatic slope correction. If the road is not level perfectly, water stayed on the surface and the surface slowly damage the pavement structure. And the limited real-time quality assurance, there are no real-time data monitoring in traditional method. Defect are the notice after the completion by then only solution called costly rework. And the impact of the performance gap, the compromised riding comfort. When the road is not smoothly, every vehicle feel it, from a small car to heavy truck. It affect the comfort, increase fuel use, and even at the stress for driver. And accelerated deterioration, the small mistake during the construction grow big over time. Unevenness surface and trapped water uh, weaken the pavement faster, so it's fail long before its design life. And the higher maintenance cost, even though the conventional method may seem the cheaper at the first, uh, the repeated repair makes the costlier in the long run. There are the limitations of conventional highway construction method, as we have already discussed: the inconsistent surface smoothness, inaccurate geometry control, and limited quality assurance, and the high life cycle cost and maintenance. The limited stability and speed, manual process, and labor intensive are error prone. The slow construction pace, unstable for the fast track project. And the impact summary: reduce the payment quality and durability, increase the maintenance requirement and high life cycle cost, compromise safety on high speed corridors, delayed the infrastructure delivery. Emerging the technology in the pavement construction, first is the robotic paver, automatic control system and sensor array, real-time depth control for uniform layer thickness, and the programmable logic control and the GPS integration. The benefits versus the conventional paver: uniform layer thickness with automatic depth control, and the high surface uniformity through the precious control, even the compaction across the entire paving width. And the second one is siliform paver with graded slope control, unmatched precision in shaping pavement profilometer, advanced sensor with gyroscopes and GPS control, consists the cross slope and longitudinal grades. And the advantages are the highly accurate geometry control, eliminates the physical framework need and ensure optimal surface drainage, enable the continuous and rapid paving. And the third one is a laser-based profilometer, high resolution data on surface evaluation, real-time surface quality assessment, and no content measurement technology. It is why it is superior to the conventional method: precise high resolution surface measurement, real time IRI roughness index monitoring, object repeated result free from the human bias, and immediate identification surface of irregularities. And the fourth one is 3D imaging system, full surface digital method using the laser scanner, comprehensive quality assurance and defect deflection, AI based post processing and for advanced analysis. And the advantages are the full surface topographical analysis. It gives us and the real time minor flow detection, easy integration, and productive insight through AI that enhance the data analysis. The integral best practices in the US, the Interstate 80 project, a robotic paver reduced the construction time by 25% and 40% reduction in the maintenance cost over the pavement life cycle. In the Japan, in the Shuto Expressway, automated slip paver paving for consisting the cross slope, superior water drainage, and reduce the surface degradation. And the Germany Autobahn A7, a real-time assessment with laser profilometer, 3D digital surface modeling for defeat prevention. And the South Korea, the Gyeongbu Expressway, integration for robotic system with sustainable material, lower carbon footprint with improving the riding quality. The benefits of the analysis: they enhance the riding quality, it reduces the IRI, lower fuel consumption due to decrease the surface resistance, and improve the driving comfort and reduce the vehicle maintenance, and increase the durability, extended pavement lifespan through the uniformity, better water drainage, preventing the structural damage, and reduce the frequency of maintenance intervention. The environmental sustainability: optimize the material uses and reduce wastage, energy efficient construction process, and lower emission through the faster project completion. and this is also cost efficiency, reduce life cycle cost despite higher initial investment, fewer repair and maintenance requirements, and faster project completion time frame. The integrated strategies for India. First, we have to make the policy framework, a revised technical specification, mandatory ride quality benchmark, and equipment subsidies and tax incentives. Capacity building, training the Center for Advanced Machinery Operation, manufacturer-led workshops, and academic collaboration for the curriculum integration. And the phase implementation pilot project on selected national highways, performance analysis and data collection, knowledge sharing across the stakeholders, and the contractor readiness, flexible equipment leasing options, and public-private partnership, workforce upskilling the initiatives. And there are some challenges also. The high initial investment. We recommended the government subsidized and equip leasing program, PPP also we can do. The skilled labor shortage, we have to run training program and partnership with manufacturer and educational integration. Resistance to change, demonstration project, awareness campaigns, and the case studies. Limited equipment access, equipment rental network, and the subsidized financing options. And the conclusion are the advanced construction technology are essential for meeting the modern road performance demand. Robotic paver slip form system and digital monitoring tools offer the significant benefits despite the challenges, and long-term advantage outweigh initial barriers. A phased multi-stakeholder approach will enable successfully implementation. The future of the India road infrastructure depend on the embracing these technologies. Thank you so much. Thanks for having me.
Thanks, Nadeem. Questions from the audience? Mike DJ, please, Udair.
Thank you, Khan sir. This is definitely an insightful presentation, but my question is something different. Like the time has come for civil engineers to see the civil engineering aspects from a different lens. Like this is not the time to see like cement, concrete, steels. So this is the time of data intelligence and artificial intelligence. So my question to you is, sir, whether there is any initiative undertaken by CRRI, CSIR for the use of artificial intelligence in the construction technology as well as in monitoring the these construction methodologies.
Sorry, can you repeat the question? If you can give me in written, I will mail you the question.
Okay. Thank you.
Thank you so much.
Thank you, Nadeem. Paper was... Another query is from this side. Please, hello, in the front row. Please give the mic in the front row. Front row.
Sir, thank you. CRI actually really contributing to a huge extent in regards to road engineering and everything and all. So the subject matter of maintenance advices to the government of India has been given to them on a quarterly basis or regularly basis, one. Secondly, the audit of the road conditions which are supposed to be handled by NHI or state authority and all. Has they really been told to attend to this? Because you said the road condition, if it is not there, the driver comforts will not be there. Safety will not be there. There will be a lot of complication of the tires and disasters, wearing out of the tires and everything and all will depend on the road construction and all.
if the roads are not been audited properly for the towards the maintenance, you have made a road for 15 years, but the things will get deteriorated. But a person has to get known where the things is getting damaged. So these things are really be lacking in everywhere, whether in the Dwaraka, whether in the Ganga, everything in Bhubaneswar, NH, all these things are being happened. I don't think the digitally things which have been told in the conference hall, these are really percolating to the department concerned, that these are the need of the hour. It is not the making of the road. My sart will be ready. My sart will be ready by the tailor. But if I do not make a proper washing, I don't think I can use the sart again. Thank you.
Thank you, Mahapatraji. Your point is well taken. But I think these new technologies and advanced construction methodologies can be very well used for auditing purposes. But the question is as of larger interest and larger, this thing, and has to be taken care of by the ministry and the CRRI, the ministry. For implementation of those strict audit, this thing. Okay, thank you. Thank you, Nadeem.
Thank you so much.
Now I'll invite the next presentation by Ms. Radhika Parsarthi for the paper number 746, Highways, Humans and Hardware, Why Safe Roads Require More Than Cameras in Concrete. And the paper is written by Ms. Radhika Parsarthi, Team Leader, Special Information Cell, Indian Ports Association, and Dr. V. Rangarajan, Director Research, AVVRON Pune. Over to Ms. Radhika.
Thank you. A very warm good afternoon to everyone, the chair, the co-chair, and the audience present. This discussion is, this presentation rather, is more around the policies and the general challenges that are being faced with respect to road safety. It's less about technology. So we'll start with the first paradox, that is that despite the fact that there are, most of our highways are so technologically rich, why do we still continue to see the road safety being compromised so much? The paradox is that the hardware has sort of grown faster than the human system design. So we have cameras, we have dashboards, they exist, but they lack the proper logic and accountability to show where the road safety fails. Further, what we continue to sort of mix up things is that visibility is not equal to vision. So this paper tries to resolve this to some extent. I begin the concept with a three-level interplay model, where at the first stage is the policy and culture. So what we emphasize here is the Vision Zero mindset, that we prioritize safety before mobility. The second layer, which is on the operational and organizational integration, follows through the policy culture, where we discuss about the concept of operations, which translates policy into procedures. And the last layer, which is that of human and technology, where ITS, the ITS systems actually interact with the drivers and the enforcement. Now, what we have seen is that while India invests heavily on the third layer, which is technology, I think the failure begins at the layer 1 and layer 2. The next, we move on to explore what is this concept of operations, that is the missing piece. It's a standard that is followed in aviation and defense. It defines who does what and when what does technology do when an event is detected. So what happens is that the vendors deliver hardware, but no one defines the operational logic. As a result, the system detects, but the agencies do not respond. I further explore the statement through a case study on the Delhi-Meerut Expressway, which was India's first 14-lane smart expressway. We saw a number of incidents around the wrong way, around fog, around speeding, something which is easily detectable by the heavy stack of equipment and machinery that is deployed. But where we fail is, let's take the example of wrong way, where a wrong way is in fact detected, but there's no patrol or dynamic signage which can respond to the problem immediately. The fog, again, is detected, but there is no variable speed limit integration that allows the action to be taken. Similarly, for speeding, there are radars deployed, but we are still distant from an average speed enforcement system. So basically, it is detection without responses. So it is detection, but it is not translating into safety gains. However, when we benchmark against international best practices, what we can clearly see is that while India treats safety as an afterthought, these countries have hardwired safety into their governance. What we propose through this paper is a result-based policy cycle, very much in line with the typical 5-year plan that is followed in India, where we first set the target. It is tied up with the funding. The targets are measured, evaluated, and the revision follows. And this cycle continues. So, in effect, if the fatality reduction actually lags, the policy should limit the budget and automatically reset the KPIs. It's in alignment with the 5-year rhythm that is generally followed. To make it further simple, what we are discussing here are the three levers, which is outcome-linked funding. So basically, 2 to 5% of the budgets are kept aside for safety and retrofits. The IRAB funding is tied up with the corridors being able to maintain a minimum 3+ rating. The OPEX is further defined by the output. So you pay the ITS vendor for the detection and clearance time and not the count of the equipment deployed. So we must pay for the lives that are being saved, not for the lenses that are being installed. Further, what we continue to overlook consistently is the vulnerable road user fraternity, where we are supposed to define a safe system where these users are not violators, but the design inputs for which we are designing. When I try to put it all together, we try to separate it out into different layers. We start with in this diagram, it's basically the operational cascading of safe systems which are aligning with the National Road Safety Policy. So the first layer basically is the policy and the vision, the authority and the funding coming together. They define the performance metrics, the budget and the risks involved. And this layer is basically defined by the Ministry of Road Transport and Highway and the NRSB. This is a proposal. Now this layer feeds into the next layer, which is that of NSP. The CONOPS is developed here in this layer. The CONOPS is the concept of operations, which I earlier discussed, which depicts the timelines, the key performance indices, and the technical specification stack. The next layer could be that of the NHAI and the state PWDs coming together that translate this into actions. And the last layer, which is the ultimate road user, is the beneficiary of all these above layers. My final slide is that of going down further into the brass tacks, where the National Road Safety Board, which is the strategic apex body, does the oversight for funding, the financial allocation, and further ties the safety outcomes with these two. The next, right under the NRSB, is the National Center for Road Safety Analytics and Innovation. This is the arm that should be looking at the technical aspects of NRSB. It leads the crash analytics, the AI-based risk mapping, data from enforcement, engineering, and health sectors integrate at this layer, It's synthesized to identify systemic risks rather than isolated accidents. And the last is the state road safety authorities, which integrate basically the national strategy into state-specific action plans that become execution hubs. So in this proposed model, what we are looking at, that how the policy drives down from the top, the governance, down to the ultimate road user, and therefore designed to deliver safety as an outcome. With this, we come to the end of the presentation. As I said earlier, that visibility is not visions and cameras don't save lives. It is the system which does. Thank you.
Thank you, ma'am. Any questions from the audience? But in your Eurovision statement, you have not said the users' education, which is one of the most important thing, because I have seen, and many in the last presentation also it was seen, that people are crossing when the red light is there and green line person has to wait or then they crash. So biggest thing is people are, voluntarily not, following the traffic rules. They are deliberately crashing and violating the fire traffic rules. Because of those, the accidents are happening, at least in the urban area.
I'm a road safety auditor. And one of the things that you mentioned is about the incidents. Okay. Now, with every one incident, I do not know what the statistics are, there are about near fatalities. The incident would also include the near accidents. Because I stay in Bangalore, one of the most vulnerable city for road accidents, in one of the most busiest area, and we as citizens have been trying to help the police, even being the road safety auditor, and things don't get implemented on the ground. You know, leave aside the system. So what I was saying, that while the policy and the framework is good, the bigger whole are the state level agencies where they have to figure out how to spend those 200 crores and then to do all sorts of things. Second is the incident which is to be taken. One are the police will note only fatalities. If you go to any, I've done few accident investigations. So they will note the fatalities. But there is a lack of noting the near accidents or near fatalities for appropriate improvements.
True. And that is what, in the paper, I have deliberately tried to explore this aspect, where the enforcement is, the agencies, the police agencies who are only focusing on fatalities should also, along with the state machinery, have a dedicated. So if you went through the paper, the last part actually proposes an integration layer, which is that of an analytics, where the police, the enforcement, and the health department feeds its data for an actual crash analysis, which includes near misses, not just fatalities.
Yes, ma'am. It was great to listen to you regarding safety, because it's one of the most first priority. One thing is, like you mentioned that over 2 to 5% of the budget of the NH and state highways is suggested to be involved in safety measures. You are not, yeah. You suggested that 2 to 5% of the budget of NH and SS should be given to the safety measures. But what I suggest, we need to learn from other countries. Like in 2024, Vietnam passed a bill. It was like a public involvement in safety measures. Like people can make the videos, give it to the government through social media or directly, and 10% of the fine goes to the public. In fact, in India, we basically lack in enforcement. It's not that people are not aware, but we need to enforce it. In fact, no need to spend our money, because we are not so rich country, so no need to divert those money. But directly, if we implement with this way, surely we can reduce to something like 80% for sure.
Correct. Absolutely in agreement. I think that comes from the fact that we still don't, the advisory body still doesn't have the clause. Let's say it's not still an
Mic
act,
in
it does
front.
not have the judicial or the backing, a legal system backing to actually enforce. So there are multiple agencies coming together, but nobody has the ultimate authority to implement. So unless probably it becomes an act, the National Road Safety Act, maybe this legal backing would never be there, and so the ultimate authority will always be lacking, including that of funding, including that of allocation.
Ma'am, Parthasarthi ma'am, I'm really thankful to you. You have brought out nearly 75% of the road safety into your project. Only thing is that it is not reaching to the ear of the officials or policy makers over here. The system has to be brought out from very beginning and all. The road education, road engineering, ARAI, who are the authority to make the vehicles, safer vehicles on the road.
Correct.
That has not been told in anywhere in the IRC. And no ARI people are there. They did not present any paper over here.
True.
So naturally, lot of things is being getting lost in the wind. One. Secondly, in the state of Odisha, when I am working from last 22 years, the mindset of the officers concerned who are sitting on the chair to deliver, they are yet to understand what is the road safety meanings to them. Each and every family gets lost on the road, but they cry only after it.
True, true.
Recent incident of Kurnool.
Correct.
It has given a great message to India. But the thing is that high-end vehicle, Volvo, also that is also not safe. Why? Because the driver concerned who is driving it, he has to be fast safe. It is not the vehicle. The roads, which in the state of Odisha, no audit system is there with them. Because the audit department not only to look onto the road, they have to implement and give a funding requirement on the system. Then only a vehicle will be completely safe. And regarding education, you have already given on the education is the past foremost, but who is going to bring out a systematic on the government level? This is my appeal.
Thank you, Mr. Mahapatra. Thank you, Ms. Radhika. The points brought out by Ms. Radhika is the hardware has to capture the various other parameters as well to realize the accidents and correct it. That has to be looked into, and the further reading can be done in the author's paper. And if any query is there, you can ask through mail. You want? Please give a mic to her. Yes.
Yeah. Hello, ma'am. It's a wonderful presentation, and you have brought to light a very important aspect which is concerning to all of us. But I don't have a question, I just have a thought that though, let's say everything is in place, the policies, the action, everything, implementation, but I think it should begin at the very beginning, that our students should get education of road safety, how to drive, what are the rules. Now we can see when we get the license, there is a test, everyone just ticks on that test, nobody follows that, and you get a license. So our licensing, when we get a license, the rules should be strict. Our drivers, sir mentioned about a Volvo accident. So our drivers should be trained very well, and I think it begins at the very basic level, even if all the policies are in place, but if people are not following or people are not taking charge of their own lives and of everybody else's lives, then I think everything will be again a zero.
I agree with you, madam. But I mean, maybe I would, at the cost of taking time of the other speakers, I would hate to break this news to you, in fact, that there is something as a Cochrane review, which is a detailed study done over 30-40 years of data that actually proves that no education has ever yielded road safety. That is the truth. In fact, it has negative outcomes, that you are actually educating youngsters about traffic. which they are not tuned to process. In fact, it causes them to start driving before they are authorized to drive. So unfortunately, the education really does not have a direct impact on the road safety. But yes, we can reserve that conversation outside. Thank you.
Thank you, Ms. Radhika. Now I will invite the next speaker, Professor S. Shankar and Ms. Pavani J. for the paper on influence of cement content and curing technologies on strength development of fly ash cement supplies full depth reclamation mixes with RAP. Over to Professor S. Shankar.
Dignitaries on the dais and off the dais, a very good afternoon to all of you. This is the paper jointly authored by 3 authors, one by a MTech student and another professor from the RGUKT Newswood and myself from NIT Warangal. So the topic is on the influence of cement content and curing techniques on the strength development of fly ash, cement stabilized, full depth reclamation mixers within a reclaimed asphalt pavement. So this is the brief presentation outline you can see. Let me introduce this topic, actually why we are concerned with this topic, and rest of the analysis part and other things will be taken care of by my co-author. Sir, as you are all aware, I feel that if at all is to be written with the golden words in Indian history, I say that is a millennium 2000, before the 2000, after the 2000, as the rural road development is concerned. So 1947 to 2000, 78 years of independence, there were a different emphases in the different plans, different schemes of the government about the connectivity and the accessibility of the rural roads. But actually after the 2000, today if you see the 6.36 or 6.33 million kilometer of rural entire road network, a rural road contributes about the 75 to 80% of the total road network. So this has happened, and this is possible with the engineers like all of you who have contributed to these things. And we know that once the Pradhan Mantri Gram Sadak Yojana started, there is today in the country, I'm sure, go to the any state, definitely there is no village which is not connected, which is not an accessibility. That's a good thing. At NIT Warangal, we have done one study during the 2013, 2014 and recently also. So you know that in 2000 PMJs was started, the average cost of the kilometer this time 2000 to 2030 is not less than anywhere 25 to 30 lakhs of kilometer per average kilometer. And if it is a little more with CD works, cross-drainage structures, is about another 5 lakhs or 10 lakhs. But today in the country, the rural road average cost of the construction is not less than anywhere 100 lakhs. We are the NIT Warangal is in STNPT of the PMJSY. So that is the scenario. What is the reason? The reason is one side, the most important part is the materials. So as rightly said in the morning, the things Professor Veeragans are also in the FDR. Now these roads are constructed 2000 to 2025 today in the different schemes. Phase 1, Phase 2, Phase 3 and Phase 4 is running now. The roads which are constructed during the Phase 1 and Phase 2 has come to the major rehabilitation. So if at all do a major rehabilitation, you need a materials. So I was reading last 6 months or somewhere back, there's a one statement in the Hindu paper saying that the rate at which we are trying to exploit the natural resources currently in India, if this continues, maybe another 250 years, the entire planet can be blown up. So how long we keep on excavating or exploiting the natural resources? There is a high time that we need to use a marginal material, an innovative material, a sustainable material for the different rehabilitation, upgradation, new project of this. So in that aspect, we thought that why don't we use mechanism? So we have done that. That is a background. So we have used a RAP, reclaimed asphalt pavement from the distressed pavement and other materials to stabilize the FDR mixes. Of course, everybody knows what FDR is there. FDR is in a kind of is one of the rehabilitation kind of technology, but it is not alone the mantra, it is not alone the technique, but other kind of techniques also that we need to explain. But it has got its own advantages, it has got it in terms of the cost point of view. So we were reviewing a few literature from the internationally and the national in the country, so we could find out the salient point from the literature that mixers with a 40% wrap need at least 6% of cement stabilization in FDR. So increasing the wrap content, there is a decrease in the maximum dry density. And if the OMs increases with the wrap content and the limit of cement, for the all practical purpose limitation, the limit of cement in the FDR is about 9%, which is has been told by the one of the study conducted in 2024. Fly ash and GGBS backed geoploy can also be cement in FDR, and this binder shows a very good durability properties. So converting the old pavement to a recycled base is in a sustainable practice. So cement slurry gives a slightly lower strength than the dry cement. So however, slurry improves the workability during their field applications. So finding out these gaps and necessary things, we have been formulated this study with the following objectives, saying that we need to evaluate the strength characteristics of the FDR bases stabilized within a wrap, natural aggregate within a chemical additive of fly ash and the lime, and also to investigate the influence of various curing methods on the mechanical and the durability properties of FDR bases, and also to assign the finally strength development of FDR bases containing the reclaimed asphalt pavement within a different curing method of things. So with this brief introduction, I now request my co-author, the Pavani is an Intech student who has recently completed, to continue from this for the further study results. Thank you all.
Good afternoon, everyone.
You have left only
Pavani.
6.5 minutes.
Myself, Pavani. I am from IIIT Nujividu and my dissertation completed in NIT Warangal. And the FDR stabilization started with the different types of materials like a wrapper, and we got that material from Eturu Nagara Mulugu district from Telangana state. This is a deteriorated asphalt rural pavement material. In FDR we have the different types of stabilizations like mechanical stabilization, chemical and bituminous stabilization. Through mechanical stabilization we have added the natural aggregates up to 30%, and through chemical stabilization we added the cement and fly ash, class F fly ash and 53 grade cement we used. And final mix proportion is 70% of wrap, 30% of natural aggregate, and 15% of fly ash, and 2, 3, 4, 5% of cement content. Using these mix proportions, we have conducted the modified Proctor compaction test for determination of OMC and MDD. After that, we conducted the UCS strength test for determining the optimum cement content. Using that optimum cement content, we conducted the different types of tests, and all the tests having the different curings with the different curing periods. These are the basic engineering properties of the materials. We conducted all the tests on this material and according to the test protocols, but they got the good results according to the MORTH specifications and satisfy all the limits. This is the gradation curve according to the cement stabilization according to the MORTH table 404, and this mixed proportion of 70% of wrap and 30% of virgin aggregate matching all the limits according to the specifications. This is the compaction characteristics we can determine through the modified Proctor compaction test. At every percentage of cement content, I got the 8% of water content with a different maximum dry densities with a different percentage of cement contents. So finally, using that optimum moisture content, I have casted the cylindrical samples to find out what is the UCS strength of sample at every percentage of cement content. So for CTB layers, the minimum UCS strength is 4.5 MPa to 7 MPa, and the 5% of cement content is matching the limits, and it is giving the higher strength is compared to the other cement contents. Here the different curing methods: water curing, temperature, membrane and lime immersion curing. Water curing is a very conventional method in India, and for water curing we can use the gunny bags and jute bags, and we need to keep it into the wet condition. Next is the temperature curing. Curing of concrete will be achieved in wide range of temperatures. The hydration of the cement is slow at lower temperatures, rapid at higher temperatures. We used the 40 degree of temperature. And next is the membrane curing. Membrane curing is used where the water is not available, and it is very hard to take the water, and where we're not ready to take the water from some places. In kind of situation, we can use the membrane curing. In membrane curing, we have two types: solid membrane and liquid membrane. Liquid membranes are generally not available. And coming to the solid membranes, polyethylene sheets like plastic and rubber compounds and waterproof papers are there. And next is the lime immersion curing. For lime immersion curing, we used to, for 10 liters of water, we added the 250 grams of lime. And basically lime is having the calcium hydroxide. When it is mixed with water, it produces the calcium ions and moisture. Because of these moisture ions, it continuously produces the hydration of the samples. And the calcium ions are reacts with the silica and alumina which are presented into the fly ash. And these are produced the calcium silicate hydrate and calcium aluminate hydrate. And these compounds are helps to make the sample very strong and denser. And next is the UCS strength. Using 5% of cement content, we conducted the UCS strength. If you observe the results here, the lime immersion curing is giving the highest results compared to the other curings because of continuous hydration and calcium ion supply. And next is the water curing is giving the good results. Here, if you can observe how curing period is increased, the strength of sample is also increased. Next is the indirect tensile strength test. For this test, we casted the samples with 100 mm dia and 65 mm depth. And we can calculate the ITS using this formula 2000 pi by P by pi dt. P is the breaking sample load of breaking sample, and D is the diameter, T is the thickness of the sample. Here also lime immersion curing is showing the highest results compared to other curings. And indirect tensile resilient modulus MR test. Basically, resilient modulus is a stiffness parameter. We have to determine what is the stiffness of the material under the repeated loads. And we can take the 10 to 15% of ITS failure load into the MR. And here the cyclic load pulse was applied to the frequency of 1 Hz, and the cyclic harvesting load is lasting 0.1 second. But in MR test, the membrane curing is showing the highest results because of continuous curing of up to 56 days. So moisture retention in membrane is showing the highest results. And finally, durability test. Durability test is a complete wet and dry test. We can do the test is up to 12 cycles. In durability test, the water curing showing the less percentage of loss compared to the other curings. Here is the how curing period is increased, the percentage of loss is decreased. Flexural strength test. The test is also called as the bending test and the modulus of rupture test. In this test also, lime immersion curing showing the highest results because of the continuous hydration and calcium ion supply. And finally is the conclusion. The mixed proportion of 70% of RAP, 30% of natural aggregates, and 15% of fly ash, 5% of cement content is showing. When the water is added extremely, then maximum dry density is decreased. In all cases, in all tests, the lime immersion curing is showing the highest results because of continuous supply of the calcium ions and hydration and moisture. And in some cases, membrane curing showing the highest results because of moisture retention in membranes. In durability test, the water curing showing the less percentage of loss because of continuous hydration. Thank you. Thank you.
Just one question, quick. We have already overshooted the time. If anybody has. Okay. Thank you, Ms. Pawni. I think they can interact with you if they have any questions during the lunchtime. Okay? Thank you. Next, I'll invite next speaker, Dr. Etop Lego, Director, Seismic and Structural Consultants Private Limited, Itanagar, for the paper on soil structure interaction modeling of interior abutment bridge in cohesionless soil and practical implementation. Over to Dr. Lego.
Very good afternoon to chair and co-chair and the audience. I'll just make my outline to presentation will be just introduction to integral abutment bridge, which you might be knowing, all of you might be knowing, then a brief literature review, how to model soil structure interactions, in integral abutment bridge, and modeling of integral abutment bridge is a practical implementation and summary conclusions. As you know, integral abutment bridge designed without movable joint at the abutment, and if you have a fire, you can have a, if you have a flexible fire, you can integrate the deck with the fire, and if you have a rigid fire, you can have a bearing, but the deck will be integrated to the abutment. The practice of integral abutment is a departure from the conventional bridge design, where we have joints in the fire and abutment using expansion joints. This is the integral abutment bridge concept. This is called semi-integral abutment bridge concept. So this is also very good because it protects the bearings and no percolation of water is allowed to the bearing. This is the integral abutment, photo of an integral abutment bridge. So if you have an integral abutment bridge, you will have, you will not have frequent maintenance of bearings like this. So your bearings will be protected, or in single span bridge, you will completely avoid provisions of bearing. So you will not have any maintenance problem for bearing. So advantages is economical, and we can have a single line of file because it restrains the earth pressure from one side is restrained by the earth pressure on the other side. So you have to design only for a vertical load on the file. So it's act as a redundant frame, so highly good in resistance, seismic resistance. So the modeling is that we cannot go for the single degree freedom system modeling of the bridge. So we'll have to make a full 3D model of the bridge. So you'll have to model the soil infrastructure interaction, soil pile interaction, and abutment backfill interactions, because the expansion contractions causes a lot of forces due to the temperature. Expansion and contractions due to temperature causes a lot of forces on the bridges. So the pile is the most popular foundation for the integral abutment bridge because of its lateral flexibility, and hence I will be concentrating on modeling of the interaction with the pile only. So this is on axial load and another is in lateral load. So in the modeling of the axial load is called as load settlement curve, and then this is based on the study of Bhubaneswar. The recommendation is already available in the American Petroleum Institute, that guidelines for design of offshore structure. So we have got a recommendation for load settlement curve based on the ratio of displacement, settlement and depth of pile, and then force generated, and then maximum force that can be generated, maximum bearing capacity that can be generated. So for the frictional, sub-frictional forces, we can use this, of course, the increasing of the frictional forces with the depth will be limited up to 20D of the pile, which is also available, prescribed in IRC 78. So we'll calculate maximum frictional, sub-frictional that can be generated, and then we model the interactions curve. Actually, API gives a bilinear curve. This American Petroleum Institute, they give a bilinear curve, and then Bhubaneswar has given a relation which is multilinear. So if we compare these two, of course there are some other curves also given by other authors, but I am concentrating on these two. We see that in the small displacement, the API curve over-predict the resistance. So bilinear curve is better. So generally, I have adopted in the bilinear curve in the modeling of multilinear curve in the modeling of the integral abutment base using the relations given by Bhubaneswar. Then this is the fundamental equations for lateral load POI curve, that is the lateral interactions model using POI curve, developing relations soil resistance with the displacement, lateral displacement. Of course, the practical formulation which we adopt in practice in design is the modification done by experiment and then mathematical curve fitting. So that becomes a very smooth or easily adaptable curve. You see, the important one is there is two theory in the lateral resistance of the pile. This at shallow depth, generally we assume that there will be wedge failure. This is derived by Rich in 1964, and we assume that a rigid cylinder is translating into the soil, that the cohesionless soil, and passive wedge is generated, and they calculate what is the resistance at this shallow depth. The second theory of failure is at the deeper level, the pile is, the soil is assumed to be failed by flow because it moves around the pile, and then the resistance is calculated considering the resistance of the flow using shear strength. This is the PY curve was generated by Rich. This is segmental curve, we call it. And if you are using L pile now, I think this formulation is available in the L file. But in design of this, we found that the hyperbolic formulations as given in API is most easy to use. And this has been recommended in API because this O'Neill and Murchison, they have studied the test of lateral loaded file, including cyclic and static loaded, and then he took the results and then analyzed using 4 POI curve formulations, and then they compared what is the predicted using theoretical formulations and what is the result of the test. And then they found that the hyperbolic formulations, which was formulated by Parker and Rich, is found to be giving least error when compared with the experimental results. So this hyperbolic formulation has been adopted in API, and then this can be very easily used in design office. Then calculation of PUS, that is shallow depth forces resistance and deep depth resistance, has been modified, simplified. Of course, the original formulation was very frightening, so that has been modified, and then it becomes very easy for the design office, and this can be adopted, and this is adopted. So C1, C3 is given in figure form based on the frictional angle of frictions of soil. So it can be taken directly from this, and then we can adopt the interaction modeling. So this is the PUI curve as per hyperbolic formulation. So then abutment backfill interaction come. The abutment backfill, they say that when the wall is pushed towards the soil, generating passive pressure, it after a certain moment, it creates limiting passive resistance as per Clow and Duncan. So even if you continue to push, the passive resistance remain the same. Using this, I think abutment backfill is modeled. So one is based on England, experiment by England, say B42 is adopted, and I think even mentioned in our IRC SP 115. And then another is the recommendation of mass highway manual 2000 poem. This is also based on prototype test on prototype abutment, and then the recommendation of England in BA42 is also based on the test on the retaining wall with hinge at bottom. So if the 0.43 is replaced by Kp, K0, based on which is as earth pressure at rest depend on the frictional angle of the soil, So we can just modify it and compare. You see, the mass highway, it gives a it coincides with the theory that it remains constant after certain moment, and then BA42, it continues to rise. So here we have adopted mass highway recommendation, which is very simple and then almost accurate. So this is how we implement the abutment backfill, then we PY, then vertical TZ curve, then QZ curve. So this is the bridge I have considered in modeling. We have designed it. The soil at site was matched with the as per the properties of the site, soil at the site. We have taken the matched the properties like this. Then this is the QZ curve, that is load settlement curve. And in the abutment, we have got that component of surcharge load. That is why the forces in abutment is more. Abutment is more in the abutment file. This is the TZ curve. The positive side is axial resistance, and then the negative side is pull-out resistance of the pile. This is the PY curve which we have adopted in the modeling. And this is the abutment backfill interactions. So the active side we have taken constant after the certain. So this is the bridge. So if we see the dynamic, model analysis and dynamic characteristic, you will find that the longitudinal acceleration that manifests at almost at 200 mod. So this means that the bridge is very, there is no risk on the bridge in the axial. There is no seismic risk on the bridge on the axial direction, but in lateral direction, I think the bridge can fail in lateral direction only. So vulnerable in lateral direction only. So where we have got very more numbers of load resisting element. So soil, this is the passive resistance. I think API is very good. Backfill integration, we can use mass highway recommendation. And then pre-vibration says that the bridge is very steep response in longitudinal direction. And soil structure interaction modeling and implementation is feasible in modern software. So this is the bridge we have already implemented. I think some of the research institute can help me in documenting this bridge for monitoring the behavior. Thank you very much.
Thank you, Dr. Lego. Any questions? Just one question, because we have already overshooted, otherwise you can discuss during the lunch time.
Good afternoon, sir. Myself, Aruna Tageja, Bridge Engineer in NHI. I have two questions regarding soil structure interaction, which is being followed nowadays as per our latest codal guidelines, IRC 114. So we have to understand how to use 2911. Earlier, all pile and pile cap design and the transfer of forces from the pile cap to the pile was done considering a hinge connection. And we have been following that detailing since quite long. And when this soil structure interaction has been introduced now, we are modeling, we are not giving any hinge connection between the pile and pile cap. It is a fixed connection, but we are not doing any change in the detailing. So are you doing any change in the detailing to achieve a fixed connection between the pile and pile cap, or we are following the same as we used to do earlier? And what is the role of 2911 in this interaction? Or it don't have any role to play? And in our 2911, it is mentioned for soil structure interaction, we have to refer to the special literature. And when we refer to the special literature, it is mentioned the increase in the development land to achieve this fixed condition between the pile and pile cap. So have we done something to understand that, or you suggest anything for that? Thank you.
Now in the pile and pile cave, we do ductile detailing, and then the displacement because of that moment curvature, say yield curvature, we generally when I check with yield curvature. So what is the allowable displacement based on yield curvature? And then if the displacement I expect is lesser than the deflection that is available with yield curvature, then we feel that the structure, the modeling is okay, the design is okay. So we restrict like that. So if we do ductile detailing.
So sir, now as per 114, we are not trying to give ductile detailing in the piles.
And
we are trying to give at the fixed pier bottom. And this is generally a wall type abutment which you have shown. So how ductile detailing will come in the pile here, and how to achieve the real condition of the model for a fixed pile cap and the pile in the detailing of the reinforcement for this calculation.
One thing, in the abutment, in the pile, the displacement will be, the ductility of the pyre will take care of the displacement, because or if that is not sufficient, the pile will also displace. And abutment pile cap interaction we are not taking, because generally we place the pile cap at low water level, top of the pile cap at the low water level, so the interaction may not happen. And then we put steel sheet around the pile for protection of the pile. So that again we do with a CFT type analysis. Concrete field tube, we take strength of the concrete field tube, and then we analyze what could be the displacement that could be allowed. So based on that, we decide how much span you can allow in an integral abutment bridge. So I'm concentrating on that, on the integral abutment bridge. And in abutment side, generally abutment is very rigid. So displacement is not expected there. Yes. So your displacement is, rotation is expected with the pile joined with the cave. So we detail that, we allow the pile to penetrate inside the, up to the penetration length as expected, as per the literature.
What is that penetration length? Are we following earlier codes? Because earlier it was a hinge connection, now it is a rigid connection.
I am following the literature, literature on integral abutment bridge.
Okay, so what is that length?
Where they, no, exactly, they give some exactly, some calculations. Embedded length is to be calculated.
Okay, okay, to achieve this fixed
You
connection.
cannot arbitrarily put 3D, 4D like that.
Okay.
It has to be calculated based on the force.
Okay, thank you, sir.
Good afternoon, sir.
Yes.
Sir, actually, I have a query. Like, while modeling, you have used spring dashpot elements at connectors at nodes. Why use that configuration only? I mean, in parallel. And the other thing is, you showed one characteristics of force versus displacement, which was having, I think, S curve or sigmoid curve up to peak, like a curve was there. So can you highlight, shed some light on these 2 points?
That dashpot, which is the material damping. That is the material damping of the soil. And I am not taking care of the far field model. Far field, that is because we can take it, it will increase the displacement, but the nonlinear model itself, the short field, near field model itself is okay. So for normal analysis, we use up to date, and the dashpot which we have shown is the material damping of the soil, not other than that. Then if you have to make a detailed analysis, you will have to consider the far field element also, which is a linear spring. So that you have to calculate separately and attach with the, in parallel with the, this non-linear spring. So I am using only this is for implementation, not for assessment.
Hello, sir. You have combined both the behavior of the abutment and the superstructure, is it?
Yeah, it is combined.
Yeah, so normally, then if there is any behavioral change in the abutment, then it will be transferred to the superstructure. Then if there is any failure in the superstructure, it will affect the abutment. So, whether this concept is, it is...
Actually, while designing, we'll have to allow the allowable settlement, induce a movement in the girder, and you design your girder considering all those things. Because you have to allow the allowable settlement. And then generally, when you design a file, taking to the hard state settlement doesn't happen. But while designing the girder, we allow the allowable displacement, allowable settlement of the file, and consider the moment induced, and then design the girder.
Okay, I think we have come to the conclusion. Thank you, Dr. Lego, for the modeling, for analysis of soil interactions, soil-pile interactions. Thank you so much. With this, the last paper, I conclude the session, subject to further remarks by my co-convener. Thank you.
Actually, today we had very nice presentations, 5 nice presentations, in which we have listened from Professor Bir Raghavan regarding the premature failure in highway pavement, and the result of forensic investigations reveals that pavement warrants a costly major rehabilitation within a year due to poor quality of construction. So, if we can improve our quality of construction, then we can reduce our maintenance cost. Then Mr. Nadeem also throw light on the technology that will not only improve the riding quality but also durability as well as sustainability. Similarly, Ms. Radhika, she has given a nice presentation with an example of Delhi merit case study. But unless we change our mindset, we the users, the drivers, the commuters who are using the road, unless we change our mindset, actually road accidents cannot be reduced. Because of whatever safety measures we are taking, unless we adhere to that, that will not be fruitful. Similarly, Sri Pavani has given a presentation on influence of cement content and curing technologies, which is also a demand of the day. And our last presentation, Dr. Alok Topo, he has given nice presentation and of the soil pile interaction in case of our integral abutment bridge. So with this, I conclude my remarks.
Okay, thank you, delegates and the fellow speakers for nice presentations. And I thanks the IRC for arranging this session, for disseminating the knowledge which has come up from the research papers and which will certainly benefit the fraternity for betterment of the highway projects. Thank you so much.
Thank you so much, respected chair of the session and the co-chair of the session and all the presenters. Well, time to felicitate all our respected presenter by our respected chair of the session, Shri I.K. Pandey sir. So, first requesting Professor A. Veeraraghavan sir to please step forward, and requesting our respected chair of the session, Shri I.K. Pandey sir, is going to felicitate him with a memento. Expecting some clap from the audience, definitely. Next, our chair of the session will felicitate Shri Nadeem Khan ji, requesting him to please step forward. Next, requesting Ms. Radhika Parthasarthi, Team Leader, Special Transformation Cell, Indian Sports Association. Thank you so much, Chair of the session. Thank you. Next, would like to request our co-chair of the session, Engineer Dukhabandhu Behera sir, is going to felicitate Professor S. Shankarji with a memento. Next, requesting Shri Pavni Ji to please come forward. Thank you so much to all the presenters. Now it's time to felicitate, and for that would like to request Engineer Pravash Kumar Maji, Additional Chief Engineer, Work Department, Odisha. He's going to felicitate our respected chair of the session and the chair of the session. So before that, we have Dr. Atov Lek, Director SSME, Structural Consultant Private Limited, Itanagar. Sir, please come forward and receive the memento. Now requesting Engineer Pravash Kumar Maji sir to please come forward and felicitate our respected chair of the session, Shri R.K. Pandey sir. Chair of the session, Shri I.K. Pandey sir, thank you so much for all your valuable time and words. Now requesting Engineer Pravash Kumar Maji sir to felicitate our respected co-chair of the session, Engineer Dukhabandhu Behera sir. Thank you so much, respected co-chair of the session. Thank you so much, Prabhas Kumar Maji sir. And with this, we are just winding up the technical session 15. Thank you so much once again, the chair of the session and the co-chair of the session, and of course other presenters. Thank you so much. Definitely we will capture this moment through a photograph.
I'll share screen. This.
You start sharing it.
Okay, can you see my screen?
Yes, sir. We can see the screen.
Okay. Yeah, first of all, good afternoon to everybody, including chair and co-chair and my fellow highway colleagues. I'm sorry I'm presenting from Jaipur. I have been attending many IRC sessions in the past and had presented 7 or 8 formal papers. So I'm going to miss you in person this time. So please excuse for me that. Now, the title of the presentation, as you can see, is Troubleshooting of Bituminous Payments Worldwide Experience. Now, if we have a road like that, then we don't need any troubleshooting. Life will be very simple. But fortunately, we do have bituminous payments throughout the world, and sometimes we see premature failure of these bituminous payment, and that's why we need some troubleshooting there. Now, I would like to share this is the first ever textbook ever published in India on bituminous road construction in India, and it is very comprehensive. And as our honorable minister told day for yesterday, that we need recycling to cut cost, and this book has the largest chapter is on recycling. So there are many chapters in this book, and we got to know all aspects of bituminous road payment before we start troubleshooting. So I recommend that we do read all the material about bituminous payments. I had the privilege of investigating many premature failures of bituminous payments across the world, including India. As I said before, the knowledge of payment materials, mixed design, and construction procedure is helpful. Obviously, the experience is also very helpful. So, my presentation is divided into 3 parts. First is the general approach for troubleshooting, which I've developed. And then there are 2 case histories I'm going to present. So 3 parts
Excuse me,
only.
sir. The slides are not moving. We are still at the title slide.
Is it moving now?
You need to move. Yeah, it's moving to the second. Yeah, your book. We can see the cover page of your book.
Okay, then after that, this one?
Yeah, it's now moving.
Okay. Is it moving now?
Yes, sir. Yes. Please go ahead. It's moving.
Okay. So first I'll talk about general approach for troubleshooting. Some of that I have developed over the years. So I'll describe that. And then I'll talk about shooting of 2 case histories only. The book which I showed to you before has 8 case histories. So that's in the last chapter. So they are all very interesting, like very much like detective type things, So interesting to read. So I recommend you to read the last chapter of that book. So the general approach which I do was that I select a representative 500-meter long poor section which is showing distress such as raveling, bleeding, rutting, and cracking. any of these or combination of all these. So I select a 500 meter. I'll show you the plan in the next slide. Then I also select a 500-meter section which is relatively free of distress, which I'll call it as a good section. What might have been a little bit better than the poor, so I'll call it fair. So from the comparison of the test data, which includes mean and standard deviation of both the sections, usually the cause or causes become evident. For example, if the standard deviation of one test section is larger than the other one, that shows that there's a lack of good quality control on that project. So let me show it here that I have a good or poor test sections here and 500-meter length. So I'll take 5 cores in equal distance, and then I'll also take pits at the edge of the pavement. These pits will be used to test the subgrade GSB and WMM. Near these cores, I'll also have a 18-inch 80 by pit made by using a jackhammer, so I don't add any water in there. Now in this case, you can see that one lane I have chosen is near the median because that's where the heaviest traffic is occurring in India, unlike any other countries in the world. So we have to sample the lane which carries the heaviest truck load. So personally, I would like to see that such signs should be posted every 5 kilometers on 4-lane Indian highways. Very easy, very simple sign. Trucks and buses should use the left lane, and cars should use the right lane, which is not the case in India, unfortunately. That's why we have so many accidental deaths, especially when overspeeding. Lane discipline is very much important. So I'm showing some pictures here that we have to take course. We also have to take sample of with the jackhammer so that we can get sample to test the moisture content, because moisture content is very important to find the percent saturation of the voids. Also, this sampling will give us extra material for the theoretical maximum specific gravity, which will be used in the analysis. And also, I can see the stripping if there is any. With the core, it's not possible to see which layer is stripping or which layer is not stripping. So it is multifunction to take a sample with the jackhammer. Now here you see a coring operation because cores we do need to get the volumetrics calculated. And again, you can see here that this is the lane carrying the heaviest traffic near the median. Now here is a very rare picture. There are 3 textbook stages of stripping visible on road surface. First, appearance of fines. You can see here, you can see the whitish, the appearance of fines. And then we see flushing. The bitumen is coming up to the surface. And then we see a pothole. I was very lucky to get all these stages of stripping in one picture. Sometimes we just see fines and we see pothole. There is no flushing. So, but these are the stages, because what happens is that if the stripping is taking place in the binder course, then after the bitumen film is detached, the fines are exposed, and the fines are brought to the surface by moisture or moisture vapor. And so we see the fines here first here. Then after the fines have been brought up, now the aggregate is exposed, so the bitumen which has been detached, that starts to be brought up to surface by moisture vapor or moisture. So we see flushing. Once you see the flushing, now the moisture cannot escape at all. So after flushing, the pothole develops very rapidly. In other words, the stripping starts to occur very rapidly. So this is what you see in this here sample from jackhammer. You see this stripping of the it's not a white aggregate, that's why in the blackish aggregate you don't see stripping, but you can see here to some extent. What I have developed in India is that a crude field permeability test, which I called grease ring test, because it's not, we don't have access to the field permeameter here in India. So what I just make a grease kind of wall here, 9 inches or 12 inches diameter, and put 12.5 millimeter water, like half inch of water, and then measure the time it takes for the water to penetrate. And thereby I can know relatively which surface is more porous than the other. I've seen that the premix carpet really absorbs water very fast, and if we have a BC, bituminous concrete, the water can stand for forever. So, having discussed the general approach, now let me talk about two case histories. One was in Australia, and the other one was in Europe. So I'll start with the Australian one. There is a Hume Highway just south of Sydney, on Sydney-Melbourne National Highway. Now let's take a look at all these composition of the overlay, because we have to know these to keep in mind how the trouble occurs. So the overlay work was performed on this highway in June 1993. 80 millimeter thick dense HMA, hard mix asphalt, was at the bottom. Then over that they laid 35 millimeter thick dense hard mix asphalt on the top, and over that we had 30 millimeter thick OZFC, which is open graded friction course, very highly permeable, similar to previous carpet we have in there. So after these three layers were put in there in the overlay, they started to see the potholes in southbound lanes in February of 1995, primarily on the left slow lane where the trucks were plying, just 20 months after construction. So the question is why? That's the problem we are going to solve here. The other thing was that no potholing in the northbound lanes, where the same contractor, same overlay, everything was same, was constructed at the same time. And I'll get to that in the next. So the question now is that why we have the potholes in the southbound lanes. And here you can see the picture of that expressway from Sydney to Melbourne, and you can see the potholes are there in the left lane, only where the traffic is heaviest. What I saw on that project was that there was a chicken wire or alligator cracks were there, through which the fines were coming out on the surface. You saw my previous slide where fines will come out, because of the moisture vapor, and then a pothole will develop at that place. So that's why I suspected that on this project some sort of a stripping is taking place in the binder course or the surface course underneath. Mostly stripping starts at the bottom in the binder course. So I asked them, they had a milling machine nearby, so I requested them that why don't we bring a milling machine here and mill it off layer by layer, so we can obtain samples to find the saturation level and also see what's happening in there. So the milling machine was brought in there, and you can see here we have made a big cut in there. Part of the overlay was also on the shoulder. So that's why we have milling done also in the shoulder. But as I expected, there were no potholes in the shoulder area because there was no traffic. And for stripping to occur, we not only we need moisture, we also need traffic. So there was no traffic on the shoulder, so no pothole in there. And when we took out the sample of the binder course and the surface course, we saw a lot of stripping there. And I'll discuss the layer-wise system later on. And here you can see here in the top big, there is the binder course where the stripping is taking place. And at the bottom you see some samples where the stripping has taken place in the wearing course. So let's talk about construction of the Hume Highway. I gathered from them this is what happened. They, they did use basalt coarse aggregate and crushed gravel fine aggregate. Now both are susceptible to stripping. And I found out that ineffective liquid anti-stripping agent was used. As at that time, we were seeing more of the case histories of stripping throughout the world, and liquid anti-stripping agents were being developed at that time. So at that time, I think the hydrated lime was the best solution to take care of the stripping problem. The third thing I found out from the people in charge of construction was that the OZFC, open glitter friction course, which is highly permeable, was placed immediately after the surface course, which had interconnected air voids. In other words, it has not been densified by the traffic. So the water from the OZFC, which was highly permeable, that is the purpose of the OZFC, easily penetrated both the surface course and the binder course. I'll show you the cross section here. So you can see in the top road surface, OZFC has 18 to 20% voids as per design. That's the way it's designed. So the bottom 1/3 was stripped there. So the water from the OZFC penetrated into the surface course, which has 8% voids, and it was stripped. Binder course also has 8% voids, and it was stripped. Here are the existing bituminous courses. So you can see here that the water is having access down to the binder course. So that's why the stripping will take place. So when we did the milling machine, we found out that the top surface course was heavily saturated and the water started to ooze out. It was very dramatic appearance there. So not only this surface course, the binder course was also stripped and saturated, but surface course was more saturated because it was near the OGFC. So now the question is, I told them all these things, how things happen, how the water penetrated, all that, how stripping takes place. They said that's fine. They were convinced about that. But then the question they asked on the first day was that how come there is no potholing in the northbound lanes, which same contractor, everything was same. So that kind of threw me a question which I had to ask them. But luckily I had seen in Pennsylvania in the United States is that in the afternoon I could see sometimes the water oozing out of the pavement in the afternoon. And also if I compress the surface, some water will also come out. So based upon that, I thought that the traffic has to be very heavy in the afternoon. So that experience kind of saved my grace in there. So I told them, okay, over the night you gather some traffic data, like so many vehicles per hour on hourly basis on southbound lanes and the northbound lanes. So I was very lucky that to find out next day that in the southbound lanes where the potholes were developing, peak traffic was in the late afternoon when the pavement has become very hot. So the high moisture vapor buildup was there. It is very surprising to note that the volume of moisture vapor is 1,700 times that of the moisture. So there's a lot of vapor buildup, uplift takes place. And the other thing is the viscosity of the binder is also low at 60-degree pavement temperature. So stripping, it also helped in stripping. So the northbound lanes, when they gave me the data, we found out that the peak traffic was early in the morning before sunrise, and low moisture vapor buildup was occurring at that time. So the binder was also stiff at low temperature. So I told them that it's a matter of time before the potholes will start to show up in the northbound lane. And so lessons learned was that evaluate water saturation level in bituminous courses through samples obtained by jackhammer so that we can get the actual moisture content, use hydrogen lime as an anti-stripping agent, delay placing of the OZFC for at least 2 summers so that the underlying surface course is densified under traffic, otherwise provide a fog seal to close the surface voids. And that's what has been done throughout the world now. So now the second case history, that was in Europe, in Azerbaijan in 2004. They built a 21-kilometer of two-lane highway which was exhibiting central line crack in both lanes. Usually you don't find central line crack in any lane actually, and it was occurring on that case. So it was a nuisance. Crack sealing had to be done every year as new cracks developed. Crack sealer would not penetrate the fine cracks and just smear the surface. I'll show you some picture of that. So the project was investigated in 2007 to determine the cause of the center line crack. So that's the main problem we are going to solve here in this case. That why we have a crack in the center of each lane. Now this project involved complete overlay over a deteriorated Soviet era road. So let's take a look at the cross section here. Keep that in mind so that we can look at the problem. First of all, from the top down, 50 millimeter bituminous wearing course. Below that, 75 millimeter bituminous upper binder course. Below that, 100 millimeter bituminous lower binder course. So the binder course was considered in 2 layers. Below that, we have 250 crust gravel base course. One thing I would like to point out here is that they did not use any anti-stripping agent at all, because with the gravel we do need an anti-stripping agent. The gravel is very prone to stripping. Now here you can see the construction joint. I'm not showing there is some sort of a central line joint is appearing here, but it's not very clear. So the construction joint was also not done very bad, was very bad. Now here is the central line cracking, which initially shows up like that, like one crack, and then after some time, one crack will develop into multiple narrow cracks, and now they're all very narrow, so sealer would not penetrate these cracks, so just smear the surface. It was a nuisance. So every year more cracks will develop, and they have to keep on sealing that. So now here you can see the central line crack. Now I must say that a part of the overlay was also on the shoulder. So here you can see the construction joint crack. So it was not done a good job. And then, I'm sorry. And here is the central line crack. You can see there's a lot of smearing is taking place. So let me see if I can see the pointer. Here is the construction joint. Here is the central line joint. You can see a lot of smearing is taking place. This is central line because the part of the shoulder was also done in the single pavement. So what I did was that I told them that let's take some core samples right on the center line crack and also away from the crack. So they brought a coring machine. So the condition of the asphalt mix just below the center line crack, I saw this thing, that the core showed honeycombing low density binder mix, which usually disintegrated in the coring operation. I'll show you a picture of that. The binder mix was very coarse and it was severely stripped. Now here you can see the picture of that binder course, and in the top of the lower binder course was intact, and then we went gradually, and then at the bottom it was almost completely stripped, as you can see here. So this is the picture of you can see here that I have a low density zone on the left side, and that's where, let me show you picture. So the lower binder course is kind of stripped here as per the core I took. So because of that there was a poor support, so the crack would migrate from there to up there, and then more cracks will develop. So the question is that this area, low density has a lot of honeycombing. So the question is that why is that so? That was my question. That was the question which I have to think about that, and that's what you also have to think it now. And let me show you the reason for that was that here is a good paver where we have these augers, and there is one reverse auger on this side and that side. Reverse auger in a good paver pushes the material below this auger drive box, because here there is no auger, so it has to push it below that, so density is achieved. What I told them that let me see the paver which was used on this job, and I could see there that in that case there were no reverse auger. All augers were just pushing the material on this side, so nothing was being pushed under uh, the dry box. So that's why the zone which we saw a lot of honeycombing was taking place right below it. So I told them that it was a very poor designed paver. I knew about that. There were some pavers were done with this kind of a defective thing, that there were no reverse auger. So that was the question, and they were satisfied with that question. So the lesson learned on the second uh, case history was that use anti-stripping agents such as hydrated lime for stripping prone aggregates such as gravel. Now in their case, the optimum binder content was selected at 7% air words, not 4% as we do. So that also reduced the bitumen content. And the third thing was that make sure that you use a paver with the reverse augers on both sides of the auger drive box to push the material behind that. Now, when you, this is the last slide, when you go out on a project which is to be troubleshooted, usually you have to walk on the road, along the road and look at the whole thing. And sometimes you find like beer bottles and uh, soda cans and all that. And once in a while, you also see something like that. In some states of the United States, there is a big rat, which is called armadillo. It crosses the road and gets killed. Now, in this case, the state PWD, when they were using the yellow stripe in the central lane, they did not care to remove this big rat and striped on top of things. So that's a very strange scene there. With that, thanks very much for your attention, and I'll be glad to answer any questions that you might have. Thank you.
So thank you very much. We'll be taking up the questions at the end of all the presentations. We have one more presentation to go. So thank you very much.
Okay,
With
thank
that,
you.
we'll go to the third presentation by Mr. Hughes Benbow, who is the Global Support Manager at ARRB Systems Limited at Great Melbourne. So his presentation is on traffic speed deflectometer, new innovations. So 25 minutes. Thank you. So I request the audience to send me the questions if you have a question.
Good afternoon, ladies and gentlemen. Namaste. A warm welcome to all our distinguished representatives from the road authorities and research institutes across India and the world. My name is Hugh Benbow, Global Support Manager for ARB Systems. It's a very proud moment for me today as I stand before you as we announce the arrival of the iPave into India. The iPave, the first and only proven comprehensive pavement measurement system in the world, capable of measuring surface, structural and subsurface elements in a single pass. There are systems around that measure these parameters separately or individually, but this is the only system in the world proven to collect all of these parameters in a single pass. Let's talk first about our current technologies. What is our current state of play here in India and in much of the world? So our current technologies, the NSV, it mentions our functional and surface condition data using a combination of 3D lasers, point lasers, scanning lasers, coupled with INS systems, 360 cameras, right-of-way cameras, as well as the world-renowned LCMS system, which is used broadly across the world as well as for quality control purposes here in India. This essentially is the gold standard for measurement of surface condition, and this is widely accepted around the world. You find these type of machines on different vehicles in this configuration globally. In terms of structural condition measurement and bearing capacity, the most common technology at the moment is the FWD. The FWD is synonymous with structural assessment, and it is the industry standard. However, we are moving forward. There are downsides with the FWD. It is slow, it is dangerous. Having a vehicle stop in traffic for up to 30 seconds, a minute to perform tests, dealing with the lack of data that this system generates. Fundamentally, we have a very low number of test points that an FWD can generate in a single day. And that's one of the major limitations. We can only essentially perform spot tests with an FWD. We never have a full understanding of the structural capacity and the bearing capacity of our roadways. It's impossible with an FWD. It will take a lifetime. The other technology which is newer and more emerging is GPR. It is becoming more widely used, but there is still kind of a concept of a little bit of black magic behind the idea of GPR. These waveforms that we see underground the road surface. But as we are progressing with GPR, we are learning more and more how to use this information and how to avoid situations like having to go out and do expensive core sampling on roads. Again, a dangerous practice, going out, having vehicles performing coring on public roads. We often have to have traffic control in place, and if we don't have traffic control, we present ourselves with significant safety issues. But in order to get accurate data, that was the historical method of performing these inspections and determining these layer thicknesses so we can perform our back calculations. So we lay out some of our challenges here. The FWD is stationary, disrupts traffic, it's unsafe. It has a low spatial resolution. Generally, if we're trying to do network level surveys, there might be 200 metre to 500 metre spacing. Otherwise, we might go out with our network survey vehicle first and do an initial screening, identify areas where there is significant degradation in the pavement, and then we'll take our FWD out and we'll go and perform testing in those locations. The problem is that our pavement has already started to degrade. We don't understand the structure before we actually see a problem on the surface. The NSV is great, but it only provides us that information on surface defects. We have to combine that with our structural information, our subsurface information, in order to paint a better picture of what we're doing. GPR is not currently being widely used. There is an argument to say that we should be using more and more GPR and focusing on adopting that technology, moving away from core sampling. A major issue that we face is that the data is collected in multiple vehicles, on separate days at separate times, perhaps in separate climatic conditions. How can we practically compare our data when the data is not collected simultaneously and consistently? This also presents challenges with data alignment. In order to align our data correctly, we must spend a lot of time in ensuring that the data alignment is correct and valid. And in many cases, there will be errors that are introduced into the process that we cannot eliminate. And sometimes it becomes impossible to align these data sets. This manual consolidation process is slow and it can lead to misalignment. So what are the solutions for our current challenges? Okay. What do we need to do? What is the way forward? So more often than not, roads are designed by strength characteristics. Pavement and civil engineers spent weeks and weeks, they spend their lives determining, we just watched a very interesting presentation from an emeritus professor who spent his life dedicated to understanding pavement failure. And I'm sure when he stops and thinks about how to design a pavement, he thinks about how do I define the strength of that pavement? How strong do I need to make it? Okay, and how do I define those strength capabilities? But once we have built the road, the aspects that define the strength of the pavement are hidden to us. They are sealed under our wearing course. Okay? We then manage the roads based on surface characteristics. We kind of forget, for the most part, about those structural characteristics. Okay? We wait until we see fatigue cracking on the surface, and then we go out and test with an FWD in order to determine the way forward. But what if we have a smooth surface with a strong subbase? What if we have a rough surface with a weak subbase? But what if the inverse is true? What if we have a good surface and we have laid a good surface, but we have a weak subbase? How do we know? Knowing the difference can save us a lot of money, can save many, many crores. So let me introduce the iPave. I hope some of you have taken the time to look at the iPave. We have the trailer here this week, and I hope you've taken the opportunity to go and look through the iPave so that we've had the opportunity to talk to you about the iPave, the technology, and get you up close with the equipment. If you haven't, I encourage you to do that. The iPave combines all of these elements together. Okay? We have functionally the heart of an NSV installed onto a rolling weight deflectometer capable of measuring continuous structural capacity. Added onto that, we also have ground penetrating radar, full vehicle with ground penetrating radar, which is measuring full scans of the lane at various depths, various frequencies, a spread frequency antenna that we're using in order to get the most accurate data that we can have. This system collects continuous high-resolution structural and surface data at traffic speeds. It provides a holistic pavement condition profile in a single pass. There is no other system in the world that can present this information to you in a single pass that has been tested and proven and approved by road authorities around the world. Some of the most prestigious road authorities, road research institutes have adopted the iPave. Organisations like Highways England and TRL, BAST in Germany, the NTRO in Australia, the Federal Highway Administration in the United States, TxDOT. All of these organisations, they believe in iPave and the technology and what it can offer to them in understanding and managing their road assets. This enables faster, safer and more cost-effective network level assessments. It supports proactive maintenance planning through predictive analysis based on comprehensive data. Another amazing part of the system is the data is so detailed that we can perform network level surveys, but then when the time comes, we can take that same data and we can break it down so that we are performing essentially project level investigations on that data. And there are very few other systems that will enable you to do that. Normally we perform a network level survey, we will identify areas of fatiguing and failing, and we will go out and perform project level assessments once we've identified them in a works program. This is not the case with the iPave. We can go from network to project in one step. The system operates within traffic flow with no external traffic control requirements. It looks just like a normal truck for the most part, except if you look at the back, it really just looks like a normal truck, big refrigeration truck. This system can and has completed 12,000 lane kilometre network in 9 weeks. This was a demonstration that we did for the DNIT in Brazil. The equivalent FWD network testing, 1.2 million test points, it would take you 24 years with a single FWD, or 1 year with 24 FWDs. It's a significant investment. It also reduces the risk exposure and severity considerably over other stationary or slow-moving objects. So if we consider the FWD or even some of the rolling deflectometers of the past, the Lacroix deflectometer, the curviometer, these systems operated maybe 10 to 30 kilometres per hour maximum. They still weren't a safe vehicle to use in traffic. They still needed traffic control safety measures in place. This system is used across the world, as I mentioned. Okay, currently 12 iPaves operate globally. The platform that the iPave sits on, the Greenwood TSD, the number of the TSD out here is TSD number 24. So 12 of those TSDs in operation are iPave systems from ARB Systems. We operate in the US, Canada, and Mexico in North America, Brazil, throughout Latin America. We have 2 systems in South Africa. We have taken our iPave across Europe from the north of Scandinavia down to the south of Spain. We operate 4 systems in Australia and New Zealand, and now we are here in India. This can be used for comprehensive network level, project level assessments, as well as research studies, which has been proven by many of the research institutes around the world, including BAST in Germany. So how does the system work? Essentially, we have a rolling wheel. The rolling wheel has a continuous loading of 10 tonnes, 5 tonnes per axle. That is configurable. We can bring the loading down in some circumstances where road authorities are very concerned about the bearing capacity of their pavements. They haven't built their pavements to the structural capacity. They have load limits on their roads. In some of those cases, we may reduce the total loading. As an example, 10 tonnes is 22,000 pounds. In the United States, we use 20,000 pounds as their specification. Or we can bring it up. We can increase the loading. We go up to 12 tonnes, 6 tonnes per side for a 60 kilonewton axle loading. We have an array of Doppler laser heads. These Doppler laser heads are measuring the velocity of the pavement. So as the truck moves across the pavement, it is physically bending the pavement. It's imperceptible to the human eye. We cannot see it, but it is physically happening. We know this because we can measure it. We can measure it with an FWD. We've done that for many, many years. But we can also measure it with high accuracy velocimeters. These velocimeters are traditionally used in vibrometer testing. So for vibration testing, they might have a shake table. They place a device on the shake table and they shake it, and then they point the sensor at it and they measure the oscillating frequencies. Using this laser sensor and changing it so that we point it down at the pavement surface and roll a heavy weight along the pavement surface, we can now measure the acceleration of the pavement surface as we bend the pavement. So bending the pavement pushes down, and using these laser heads, we can see essentially the movement of the pavement in real time. At the very right-hand side of the image, you'll see what we call the reference laser. This laser is positioned 3.5 metres in front of a load. This laser should be measuring zero deflection under normal circumstances. Progressively, the other lasers, as we move forward, will measure increasing values of acceleration, velocity. We then integrate those velocity values, we convert those into those velocity values, and then we integrate those values into slope values. So we take the vertical velocity and the horizontal velocity of the vehicle, and we then convert that into a slope value. Once we have our measured slope, we can then determine, using our calculation methods, the calculated deflection at D0. Now, while we may not have lasers specifically at D0, our field studies, our field trials have demonstrated that we are able to accurately define what D0 is, exactly the same as an FWD would, with excellent repeatability. The TSD is non-destructive. It uses Doppler lasers to measure the traffic response, the pavement response at traffic speed. It's measuring deflection velocity. Okay, we have a 10-ton axle load, and this generation 4 TSD that we are using in the iPave has 11 lasers with 8 in front and 3 laser sensors behind the load in order to measure the viscoelastic response or the load dynamics and pavements and slab shift between slabs on concrete pavements. The iPave itself, as we mentioned, is a fully integrated network survey vehicle as well at the same time. So on the rear we have our LCMS2 system as well as a rear right-of-way camera. We have our deflection measurement, we have INS and GPS measurement in order to get our positioning. We have a front digital imaging system, up to 3 cameras. We can also include 360 cameras. We're currently working on developments which will appropriately create a 360 environment on a vehicle that is 15 metres long. We also have our 3D GPR as well as our regular point laser texture measurement and roughness measurement that is industry standard. So in terms of the data that the iPave or the deflection measurement and system fully can generate for us, what is all this data that it could generate? Okay, we generate deflections from our slopes. We can generate SCI 300 as well as D0, absolute deflection values. Greenwood have got a new SCI TSD calculation, which they'll be releasing a research study on soon, which gives us a SCI TSD, which looks at the deflection bowl in a slightly different way than traditional methods. We can measure our layer thickness with our GPR. We can measure our surface conditions with our 3D laser and our inertial laser profiler. We can calculate our strains and our modulus by back calculating the information that we receive from this vehicle and get those results very, very quickly, very rapidly from a single data set. We can also obviously perform our viscoelastic back calculations. And it's not that we can perform those in a single area, we can perform them anywhere along the pavement. That's one of the greatest advantages of this system, is that we don't have to choose, go out, please do 5 test pits for me. Where do you want those test pits? 50 metres apart, let's say. But at the end of the day, if the problem was in between those test pits, we never would have seen the problem. And that happens in more cases than you might imagine. So the iPave system and the TSD system, the calculation of the deflection is using this model here, using this AUTC model, area under the curve. So on top of here we see the slopes that have been calculated from the velocities, and then by looking at the area under the curve, we can then determine the deflection bowl. And this is how we determine the deflection bowls, by looking at that area under the curve and then plotting that as a negative value, as a deflection in microns. Using this method and a curve fit, it also allows us to perform or determine the deflection at any point along that curve. So by determining deflection at any point along that curve, we can calculate the deflection at any point along that curve. And we can use that information in order to better understand the condition and the structure of the pavement. So here's some examples here of just some of the moving values. This is essentially what we would see if we were looking at the data and clicking through 10 metre or 1 metre intervals, depending on the data that you're looking at. So TSD versus FWD, okay? 27,000 test points a day. I probably would have made it a nice round 30,000 test points a day if I was doing this graph myself. If we compare that to an FWD, the number of test points is minimal, very, very minimal. Okay? The speed and difference in terms of the volume of data, the amount of data that you get, the rapidity of collection. Normally an FWD might do 30 kilometres a day. The iPave will comfortably do 300 kilometres a day. In perfect environments, perhaps in the outback of Australia and things like that, when we have no traffic and just a direct opportunity to drive into the sunset, we can do 600-700 kilometres in a day. Imagine that, 700 kilometres of structural, subsurface and surface data collected in a single day. So I want to show you this example here. So this is an example from a case study that was done in South Africa. And what we wanted to do is we wanted to compare and determine that back calculations, viscoelastic back calculations, are consistent between an FWD and the iPave. So we performed a case study. and we found a defined area, a reference area for strong pavement and a reference area for a weak pavement, and we tested both of those critically using the FWD and the IPAVE. We then had independent and internal civil and construction engineers, research engineers analyse that data, run it through their viscoelastic back calculations, and we ended up with these results. Okay, so we have FWD in yellow, and we then have IPAVE in red. And these are the different layer calculations based on the data inputs. For our layer thicknesses, in this case, we used core sampling in order to get the highest accuracy and to ensure that we were using the correct information when performing these back calculations. It was a research level study, not a network level. But this just goes to show that the FWD and the IPAVE, they are consistent, they are the same, they measure the same data, they give you the same results. This has been proven and accepted by road authorities around the world. So the IPAVE has been here for a short time. We brought it into the country a couple of months ago, and we've been getting it ready, and we've been doing some initial discussions and test trials. Cube Highways Corporation asked us to come in and do an initial test trial for them on the NH44 between Delhi and Agra. So we performed a test on this section, and we essentially performed two types of tests. One was a repeatability test, okay, to ensure that the equipment itself was repeatable, to demonstrate the repeatability of the equipment in terms of its deflection measurement, its roughness measurement, all of its parameters. The other aspect that we did was a reference check against an FWD. So on that site, at the same time, to ensure that we weren't using old data, that we collected the data on around the same days, we had the FWD there collecting data at 20-metre intervals. We wanted as much data as we could get out of the FWD. And we then collected that data, and we then performed an analysis on that data, cross-correlation, cross-referencing of that data. And then I'd like to present to you the results of that test here.
3 minutes. 3 minutes.
My clock has stopped on the screen here, unfortunately. It stopped at 16 minutes. So this data here that we have from the NH44, as you can see, the blue data is very high resolution data. This is the data from the IPAVE, okay? This is our, essentially our D0 deflection. In the red spots, you can see that we have essentially the FWD data cross-sectioned against that. And as you can see, there is a very good correlation between those two data sets. The FWD generally follows the IPAVE system and the IPAVE deflections. There are some outliers, but that is to be expected, particularly when we are doing singular spot tests. But what this demonstrates to us is there is a high level of repeatability when comparing, or a high level of comparability and accuracy when comparing the IPAVE and the FWD. Here is the repeatability charts, okay? Again, looking at the D0 deflections from the southbound and then the northbound lanes. And as you can see, we have a very, very high level of correlation between those two data sets. Great level of consistency, a great level of agreement. Our ground penetrating radar. We're using a contour ground penetrating radar. It's a spread frequency radar. It's a full width radar, multi-channel. We get an enormous amount of data from this system. Some would say too much data sometimes, but we then analyse that in-house and just present to you the information that you require. You can also analyse the data yourself. We can present the raw data to you, but you can also just provide to you the layer thickness information, and that way you have the layer thickness, the critical information that you require from this subsurface inspection. It's a very useful tool for understanding what is happening below the pavement. So why the IPAVE? Focus on improved accuracy of structural and condition data. More test points means more information. More information means better decision making. Trying to make decisions, I feel for the engineers of the past because they only were able to make decisions based on very, very limited information. But the engineers of the future will be empowered with big data, with lots of information, with an abundance of knowledge that can drive their decision makings. It helps us make better decisions. We can optimise our maintenance and rehabilitation planning by identifying early signs of structural and surface issues The comprehensive machine helps target preventative treatments before costly failures occur. This proactive approach extends pavement life, minimises high-cost interventions, improving cost efficiency over the pavement life cycle. We generate, obviously, our data in standardised formats, CSV formats, Excel formats. We can then use that data to perform additional analysis, safety ratings, back calculations, mechanistic analysis, and then we can also then use it to influence our maintenance strategy. This is the purpose of this data. Influence our maintenance strategy, influence our engineering decisions. We also have a system called Hawkeye Insight, which we take this data together and we place it on an online viewing platform to allow that data to come together in a single space. And we're happy to do a demonstration for that. If you'd like to come past our booth, we can show you the Hawkeye Insight platform. We can show you some demonstration data that we have. I can show you some live data that we have from some of our clients who are kind enough to allow that to be shared from some of our international clients who have different rules around how they can share government and public data. This allows us to view our deflection data, our imagery. We can have heat maps, overlays, all this information, and multiple data sets plotted together. And we know that the data is aligned. We know that the data is accurate. Okay? It's driving better decision making. It allows us to categorise our roads better. Okay? We know whether a road is going to have a short lifespan because we can look at the bearing capacity. We could build a road and 1 week later we could go out and test that entire length of road and know that the information that we're putting into our predictive modelling is going to tell us the life cycle of that road and not just a close estimate. It will be very, very accurate, much more accurate than historically possible. Categorising these pavements so that we can make appropriate decisions about how we rehabilitate our roadways and how we manage and maintain our roadways. Thank you all very much. Dahanya.
Thank you very much, Mr. Hugh. So the vehicle is just outside the exhibition hall. You can visit that, and specifically for the IRC H6 committee, the maintenance committee can invite Mr. Hugh. If they are here, they can visit the vehicle, they can have detailed discussion, and it's good to understand the detailed functionality behind the presentation. Now we'll have a brief floor intervention. So in terms of the slips, I have not received much slips except for one intervention from Mr. Rajesh Naik, MP RDC, but like it was after a presentation by Mr. Sinha. He says that it's good appreciating the presentation, which is like the presentations are highly informative, well-structured, offering valuable insight into emerging technology and various type of practice adopted in road construction. So that is one part. And the depth of discussion and practical relevance of each presentation in the session is truly enriching. So that's a very positive comment, which says that why we should have annual sessions, why we should have these discussions. And in case anyone wants to speak, please raise your hand. Maybe I can, otherwise I can take some names. Dr. Bhavesh Jain, Dr. Pateria, Professor Venugopal Mahapatra. In case you want to speak, you can come forward, can share your viewpoint. So Dr. Bhavesh Jain, want to use the stage? No? Okay, so we have a slip. So that is from Mr. Indrajit Ghai. Ghai sir, you can go ahead. Please use a mic and you can speak.
Hello, R.S. Mahalaha from Rodek. I want to know what is the cost per kilometer of your survey? Per kilometer for a 2-lane road.
So you want to understand the cost of the collection? Yeah.
Data collection.
Okay. Essentially, realistically, it would be anywhere starting from about $250 US. I would have to back calculate that into rupees for you, moving up from that point. So at a basic level, that collection would be about $250 US moving up at that point. So per kilometre, sir, per kilometre. So we've had some discussions recently, and it raises a good discussion topic in that respect, and thinking about our maintenance, and think about how much 1 kilometre of road network costs you to build, and think about that number, and then think about how much you are prepared to spend in maintenance on that section. So our observation would be, think about what is a reasonable percentage that you would spend on a yearly basis in terms of maintenance on that section, and what value that actually is. The example that I give is our automobile, the car that carries our family and our children. If we were to spend, say, $10,000 on an automobile, it would be reasonable for us to spend $100 per year on the servicing, 1% of the value of that vehicle per year on the servicing.
Yeah, I'll suggest that maybe you have an interaction with them at the exhibition hall, and they are going to do trials for national highways for 200 kilometers of road network in the state of Odisha. So any further questions, you have one-to-one interaction with Mr. Hugh. Now there is a question for Mr. Kandal. What is the effect of median with plants? That was the third case study which you are showing in the last slide on performance of pavement. Professor Kandal, if you can hear me, you can respond. I'm not sure he was connected online. Okay. Yeah, if there is any other question, yeah, please. Please address to the particular speaker who is supposed to.
I have a question to Mr. Sinha. He has said that digital, it was a quite good presentation. I just want to know that ministry has mandated all its agency to have data on data lake also. So is there any pilot, have you studied that your system can be integrated with data lake data that is already we are using for our project management, or?
We are actually examining it and soon reach out to the ministry. I have had discussions with DG Saab, DG RD and SS, but we are formulating our proposal in this regard.
I think since most of the work has been done in linear project, so probably that what ministry or NHI is struggling in data lake to have meaningful interpretive data in our project monitoring. It will be great, sir, if that collaboration work out.
We will soon reach out to the ministry.
Thank you very much. I'll just request that please send your written comment so that it is also kept on record, and we'll share with the ministry in a formal way. Thank you. Any other comment?
Can I answer the question raised to me? Can you hear me?
Yes, sir. We can hear you.
Okay. Yeah, somebody mentioned about the raised median.
Yes, sir.
I had two slides which I did not show because of lack of time. I just want to mention that I was traveling from Jaipur to Delhi, and I saw a raised median, and the lane just next to raised median has carried the heavy traffic, and it had a lot of potholes. Wherever the raised median would end at the intersection, there won't be any potholes. So that means the water from the raised median, if it has soil which is not permeable, then it will go towards the pavement layers. It can saturate the WMM and GSB and cause these potholes. So I have this concern about it won't happen at all the places for raised median, but somewhere it can occur, as it appeared on Jaipur Delhi highway. The other is safety feature. If I am driving my car on the lane next to median, if there's a truck is coming in the left lane, he can squeeze me out, I don't have any place to go. There's no shoulder, nothing. So that's a safety concern. So I think we are building a lot of raised median, so we should give it a second thought.
So thank you, sir. I think with that we'll close the floor intervention. Now it's over to the co-chair of the session to wrap it up. He'll provide a brief summary. After that, we'll close the session.
Yes. Thank you, sir. Good afternoon, esteemed chairman, sir, esteemed speakers, and dear delegates. Uh, it's an honor to share the stage with you, sir. Professor Mananjan Padi, President, Indian Road Congress, a visionary leader guiding the national road sector towards innovation, safety, and sustainability. From the land of Konark to a leader in national scenario. So, on behalf of Indian Road Congress, I extend my heartfelt appreciation to all the three distinguished speakers for their innovative, insightful, and modern presentations. Each of you brought a unique perspective that blended technical depth and forward-looking ideas. So I will start with my first speaker. It's Nagendranath Sinha, esteemed speaker, Sri Nagendranath Sinha, MD, Rodic Digital and Advisory. All operations of the main, before I asked giving the insightful details regarding the speakers, just I want to make a point here in this esteemed gathering. It's a time has come for the Indian Road Congress to look at civil engineering through a new lens, one shaped by data, intelligence, and innovation. The artificial intelligence holds transformative potential to revolution how we design, construct, and maintain, govern roads. From prospective maintenance and predictive maintenance and safety analysis to real-time quality monitoring and transparent project management. AI empowers engineers to move from reactive decision to proactive solutions. As the custodian of Indian road standards, IRC must now lead this digital transition in integrating AI into codes, practices, and capacity building. By enhancing AI, we can ensure that our roads are not only stronger and smarter, but also safer, greener, and more accountable, truly affecting the vision of smart infrastructure for new India. So, in the presentation of MD Rodic, all operations are digital. Every organization across the globe is now transforming the data and digital project management in the same way. AI and ML is transforming civil engineering. My humble request to all state PWDs and corporations, explore potential of AI for transformation. A digital platform like R360 for AI, I think it can affect the in the all stages of a project, like feasibility stage, DPR stage, procurement stage, construction stage, project monitoring stage, and quality assurance stage, as well as completion stage. Project initiative in Maharashtra, Bihar, Assam are really interesting. And in Odisha, there are more than 60. In Odisha also, we have started the initiative of AI for building and as well as highway sectors. And we find out there are more 60 processes and applications where we can use AI in building sector as well as in road sectors. Then to our second esteemed presentation, troubleshooting of bituminous pavement worldwide experience by Professor Prithvi Singh Khandal, Associate Director of Emeritus. Sir, your presentation was really insightful. It's a regarding the good or poor sections. A good section reflects to the stretches of road that performs well and meets the expert desired standards in terms of ride quality, safety, drainage, and durability. Flushing occurs due to excessive binder, inadequate air void mix, high temperature, heavy traffic loading, poor drainage bases. The Hume Highway is one of the leading highway of Australian road. You have presented about the Hume Highway. Why no potholes in northbound roads is one of the aspects of your presentation. and peak traffic in early morning before sunrise, low moisture vapor buildup, binder stiff in low pavement transparent, these are the factors why there is no potholes. Impact of moisture on pavement, that's quite interesting. Moisture is one of the leading causes of pavement distress and structural failure. Then impact of temperature on pavement condition. Temperature affects binders, properties, volume, changes stress and durability. And when there is a combined effect, it's more interesting. Like moisture and temperature, when both combinedly affect on the highway pavement, moisture weakens structures, high temperature stiffen binders, and combinedly it causes rattling or swaying. Similarly, wet and cold condition causes toe damages, and alternate wet and dry cycle causes fatigue cracking. Similarly, traffic speed deflectometer is one of the criteria. So then my third esteemed presenter, he is traffic speed deflectometer, new innovation by Hugh Bonbo, Global Support Manager at ARF system, IPAV system. IPAV is an intelligent payment assessment system. In a specialized vehicle-based payment assessment system, it uses advanced sensors including a traffic speed reflectometer. The advantages, very well he explains the advantages. The IPAV vehicle drives along a highway on road network on traffic speed, collecting data continuously. Then the system records structural responses, functional measurements also. The collected data is geolocated and time-stamped and enabling mapping and analysis of conditions across the network. Highway engineers use these data to infra-bearing capacity, fatigue life, structural strength, as well as decide on maintenance needs precisely. Why IPAV we need in India? Why we need in India? Efficiency and speed, holistic condition assessment, better maintenance planning, and resource allocation. Key challenges for adaptation in India. One of our delegates also raised the same question. It's regarding the cost first. Second is data handling capacity. Third is integration with the existing asset management system. Fourth is adaptation of local conditions. These are some of the key findings. So I once again thanks to all the speakers. Thank you so much. Now, Honorable Chairman, sir.
So we now hand over to our hostess for the closing of the session.
Thank you so much, sir, and thank you to all our
check. Ladies and gentlemen, we are starting the technical session 19 within few minutes, so requesting everybody to please kindly settle down. Sure. Namaskar and a warm welcome to Technical Session 19, presentation by Officer of Central Government Department, MOD, NHAI, BRO, CPWD, NHIDCL and NRIDA. Well, first of all, let me take the honor and let me call on dais our respected Chairman of the session, Shri A.K. Jain, former engineer in charge, UPPWD, and past Vice President of IRC. Let's give a big hand and let's welcome Chairman of the session on stage. Namaskar and welcome, sir. Next, would like to call on the dais our co-chair for the session, Sri Ashok Basha, convener IRC B3 committee. Let's give a big hand and let's welcome our respected co-chair of the session on dais. Namaskar and welcome, sir. To welcome our respected Chairman of the session and co-chair, would like to welcome and of course request Executive Engineer Civil Works Department of Odisha, Mrs. Ashmita Mahapatra Madam, is going to welcome them with the flower bouquet. Thank you so much, Ashmita Mahapatra Madam. Now requesting, and let me take the honor to welcome all our presenters on stage. So first of all, would like to welcome Shri Amit Shukla, JSRC and DG NRIDA. Unfortunately, he is not present here. Well, let me welcome our next presenter, Dr. I.K. Pateria ji. Let's give a big hand and let's welcome. Namaskar and welcome, sir. Our next presenter is Shri L.P. Padhi, CGM. Namaskar and welcome, sir. Our next presenter is Shri Amit Munjal, GM Tech, NHAI. Welcome, sir. Would like to call on dais our next presenter, Shri Nirman Kishan Jambulkar, Executive Director, National Highway Infrastructure Development. Let's give a big hand and let's welcome, sir. Our next presenter is Shri Vidur Khan Jha, Director, New Technology, Ministry of Road, Transport and Highway. Welcome, sir. Would like to call our next presenter to the dais, Shri S.K. Verma, Superintending Engineer, Civil, Border Road Organization. Welcome, sir. Now I request the chairman of the session, Shri A.K. Jain, sir, to start the session with his opening remarks. Thank you.
Good evening, ladies and gentlemen. So this is the last technical session of today's conclave of IRC at Bhubaneswar. This session is by the central government departments So it's going to be a very important session, and I think very interesting one also to all of us. We have 5 presentations in this session, and these presentations will be made by NRIDA, then NHAI, NHIDCL, and Ministry of Road Transport and Highways, and NRIDA. So we have the entire spectrum of central government departments in the sector of roads and highways. You see, in our country, the responsibility of creating and maintaining the road infrastructure lies on mainly 4 pillars. And these pillars are, the pillar number 1 is the research and academics, who bring the technology and engineering in the implementable shape. And the second pillar is of IRC, who formulate the standards, specifications, and codes to enable the contractors and department to practice the technology in the field. And third pillar is of the contractors, who implement the technology into the field. And fourth one is the most crucial one, and that is the pillar of the government departments, because the ultimate responsibility lies with the department. They are responsible to the government, and they are answerable to the public at large. So, no technology can succeed until it is practiced in the field. And no technology can evolve until it is practiced in the field and the results come to the research, and the research goes into the field. So this is a very two-way process, and it should be interactive. What I feel as a field engineer, that somewhere this interaction is missing. So the purpose of such conclaves is to bring all these 4 stakeholders together and to interact and bring out the best one, so that our results are seen in the field and ground. Then only we can serve the nation. So with these opening remarks, I request my co-chair to give his opening remarks, and then we will start our presentations. Please.
Good evening. First of all, it is a very important session in the sense that in IRC, opportunities are given to everybody to share their experiences. And this is specifically meant for Government of India organizations. Similarly, IRC also conducts a program for the state government and state government PSUs. The idea being the problems, the areas where solutions have been made, that has to be shared to the larger audience of the country. And in that way, I think this is very important, but at the same time, I agree with the chair that this is the last session and our business session will start at 6 o'clock. So we are already late, so I don't want to make it further late. We should give opportunity to our speakers for whom we are congregating here. Sir, with your kind permission, can I say that we should give about 10 minutes to each? 10 to 12 minutes. Yeah, 10 to 12 minutes, and we request all the speakers to maintain time. And after 10 minutes, we'll just say that 2 minutes more, just to remind. Yeah. And within 2 minutes, we have to conclude. This is in the interest of the audience and also in the interest of the IRC, because the business session we cannot be delayed. In other sessions we could have delayed, but business session should not be delayed. Thank you.
So, just to start with, I invite Dr. R.I.K. Pateria from NRIDA. He will be presenting on experience of National Rural Infrastructure Development Agency in PMJSY. And so please, you can go ahead with your presentation.
Respected chair of the session, co-chair, my fellow presenters, senior officers sitting in the audience, my colleagues, officials from different organizations, and our friends from road sector. I am going to make a presentation on Pradhan Mantri Gram Sadak Yojana, our experience till now, what we are doing now, and how we are planning to move in upcoming or in the current program of PMGSY 4. We are aware of the road network in the country. The purpose of bringing in this slide is that the share in terms of length of the entire network is major with the rural roads. Maybe 71% of the roads are rural roads in the country, and it is depicted on this slide. One more clarification I would just like to make. All rural roads are not being covered under PMGSY. We are covering only a part of it. So, though Ministry of Rural Development is responsible for making policies, guidelines, and taking care of all rural roads, but these are being the state subject, they are with the state governments. And PMGSY as a special intervention, one-time intervention, covers only a part of it. So not all rural roads are being covered or likely to be covered under PMGSY. However, the roads which we have constructed till now makes around 17% of the total rural road network. These roads have been already constructed and have also been, majority of it, almost maybe around 90% of it have been already brought onto PM Gati Shakti platform. So their location, everything, all data has been transferred. This is, in nutshell, the overall PMGSY journey started in the year 2000. In 2013, another program, PMGSY 2, was started for upgradation of some of the roads. After that, in 2016, RCP LWE, Rural Connectivity Program in left-wing extremism affected areas, 2016. This was also a special intervention of Ministry of Home Affairs. Then we started with PMGSY 3, 2019. Again, upgradation of 1.25 lakh kilometers. Recent intervention of Ministry of Home Affairs in border areas, Vibrant Village Program limited to border states. Then another program of Ministry of Tribal Affairs that has also been given to PMGSY in 2023, known as PM Janma. This consists of many other programs in different sectors, but road part is being done by PMGSY unit, MORD. And the last one is PMGSY 4, which has been just started in sanctioned in 2024, and we have started the process of sanctioning the road projects to different state government departments. This is again a intervention for new connectivity only without any upgradation component, and is likely to provide connectivity to around 25,000 habitations based on census 2011. The earlier programs were based on population data of 2000. So now we are moving to census based 2011, and around 60,000 kilometers of roads are likely to be constructed under this program in next around 4 years. I'm straightway moving to the very specific intervention and the adoption of the technologies. So we started with framing the initial guidelines in 2013 that around 15% of the roads are to be constructed with various new technologies. Then in 2022, based on experience, the guidelines have been modified in the form of Vision 2022, wherein the mandates have been issued for use of various green technologies in different layers. Rather than making use only in a particular layer, now it is layer-wise, that in bituminous layer, these technologies are to be adopted. In base layers, these technologies are to be adopted, and these have been issued. this adoption of new technologies in PMGSY has gained sufficient momentum only because when the states are coming for next batch of sanctions, the review of the proposals in the current batch, which is being placed before the empowered committee, and the achievements are being reviewed by the empowered committee. Based on the achievements only, the further sanctions are being issued. These are the technologies. Simultaneously, some photographs are being displayed. These are some further interventions. As I said that in 2022, Vision 2022, so these are the specific provisions for different layers, right from waste plastic, mechanized surface dressing, cold mix, cement concrete, thin white topping, green technologies which are being covered under SP 89, FDR, flyers and whatnot. So details have been issued. This is the overall data of the length sanctioned and which has been completed. State-wise, I have just brought in. We have on our website the state-wise and the technology-wise data as well, what has been sanctioned and what has been accomplished. So in total, a length of 1,66,780 kilometers has been sanctioned till now. Against that, 1,27,664 kilometers has been already completed, including around 6,000 kilometers of roads using FDR in various states, majority of which is in the state of Uttar Pradesh. Now, other states like Himachal, Kerala, Jharkhand, then Bihar, they are also following and they are also adopting this FDR technology on substantial number of roads. Moving towards the maintenance, earlier we had this system that bill of quantities that was being prepared manually. Contractor used to submit the physical bill based on quantity of the material. PIU receives the bill, inspects the road, verifies if the bill is correct. The account officer adds taxes, bill gets approved and check is sent to the contractor. But this was a cumbersome process and there was no check. There was no control when the maintenance is being done and when the payments are being made. This had several issues which have been simultaneously listed. Cycle of payment started from contractor submitting the bill, manual process, bill generation, taxes, etc. So everything, paper-based system and tedious record keeping. Now we have moved to e-mark, electronic maintenance of rural roads, and that has been mandated to all the states since 2019. It is a performance-based maintenance wherein no measurements are to be recorded. At the time of signing the contract of maintenance, which is inbuilt along with the construction contract, the contractor is not even quoting the rates of maintenance. The rate or the estimate prepared by the engineer along with the bill of quantities when we are publishing the tenders, along with that, so the contractor has to only agree on the rates which are, has to agree on the estimate for maintenance part. He has to quote the rates only for construction part. This has brought in a kind of discipline that whatever the engineer has estimated, in that amount the maintenance will be possible, and accordingly he will keep an eye on the construction quality, because then he has to maintain for 5 years. We started with this in 2019. This is outcome-based monitoring. Evidence-based assessment of roads. Every 2 months, the district PIUs are assessing the quality of roads, uploading the photographs online on the e-mark website. Quality in construction is rewarded. No requirement for detailed measurement. 2 more minutes, Dr. Patel. Yes, I will. Defect liability period is 5 years. Now we have started, these are some of the advantages. Because of shortage of time, I am not going through all that. Post-defect liability period, again, another contract is being signed for next 5 years. So that makes 10 years. Today in the morning session, there was a presentation by Madhya Pradesh government wherein they said that now they are monitoring even those roads which have crossed 20 years. Because every 5 years or 6 years, as per the assessment, the resurfacing is being done. So now this e-mark is also coupled with artificial intelligence, and the photographs being uploaded by the executive engineer's office, they are being verified by AI whether the marks awarded for its performance are correct or there are issues. This kind of discrepancies in photographs are being pointed out by AI. We have just started with another system in addition to this 3-tier quality management system to strengthen tier 1. Today only in the morning session there was a presentation on stage passing. So with effect from 15th of August, now we have made it mandatory that every layer of the road has to be stage passed by the concerned executing agency. He will upload the photographs, he will upload all test reports directly onto the website. And this data will be in public domain. Till now we had the data of tier 2 and 3 in public domain, but tier 1 was missing. So there were many issues, records could not be scrutinized, but now all this data will be in public domain. This is IT backbone of the PMGSY. Data is being posted regularly to Gati Shakti project, which has been mandated. This data has been already brought on to PM Gati Shakti. There is a citizen feedback system known as Meri Sadak, so anybody can put up any kind of the complaints or suggestions through this Meri Sadak app. This is another app, This is another app which has been brought in as the Gram Sadak Survey app for this PMGSY 4 project for survey of the new habitations regarding their eligibility and finalizing the alignment. This stage passing I have just narrated. This kind of certificate will have to be generated and stored on the website after each layer is compacted and finished. And with this, we hope that the quality of the PMGSY roads will further improve. Impact evaluation studies have been carried out by World Bank, Niti Aayog, some other agencies, and they have given a very positive feedback on construction quality and maintenance of PMGSY roads. These are some of the references. Thank you very much.
Thank you, Dr. Pateria, for giving an excellent overview of PMGSY and its working. Now, next presentation is on adoption of innovative digital initiatives for improvement in operation and maintenance of national highways in NHAI by Sri L.P. Padhi, CGM, and Sri Amit Munjal, DGM Technical, NHAI.
Good afternoon, respected chair, co-chair, fellow presenters, and distinguished guests, delegates. Today I will just give a brief overview about what digital initiatives we are taking for operation and maintenance in NHI, particularly in where the projects is being completed, they are currently in operation and maintenance. As you are aware, during last 2.5 decades, there has been an emphasis on construction activities on the national highways. Even more than 60,000 kilometers has been constructed. But at the same time, the maintenance of the assets, the constructed assets, to keep them in the same position as the user experience at the time of completion is a paramount importance. So to take that into account and also looking that we are struggling actually. Actually, we were struggling to keep pace with the aspiration of the public in the operation maintenance, although there is enough covenants in the contracts. But we are really struggling how to keep the pace with the requirement of the public to give them a world-class highway in maintenance period. So in that sense, the digitization and the initiatives and monitoring through digital mechanism using the high-end tools has become very, very important so that the monitoring of national highways are carried out in a very scientific manner. So today's I will just give brief because every one of these, every subhead is an important aspect and it will take a lot of time if I go on discussing everything. I'll just try to give what we are doing to do the maintenance activities like NSV. We are coming with NHA one app. We have done some pilot study of AI usage in signages. We are using dash cams in a very, robust way. Drone analytics and PBMC maintenance as well as project rating. The outcome of all these aspects, how we are doing in NHA. The point is, see, these are the 5 parameters: rutting, roughness, cracks, raveling, potholes. Apart from patching, are the important factor in country. They define the payment condition index. There are covenants are there. Every contract we are entering, either in EPC or PPP, we have covenants of operational and maintenance requirements. Let's say the roughness is given, let's say 2,400 mm per kilometer, or some contracts 2,200 mm per kilometer. Every lane has to have roughness index within that parameter. Cracking. Although in contracts we have a provision that in a length of 100 meters, the percentage area of crack should be less than 5%. But we did not have any wherewithal. How? You do not have wherewithal to just accurately say that this is the percentage of cracks in your stretch between so much chain to so much chain. Otherwise, how can you ask the contractor or the concessionaire to repair it or get it into your own, the covenant has to follow. So, similarly, rutting, 5 mm rutting in some contracts, 10 mm rutting in some contracts, 20 mm rutting in some contracts, percentage area in some contracts, they are given. But we do not have wherewithal, we do not have a mechanism whereby we can give unambiguous, unchallenged kind of data whereby the contractor can enforce upon to the activity. Similarly, raveling is an area, pothole is of course is visible to the air. So what you are doing, by doing through manual mechanism or through a 2-dimensional kind of NSV was not giving us enough results. So we have to go for high-end technology-driven tools, like we have introduced the laser LCMS, laser crack measurement system 2, whereby the cracks up to the width of 1 mm, length, width and even up to depth is clearly given in the data. So the NSP, what it gives, this high-end 3D-dimensional MNC, where we are getting the data collection is done through the high-end technology-driven tools. The data is deciphered within timeline, and the data what is coming is unambiguous, and the data what is getting, we are converting into knowledge. Then we are comparing with the contractual provisions, and each and every contractual provisions we are mapping and asking the contractor, saying that these are the places where in every 100 meters we are giving the data saying that these 6 parameters where you are actually the limiting value has been exceeded. Then this is one part, collection. Thus far, all over the world, collection of data has been done in a robust way. We are also doing that. But the challenge is how to close the loop. After the data is collected, the data is unambiguous and both parties agree to it. And when you are comparing to the contract, how to complete the circle by getting it rectified as per contract within time frame. For that purpose, okay, like what you are doing, each and every contract, we have given a unique project index based upon which we are tapping the contractual data. And and most of you must be aware, there are schedules in the contract, like EPC there is Schedule E, in PPP there is Schedule K, Schedule F in TOT, where each and every parameter like roughness, 2,400 mm per kilometer in a length of 100 meter or 1 kilometer, rutting 10 mm, this is one contract I am saying where these provisions are given. Cracking 5%, raveling 10%, these data we are collecting, and also we are giving every 100 meters, latitude, longitude wise, lane wise. Let's say project is 100 kilometer, is 6 lane, L1, L2, L3, R1, R2, R3, every 100 meters, we are collecting each of these 6 data and mapping them, even in a GIS map, indicating that where you are breaching the limits. And then sometimes we are also coming and say what could be the probable reason for the higher. Let's say a project where 2000 is the uniform roughness, but in some place it suddenly jumped to 3,500 or 4,000. we are intimating, we are also checking with the data and saying, why there could be a possibility that there is a VUP or there is a cross-drainage structure where this is the place where the damage has been done to the approach slab, and that is why the roughness is coming. Even we are going up to that standard, if somebody is interested, there are few contractors, they are coming and collecting data for every 10 meters also. So that not only the data is given, then whenever you are going for a data-based this kind of thing, then this should be a win-win scenario. The contractor also should get advantage of the data. How he is getting advantage? Like we are giving him all the cracks, parameter of the cracks of the 1 mm, not we are restricting them only for the limiting values. Every 10 meters we are giving the cracks, rutting or rubbling or the small potholes also, lead delamination also. Then contractor is anticipating that what is going to happen to his payment next 3 months or 6 months. So he is able to do a preventive maintenance kind of thing. So there the contractors, luckily what we are doing, when we are going this data collection system and its assessment and how we are going in closed loop system, we have introduced in our own data lake a priority maintenance module, wherein all the data collected automatically they are deciphered and they are plugged into that system, whereby the contractor, the consultant, my project director, and everybody in the system, they are understanding, they are knowing the data, and the notices are automatically generated in the system itself, and the contractor is given the notices as per contractual provisions, and the ATRs, we are asking this, my project directors to give the ATRs of each and every parameter which is vested in the attributables, what are coming then. Then what is happening? These data now we have introduced an app whereby if anybody who is traveling on road with this kind of app, he will able to know he is traveling on a, let's say, L2, left-hand side carriageway. If he is going on L2, he will come to know what is the status of road in next 100 meters. Every 100 meters, data is collected and that will be given. That we are mapping it with GIS map. Amit will able to give you a more detailed picture on that.
Good evening, everyone. Actually, when we started this project, some inputs from the field contractors, consultants, and our field units mentioned that because of some genuine reasons, some distresses are shown very high in the reports. So this app was developed so that site verification of the NSV report can be done. There is a small video which shows it. I will skip it because of the lack of time. Basically, it has two features. While doing the site inspection, you have the distress value in your screen so that you can correlate what you are seeing on road and what you have seen on the NSV. So in case you have any doubt, that can be mentioned in the app itself, or the rectification done at site, that can also be uploaded using a geo stamped photograph. So based on this, sir,
yeah, we have now calculated the data. What we are doing, this app we are going to make public soon, so that even every traveler, he will understand what is the status of the road he is traveling now. Coming back, we have done around 2 lakh lane kilometer, out of which one cycle 1 lakh lane kilometer, and this cycle we are going for 2 lakh lane kilometer. And you can see the data which are collected with this closed loop system, the data which is collected last time and after the rectification, what is the status, we are also comparing that.
Yeah, this video shows cycle. Yeah, this video shows cycle 1 of NSV survey. Before the rectification was done, report was shared with the field units. And when we done this survey second time, after 6 months, after video you can see how much road has been rectified based on the NSV report. So no additional expenditure on public exchequer. Without any additional expenditure, these roads pan-India are being rectified. This slide shows how much achievement has been done so far. More than 60% of the roads have been rectified without any additional cost in different distresses. And based on this, some additional, we have taken some digital initiatives. This is AI-based model where we collect the video through a normal driving, and then this video is put into an AI-trained model, which separates all the road signs present on the road and gives us a very crisp report where we can see how much road sign should be there as per contract or as per the requirement and how much is the gap. So additionally we are making a digital twin of all the national highway network.
So what is happening based on this pilot study whereby we have AI based, we have now captured all the signages. Now we are going for a dashcam level, AI level kind of thing whereby all the distress parameter apart from the pavement parameter, the 35 parameters chosen, those parameters will be captured through a dashcam fitted into our route patrol vehicle, and these parameters will be analyzed through AI, and then it will be pushed into our NHI1 app, whereby the contractor has to now look these coordinates as per contract provision and to maintain. So once this is successful, the phase of maintenance, the monitoring mechanism maintenance, and the way what we are doing the maintenance will change. So this is what we are now changed the RPV vehicle model where we are fitting into a dashcam, and this dashcam will collect continuously the 35 data, and through AI analytics this will be linked with the contractual provisions. So the point is what we are now doing after the NSP and other studies. This is what we are going to do. We will rate each and every project based on the pavement condition index and compliance to the NHI1 app for all other distresses. This we have done model study for 285 projects, whereby we are now rating the project based on the pavement condition index and compliance to the NHI1 app for all the distresses. You can see this. This is also we are going to make public to foster a competitive spirit between the concessionaires who are doing the maintenance activities, and ultimately we will also ban or debar or incentivize the contractors who are doing a good job in maintenance. So this is what NHI is doing. Thank you so much. Any questions you can intervene.
Yeah.
We'll reply.
We will take it afterwards.
Thank you so much.
Thank you very much, Team NHI, for giving a nice presentation and touching upon a very important topic of digitized maintenance of highways. Now, the next presentation is by Sri Nirmal Kishan Jambulkar, Executive Director, National Highways Infrastructure Development Corporation Limited. Please.
A very good evening to the chair, co-chair, my co-presenters, and all those members who are present in this August meeting. Yes, we are NHIDCL. We are the youngest executive organ of Ministry of Road Transport. We construct national highways in the northeastern regions, and we are dedicated to the development of the northeast regions. As an organization, we have been incorporated on 18 July 2014, and we have been working since 2015. So it's only 10 years we have been in the business of developing national highways in the northeastern region. Nevertheless, we have taken large strides as a part of thing. We have constructed around 3,500 kilometers of national highways amounting to 60,000 crores, and we have in hand now about 48 projects which will be about 1,50,000 crores. So there is a lot of opportunity for everyone, the construction industry, the consulting industry, academia, and the individual experts also. Yeah, briefing, the Northeast pose specific challenges for the construction of national highways. There are geographical complexities. We construct road on very high elevations, sometimes at elevation of 18,000 meters, where we have scarce oxygen. We have very limited working season. Unlike the plains, we have monsoon season up to 7 months, and that is one of the impediments to construct the roads. Then material accessibility, infrastructure resilience, and there are unforeseen geological characteristics, how the hills behave during the monsoons, and all these things which add to our woes. But nevertheless, we are determined and committed to development of these things. So you can refer these pictures, what kind of situations we encountered during the construction and maintenance of the national highways there. I will not just take you through the glimpse of this picture, just to visualize by yourself what we face. So now we are taking other corrective measures and to face the challenges, how the hill should be stabilized before the construction of the national highways. That is one of the challenges we are facing. And we are incorporating all the new technologies towards this end. So there are pile systems and anchor systems, rock and bolt anchors, shortcutting, rock fill fences. All this we are taking. The other key initiatives are that we have various zones in our national headquarters in Delhi. So there are project monitoring division zone which focuses on tracking of the projects. There is highway and administration cell which take the administrative tasks. There is health, safety, environment and road tunnel cell which look after the tunnel projects and the safety environmental aspects. Likewise, there are other cells which are in NHID cell to take care of every aspect of the civil works which we are executing. And we have done MOUs with all, or we are encouraging the MOUs with the specialized agencies, academic institutions to come and join us in the process of developing national highways in such a critical areas like the northeastern regions. So we have MOUs with IITs, NITs, CRRI, National Skill Development Corporation, Garden Ridge Shipbuilders and Engineers for Bailey Bridges, and Norwegian Geotechnical Institute to help us in the construction of tunnels and the soil stabilization. And various technologies we have been encouraging our projects are geosynthetics, modular bridges, precast walls. These have been constructed in various parts such in Manipur, Nagaland, Jammu Kashmir. West plastic roads we have constructed in Manipur. We are using cement treated subbases. We are using modified bitumens, additives, all these things. So there are series and many of the technologies we are encouraging. We are still encouraging people to come with us to help us in our journey to construct the roads. This is all about NHIDCL. Nevertheless, everyone has a place to work with NHIDCL. The construction industry, we can forge MOUs with them for bidding of the construction projects. We encourage consulting industries to participate in our endeavors to prepare good project reports. We encourage academic institutions to advise us to come up with resource schemes, and even we encourage a particular individual expert. Many of our colleagues get retired from the government organization. We encourage them to participate as an expert, as independent technical expert to monitor the DPRs, as special project monitors, to come and inspect our roads and suggest the corrective measures way forward. So with this, I thank you very much for having patiently hearing me. And I will expect that you will collaborate with us, with NHIDCL, in working towards a good national highways so that the unreached parts of the country are made better and all the logistics supports can be provided there, providing connectivity to people and the nation. Thank you.
Thank you. Thank you very much. Thank you very much for a very nice presentation. And you may be the youngest one, but you are the toughest one also to do the Herculean task of constructing roads in very difficult terrains. Thank you very much. Now, our next presenter is Mr. Bidur Kanja, Director, New Technology, Ministry of Road Transport and Highways. And he will be presenting on appropriate type and grade of bitumen for national highway projects. Mr. Bidur Kanja.
A very pleasant evening to one and all. At the outset, I request Chair to allow me some more time because I will talk about this bitumen, which is known to everyone. The presentation will cover context, why this topic is important, what is bitumen, then Ministry Policy Circular regarding selection of appropriate type and grade of bitumen, source of procurement, SOP for QA/QC. Issues deserve our attention, identified action tasks and futuristic issues. What are the things will come in future? And as a government, we have to have all the enabler policy guidelines specification. We all know that bitumen is black diamond for us. It is very important for road fraternity, all stakeholders from refinery, supplier to contractor and then authority. And performance back to a square one, that means year on year in 2004, 5, 6, 7, 10, 11, 14, 15, 19, 21, 23, 24, 25. So year on year across length and breadth of the country, our bituminous road is developing these premature distresses. It is a major concern. And this is one of the issues regarding quality of bitumen, purity of bitumen. Bitumen gets adulterated while transportation. And construction quality on paper. The underperformance casualty factors, modes of failure and pavement design gaps, bituminous layer rutting, not considered in design, subgrade rutting we consider in our design, bottom of fatigue cracking we consider in our design, top down fatigue cracking we have not considered in design, then method of mixed design, over specification, poor quality materials and workmanship. So all these performance criteria, now we have initiated one multi-institutional research project, MEPDG India, to also develop this performance criteria for the identified gaps. Our aim is long-lasting bituminous road which needs an integrated approach of design, construction and maintenance. A road well designed but poorly constructed fails prematurely. A road imperfectly designed but well constructed performance better than that. At present, till we come to know pavement mechanics better or more closer, the only tools available with us to have a long-lasting bituminous road is enhanced augmented quality of construction. One of that issue is selection of appropriate type and grade of bitumen, ensuring quality of bitumen, a strong aggregate skeleton, adequate rolling compaction. Bitumen, we all know, manufactured from crude oil, long residue, vacuum bottom like that. Bitumen demand supply status, about 35% we are importing, and annual consumption is 83 lakh ton. Composition, it is a hydrocarbon material, carbon, hydrogen, and chemically it has saturates, aromatics, resins and asphaltines. And bitumen is a viscous elastic material. It is time dependent, temperature dependent. Properties of bitumen required for this coatability, water resistance, flexibility, workability. Type of bitumen, paving grade, polymer modified bitumen, rubber modified bitumen. And classification, prior to year 2006, we follow PG grading, then viscosity grading in practice, and performance grading, it will come within a year or two. MORTA has sponsored one research scheme to IIT Delhi and CRRI, and work are in progress. A specification and standard, paving grade, IS 73, PMB 15462, rubber modified 17079, IRC SP 53. is also there, and some revision is under printing. Quality characteristic of paving grade bitumen, it is already given in IS 73, and there was a viscosity overlapping. So after ministry interventions, BIS has done amendment, and now for VG40, the minimum viscosity is 3600 poise. Acceptance requirement, absolute viscosity penetration softening point for individual sample, and then for composite sample remaining tests should be done. PMB classified into 5 grades, PMB 64 up to PMB 82. Classification is based on average maximum pavement temperature and minimum pavement temperature. Selection criteria of modified bitumen, then quality characteristics. It is already given in the BIS specification, acceptance requirement. And one important test is multiple stress creep recovery test, MSCR test. And one of the key parameters is GNR difference 3.2, which is an indicator of the resistance of PMB to undergo permanent deformation, that is rutting. Then CRMB 55, 60, 60. Properties are there. And ministry recently in 2 years issued 2 policy circulars. One recommended bitumen type and grade for different climate and traffic loading. And second one was use of bitumen, demand supply type and grade, specification source, and detailed SOP for QA/QC. So source of procurement for viscosity grade, domestic refinery or imported bitumen, modified bitumen, domestic refinery or domestic private producers. Selection of appropriate type and grade of bitumen, we have constituted a task force under chairmanship of then ADG Sarangi sir, and based on task force recommendation, we have come up with this different type and grade for different climate and traffic loading. So for that, inputs are design traffic MSA for 20-year design period, and maximum pavement temperature and minimum pavement temperature, and for different mix type, one can select the appropriate type and grade of bitumen from this table. SOP, we all know that ensuring quality of bituminous binder is indispensable to have durable, flexible pavement. For the supplier have their own laboratory, ISO 17025. Traceability of bitumen is important, more particularly for imported bitumen. And imported bitumen, the supplier importing bitumen shall preferably have its own vessel to ship bitumen. Imported bitumen, no mixing of bitumen imported and procured from domestic refinery. The supplier of imported bitumen shall be held accountable if bitumen fails to meet acceptance test either in contractor site laboratory or any third-party laboratory. And mandatory testing of sample taken from tankers before unloading, it is mandatory now. And we have also having the responsibility of departmental officers to do some minimum testing in front of them. Issues deserve our attention, then minimum viscosity of VG40 bitumen and VAX content we have also introduced, and no project site blending production of PMB, CRMB, and PMB, CRMB storage tank of hot mix plant shall have a stirrer arrangement. For PMB, we have to do this MSCR test, For CRMB, rubber content should be determined and contractors have that facility. And closer monitoring of quality of imported bitumen is required because few complaints have been received regarding quotability and large variability. And the most important test for imported bitumen is this penetration ratio and ductility of the RTFO residue. So these are mandatory testing before unloading, involvement of departmental official, and one should follow this SOP for bitumen unmodified. Futuristic issues, bitumen tanker fitted with vehicle tracking system and electromechanical locking for geofence e-lock system to avoid adulteration while transportation. Hot mix plant fitted with IoT SCADA for recording accurate batching of constituent material. BIS specification for high performance bituminous binder, graphene modified asphalt, color asphalt, epoxy asphalt, self healing asphalt, or separate BIS specification for plastomer based PMB, because the present BIS specification is biased towards elastomeric PMB. IRC specification for waste plastic through wet process, what the ministry has sponsored one research project to IIT BHU. Modified bitumen using dry additives such as Superplast, Titan, Honeywell. Colored asphalt. Bio-bitumen, we have done 3 trial sections with sugarcane, molasses, bio-oil produced from pyrolysis of rice straw, then lignin-based bio-binder. Future is this bitumen transportation through container using jumbo bag, what IOCL has tried, and in asphalt, in B2 blocks, what INSO, Russian company is doing now. With this thing, the transportation cost of bitumen will be reduced by 40%. Then enhancing quality of CRMB with good quality crumb rubber, because we all know that CRMB is a sustainable material, but there is a perception that its quality is low. So now we have uncracked the issues, and if we include all these tests of crumb rubber in our specification, definitely the quality of CRMB will be at par with PMB or even better than PMB. The PG grade binder, it will come in a year or 2. Air temperature, average of 7-day maximum air temperature, lowest air temperature, we have completed up to district level for different reliability, 50%, 90% air temperature for each and every district mapping and calculation we have done. Measurement of pavement temperature at 10 locations in progress. At all the spread across 10 locations, CRRI and IIT has done instrumentation. They are measuring the pavement temperature. They will measure for 1 or 2 years, and then we develop the correlation, our own correlation for pavement temperature and NN temperature, which give us the performance grade by bituminous binder classification system for India. Thank you. Thank you.
Thank you very much. Thank you very much for a very insightful presentation on various types of bitumen and their appropriate uses in national highways. Now we come to the last presentation, and that is by Sri S.K. Verma, Superintending Engineer, Border Road Organization. He will be talking on key advancement, highway technology and policy in border roads. So please welcome Sri S.K. Verma.
Namaskar, good evening, respected Chairman, Co-Chair, my colleague presenter, distinguished delegates, ladies and gentlemen. In next 15 minutes or so, I will be giving a brief overview about the border roads. Small introduction, what is this organization, where are we working, and what are we constructing. Basically, most of you are aware about the border roads, but those who are not aware, this is the only government agency which is executing the works departmentally as well as through contracts. Why we execute the work departmentally? Because mostly the border road executing the strategic works in border areas, and all these works are of emergent nature, where we need to have our own resources which are deployed 24/7 to handle any exigency. Almost more than 30,000 permanent government employees and more than 1 lakh casual workers with complete machinery and setup, they are deployed in the various areas. This is a uniform cadre, the only construction agency which is putting uniform because of the certain situation and the deployment conditions. Vast experience in the entire border areas, starting from the deserts of Rajasthan to snowbound areas of the northern region and the rain flood areas of the eastern region. Self-contained, ready to be launched force at any time because the complete manpower is available 24/7, so they can be launched in any sector of the country at any time without going for any contracting or any procedural delays. Inbuilt capability of the distribution of resources, because we are having all our own resources and those can be shifted to any of the area any time. Little journey about the border road. It was raised in 1960, basically when the country was facing the security threat in the entire northern and eastern borders. So initially the agency was raised basically for the strategic works, and then later on the responsibility of socio-economic development of the areas were also given to us. The border road organization was started with the 2 projects, one in the western sector, that is in Srinagar, and another in the eastern sector in Tezpur. Now there are total 18 projects spread around the complete border, land border of the country. We have been working in the various neighboring countries like Sri Lanka, Afghanistan, Myanmar and Bhutan. This is the overall presence of the border road in the complete border areas. Challenges generally, you are all aware the situation in border areas. Either there are very extreme cold conditions, snowbound areas, and sometimes you will be surprised to know that to complete an investigation of say 5-6 kilometer tunnel, it takes 3 seasons. Because taking the machinery those areas and retaining the manpower becomes very challenging above 10,000 feet. These are the few glimpses of the challenges generally in the areas where border road is working. Recently, because of the modernization and policy changes, the road construction in last 3 to 4 years has been almost doubled in the border areas. Earlier, we were cutting the fresh roads of almost 1,500 to 1,600 kilometers per year. Now we are cutting more than 2,500 kilometer roads per year. And the black topping rate of the complete border areas were around 700 kilometers per year to now we are doing almost 1,500 kilometers per year. So this is because of the policy advancement of the government and the certain power, delegation of the powers given to the various executive of the border roads organization. BRO has constructed in last 65 years more than 60,500 kilometer roads and more than 1,100 bridges in the various border areas. The various milestones which recently have been accomplished by the border road is the Saser-Bangja bridge over the 15,000 feet in the northern corridor of the country, which is a very highly strategic boost to the country's security. The Jojila, we are maintaining almost 27 snowbound passes in the entire border areas. Some very important passes are the Jojila Pass, Kardungla Pass, Namikla Pass, Saserla, Umlingla, Sapikla, Rajdan Passes, Sinkulla, Kunjumla and Barlasla statewide. Then Sikkim we have the Dokiala and Nathula passes. You can see the closure time of these passes. Earlier the passes were closed for more than 3 months. Now they are just closed for 1 year because we have introduced so many advanced snow clearing equipment. The tunnel construction, we are all aware of the Atal tunnel constructed, one of the longest tunnel in that altitude of the 10,000 in the world. And presently, Sela tunnel has also been completed in the eastern corridor while moving from Tezpur to Tawang area. The passes recently which have been connected, the earliest highest pass was Umlingla, which was around 19,000 feet. Now recently we have connected the Mingla Pass, which is more than 19,500 meter height, where it is very difficult to retain the manpower and even the efficiency of the equipment goes down to below 30%. All these structures have been recorded in the World Book of Records. Certain structures of the BRO has also been awarded the Vishwakarma Awards in the recent past. The work on Sinkundla Tunnel, which is alternate third axis to the Leh, has been started last year, and the almost more than 200 meter excavation, 400 meter excavation has been completed in this season. These are the certain recently completed roads in the different sectors of the country. Airfields, we have rehabilitated and modified the Bagroda airfield and the Barakpur airfield. Rescue operation in Silkyara tunnel, the responsibility to the border road was given to connect the one axis of the Silkyara tunnel where the important equipments and the rescue teams were taken up, and all the tasks were completed on time and the rescue operation was completed successfully. Now I will be talking about the advancement being done by the border roads. In road construction, we are using all the digital and AI-based survey and diligence design techniques, environment-friendly construction technologies, sustainable and green construction practices, use of energy-saving construction materials, climate-resilient structures, stabilization techniques, lightweight structures, use of precast structures, and the mobile maintenance practices also. BRO has its own R&D establishment at Shillong, and almost all the R&D works are being taken there. Digital and AI-based bridge health and monitoring system is also being adopted. You can see the certain photographs of the work being done by border roads, the stabilized based construction, the use of plastic waste. This is the controlled blasting technique to avoid the heavy fly of the rocks and destabilization of the slopes. You can see the laying of concrete blocks in high altitude areas. Here is the precast. Earlier, BRO was not able to adopt the precast technique because the areas where we are working, it was very difficult to take the heavy machinery and heavy lifting equipment. Now the road condition has been approved, and with the help of modern equipments and technology, we are able to adopt the pre-construction practices also. Now more than 40-meter long girders are also being done precast in the border roads. This is the photograph of the white topping done in the J&K area. These are the use of geocells and geomats in the high altitude areas for the slope protection. Rockfall mitigation measures taken, and now in most of the snowbound areas we are using the concrete block pavements to avoid the early damage and damage during the snow clearance operations. Steel slag test already covered by Dr. Pandey of the CRRI. This project was taken up in the most extreme border area of the Arunachal Pradesh, which is almost, the steel slag was to be transported more than 1400 kilometer distance. And the Tata Steel has provided free of cost steel at the last railway station and Harmuti in Itanagar. And from there it was taken by border roads. Steel slag you can see. In bridge construction, almost all the new technology are being done. We are adopting the cable steel bridges, extra gauge bridges, long steel arch bridges, modular steel arch bridges, precast 3D printing of the bridges, automated concrete misting machineries, stainless steel corrosion resistant bridges, lightweight structures, use of UHPC. Recently we have completed the lab test of 150 MPa UHPC in our J&K area with the help of IT Delhi, and now the field trials for the same concrete is being done, and the Bridge of 35 meter will be constructed with the use of UHPC in the J&K area. Digital-based AI health monitoring already I have talked about. These are the few signature bridges built by the border roads, 592 meter long Atal bridge in J&K over Ravi River. These are the two bridges in over Chenab and another bridge on the Jhelum. You can see the bridges over Siang River in Arunachal Pradesh, very prestigious and important bridges from the strategic point of view. This is the 763 meter Pasighat bridge. The old MRTH and the engineer from the northeast, they are aware that the bell sinking of this bridge took almost more than 18 years, and the complete scientists of the country, even the international scientists, were involved in this bridge. Advancement in tunnel construction. We have completed almost 6 tunnels in the eastern and western corridors, and we are working on the 3 tunnels. And more than 15 tunnels are in the pipeline. So BRO is going a big way in the, for the tunneling in the complete Himalayan region. These are the few glimpses of the tunnel construction. Avalanche galleries, most of you may not be aware about this structure. What is the avalanche gallery? Generally in the snow-bound areas where the passes are there and avalanche comes, just to ensure the safe movement, the galleries are constructed in their area, and I saw the photograph of snow galleries also. You can see the snow gallery structure where the snow avalanche will pass and you can negotiate the road safely without any damage to the vehicle and the manpower moving over there. Almost 28 new materials are being tried, and the 8 research projects are being taken up with the various IITs and prestigious institutions like IITs and NITs in the complete region. So thank you, Jai Hind, for patient hearing.
Thank you very much. Thank you very much, Mr. Verma, for showcasing us the workshop VRO and what human service they are doing to the nation building. So with this, we come to the end of presentation of this session. Now floor is open to the question answer session. So we can take up a few questions, though we are running out of time, but still, as it is the last technical session, so we would like to invite few questions, definitely. You raise your hand so that mic can reach you. Yeah, please reach the mic there.
Sir, it is really commendable that in the difficult terrains, BRO has been working for the development of roads and tunnels and connectivity that is being improved. Yesterday we had a presentation in which we found that in some of the long tunnels there has been some fire accidents and things like that. So what are the precautionary measures that we have taken while designing these tunnels, and whether any such protective arrangements have been installed so that some automatic control of such type of disaster can be taken up?
Yeah, very relevant question. So generally while designing, the code says you have to design the tunnels for 50 megawatt fire load. So the final lining is to be designed accordingly. But generally the strategic tunnels, nowadays practically we are considering more than 150 megawatt fire load for the design. So that is from the design point of view. And the cement and the paintings which is being used is fire resistant. All the accessories which are installed there, either they are the pipes or the electric accessories, fans, etc., they are also designed for the same fire load. So that is from the design point of view. As far as the evacuation and the detection system is concerned, nowadays all sensor-based safety equipments are being installed in the tunnels, and any incident inside the tunnel will be known in a fraction of seconds, and the complete fire mist system are being installed in the all tunnels to handle any sort of exigencies. And apart from that, now the policy decision has been taken that there will be a helipad near all the tunnel portals to evacuate any sort of mishap there. So all sort of precautions are being taken in long tunnel, and tunnels which are under construction are also having all these sort of arrangements. Thank you.
Thank you. Yeah, next one.
Yeah, I am Prerna from Hanuai. All of you who are sitting here are true nation builders, really, really impressed and thankful. My query is specifically to NHI, DCL and BRO. You both have shown the use of technology in what you do. How are you protecting it? Because there is a lot of element which should be contained within the country. And as we see the technology, there are so many things which go beyond our country because now it's open source and all. So what are the things which you keep in mind to ensure that whatever the services you are doing, the products you are using, the cloud you are using are only as of India or Indian base?
Ma'am, as such, there is no cloud services or these things that we cannot do these things. All these are international technologies and the nation technologies also. So our is a civil work. So when we do all these civil works, okay, they can be mapped on your Google also. So it is all open. Okay. So as such, what you are telling, there is no such system in place as of now.
Ma'am, what Mr. Jamulkar has told, so that is correct up to some extent, that the structure which is built there and the operation which is being done there during construction, in the today's modern communication system having satellite and all these mapping systems, whatever physically they are viewing, they can match. But the data which is available in our computers, in our software, that is definitely protected with a lot of protection systems, and it is very difficult to take away those data. But definitely the process which is being done, and it can be mapped from anywhere. Thank you.
Any more question? Yeah. So I think this should be the last question. Yeah, please speak up.
My query is regarding the specification and to MOD department. Sir, MOD specifies requirements of the aggregate in specification book. They have classified coarse aggregate as aggregate retaining on 2.36 sieve and fine aggregate as aggregate passing through 2.36 and retaining on 75. But for coarse aggregate, in their table 508, they have specified the detailed properties, physical properties. And in that they have written that aggregate shall have water absorption below 2%. But they do not specify regarding fine aggregates, what shall be the water absorption for fine aggregates. And second query is that anti-stripping agent and lime helps for hydrophilic aggregates, but they do not correlate to what shall be the water absorption.
See, for coarse aggregate, generally we classify based on 100% retain on 4.75 for general practice in concrete and in everything. So in water absorption also we have to do the testing up to 4.75 retain material only. But in case of bituminous mixture, we come up to 2.36 mm, retained on 2.36 mm. Because for gradation design there is primary control sieve, secondary control sieve. So based on that concept, it is 2.36 mm in case of bituminous mixture. And as far as NTS stripping or water absorption properties is concerned, our specified maximum water absorption is 2%, okay? And we have to do this coating and stripping test. And if some aggregate does not comply or satisfy, then one has to use hydrated lime or even NTS stripping agent. Thank you.
So this will be the last question. Okay.
Sir, I'm Deepak Mittal from Black Gold Infra. We are into microsurfacing applications. Do we see BRO adopting all these latest technologies for preventive maintenance, microsurfacing applications and all?
No, microsurfacing we are not adopting as of now, because generally our roads in hilly areas, they need a lot of slight clearance operation, heavy rain. So we have tried to test the microsurfacing, but it has not performed very successfully. Yeah, definitely now we have started working with the white topping, is the thin cementitious coat. But definitely microsurfacing we have not tried yet.
So now you have this polymer modified emulsions.
Yeah.
So which gives very good results. Now earlier it was still 8 mm.
Okay.
Now we can increase the thickness also of the.
So we have a project of designing the bituminous layer with the NIT Meghalaya, I think, or the R&D center Silang is having that project, and we are doing this with the using polymer modified bitumen emulsions. Sorry.
Yes.
Thank you.
Thank you very much. Now I think it's the end of it. And now to sum up, I would like to invite my co-chair to give his closing remarks.
As we have heard, all the topics were quite interesting, and that was represented by different organizations of the Government of India. Dr. Pateria, representing NRIDA, mentioned about the challenges of the rural roads, and the most interesting thing is the rural road network length is very high, and we have only covered 17% through PMGSY through Government of India, of course, besides the state government what they are doing. But the real challenges is going to the last mile connectivity, which is the ultimate goal of the Government of India. He has, in his presentation, he has highlighted on the new technologies, policies which were adopted by NRIDA. Out of 1.66 lakhs of kilometer targeted, they have completed 1.17 lakhs kilometer, which is a very, I would say, very good progress. He has highlighted on E-mark for maintenance, performance-based maintenance, and 3-tier quality management system. NHAI was represented by Sri L.P. Padhi and Amit Munjal. Adoption of innovative digital initiatives for improvement in operation and maintenance of NHA's national highways in NHAI. Very, very innovative and interesting topic. And they have clearly mentioned how the monitoring has to be equipment based. What I have understood, the most important thing today is for the maintenance, it has to be equipment based monitoring, and that will only help us, because having such large network, it is humanly impossible to do it without equipment based. Digitization of road construction monitoring and for good riding quality has been highlighted in their presentation. And they have given a lot of, how they are going to adopt it, and giving, I would not say case studies, they have given specific recommendations with the different formats for data collection, and how at every 100-meter gap, every lane width, the data will be collected. And not only data will be collected, that will be within 2 weeks, it will be interpreted. Because so far, data collection was much easy. But getting the getting into the report used to take a lot of time. And they are assuring us that they are doing it within 2 weeks, which is remarkable against 3 to 4 months in the existing setup time. Now the third presentation was by NHI DCL, Sri Nirman Kishan Jambulkar, our Executive Director. He has mentioned the challenges, border roads and NHI DCL, the challenges are almost analogous. They do work in a very inaccessible areas, very climatically challenging situations, and where the manpower requirement is very little, very difficult. Taking good equipment is also a great challenge. In spite of that, they do a lot of things, and they have he has suggested different kind of performance-based technologies. In spite of such great challenges, they have not forgotten
to take innovative technology initiatives into their construction methodology, which is really a very praiseworthy effort, because in rest of the country it is very easy, but taking new methodology and new materials into their project sites is quite praiseworthy. The fourth one was appropriate type and grade of bitumen for NH projects by Bidur Kant, our director from Ministry of Road Transport. He has very correctly said that bituminous road consists of 85% of the national highway, which is a very large number. And we want long lasting of bituminous road as against the present situation is, you know, how much we are projecting, we are not getting the satisfactory life, I would not say life cycle, but the life period. He has mentioned the different quality aspects and also the ministry's 2 circulars, which are very, very vital. He has shown us those 2 circulars. And he has given some mandatory testing, and futuristic issues has been very, very nicely dealt by him. Then performance-based bituminous binder also he has mentioned, and it is definitely a very good presentation. Now, the last presentation was made by Mr. S.K. Verma, Superintendent Engineer, Civil Border Roads Organization, Key Advancement, Highway Technology and Policy in Border Roads. The same thing, I mean, an organization which was there from 1960, they have completed so far 63,500 kilometer roads, 1,086 number of bridges, 21 airfields and 6 tunnels. And besides that, the most interesting thing is, we are informed that 20 tunnels are undergoing construction, if I'm not wrong. I mean, this is a huge, you know, what we have found out today, tunnel technology within last 2 decades have been improved like anything. And I think the credit goes to National Highway Authority, Border Roads, Indian Railways, and NHIDCL. I mean, all these organizations are doing a fantastic job, because within the last 2 decades, the tunnel technology has been of world-class standard. I would not hesitate to mention this, that our technology of tunnel engineering, now we are going for the world-class standards. Because of the paucity of time, we beg apology from all the speakers. We wanted to hear more, but we have been given a job to finish it in time. So our apology from all of you. Thank you, sir.
Thank you very much. Now I will just take a couple of minutes to sum up the session. It has been my sheer privilege and pride to chair the last and concluding session of the IRC conclave. In this session, we have had the presentations from various departments of the Government of India. And we have seen a very wide spectrum of road work which our country is doing. And we have seen the works from NRIDA, from NHI, NHIDCL and BRO. First presentation was by Dr. I.K. Pateria, who has been a legend in himself in NRIDA. I think he deserves a big clap, because he has been serving NRIDA for last, I think he's since inception, if I'm not wrong. So this is a great thing that he's there for last 25 years. And NRIDA and the PMGSY system is one which has shown the way how the computerization and the online system can help monitor and our road network, the quality control and assessment. So all the processes have been standardized by NRIDA, and he deserves a big accolades for his pioneer work. The second presentation was from a team and NHI, and it was on a very relevant topic that is on the digitalization, digital initiatives for the maintenance of road network. We have created a very huge road network in our country, whether it is national highways or it is state highways or rural roads. So the maintenance of this huge, vast network is a very big challenge, and it definitely requires the digital-based mechanisms and equipment-based monitoring. So he has presented a very panoramic view how the highways can be maintained by using the digital initiatives and the equipment-based models. The third presentation was from NHIDCL, we all know that NHIDCL is, of course, a very young organization, but it is doing a very great service to the nation by building road infrastructure in a very difficult terrain. So they are dedicated to only such works which are very difficult. And I think every civil engineer, and particularly the highway engineers, should once visit the NHIDCL or the BRO works in their lifetime, just to see in what difficult conditions the civil engineer works. The next presentation was from Ministry of Roads, Road Transport and Highways. That was again by our very legendary figure, Mr. Bidurkant Jha, and he has deliberated on the types of bitumen. To him, I would like to make a request or a suggestion that he should deliberate more on bio-bitumen. Actually, I was expecting something more on bio-bitumen, but he touched upon this thing, but he didn't deliberate much on this. Because our Honorable Minister also pointed out in his inaugural remarks that bio-bitumen is the material of today, so we should focus more on it. Then the next topic is of the important in this imported bitumen. Imported bitumen, actually our field engineers are struggling to check the use of imported bitumen, and especially when it is not of good quality. So is there any mechanism of imported bitumen being checked at the source itself, when it comes to our country, when it touches our source? Is there any quality check there? Because once it enters the nation, then it is used somewhere or the other roads. If not NHI, then it will be used on some state roads or some rural roads, but it will be used. Once the product comes inside, then nobody can stop its use. So I think there should be a mechanism of quality check at the source itself, at the port itself. So is there any mechanism?
Before custom clearance, at the port of discharge or unloading, they have to submit all the test compliance as per a specified IS, sir.
Submission is different thing, but testing, the actual testing, facility should be there.
No, what we have specified in our SOP, sir, suppliers should have at the port of discharge, they have their own quality lab for internal quality check, sir. But before unloading itself, sir, before custom clearance itself, they have to submit the test report, sir. So if test reports are okay, if these are not manipulated or simply given paper by the third-party testing agency, then there is different case. But the process is well established.
Because it's a very big problem, and I think most of the field people must be facing it. Then the last presentation was from BRO by Mr. S.K. Verma. So BRO, we all know that they are the people who are working at the borders and in very difficult terrain, very harsh weather conditions. And he has invited me to visit some of his works in Ladakh. So I think everybody should go and visit the works of NHIDCL and BRO, because definitely it will give us pride to be civil engineer when we visit such type of works. So with this, I think we come to the end of the last session of the conclave. Thank you very much for listening very aptly. And I hope that each of us will take some lesson home from this annual session of IRC. And we should come together to make our standards better, to make our practices more feasible and doable. And with this only, we can make our nation a developed nation by 2047. Thank you very much. Thank you.
Thank you so much, sir. Thank you so much. Respected chairman for the session, Shri A.K. Jain, sir. And of course, the co-chairman of the session, Shri Ashok Basa, sir. Thank you so much. And also a big thanks to all our presenters. And now it's time to felicitate all our respected presenters with the memento. And for giving the memento, I would like to request the chairman of the session, Sri A.K. Chain, former engineer-in-chief, UPPWD, and past vice president of IRC. Can we have the memento on stage, please? And for receiving the first memento, I would like to request Dr. I.K. Pataria ji to please come forward. And let's give a big hand for I.K. Pataria ji. And for receiving the next memento, I would like to request Sri L.P. Padhi, CGM. Thank you so much, sir. And for the next memento, I would like to request Sri Amit Munjal ji, GM Tech, NHI. And for giving the memento, also would like to request our respected co-chair, Sri Ashok Basha ji. And the next memento is for Sri Nirman Kishan Jambulkar. Thank you so much, sir. For the next memento, I would like to request Sri Vidut Khan Jha. Thank you so much, sir. For the next memento, I would like to request Sri S.K. Verma. Thank you so much, sir. Thank you so much, respected chairman of the session and co-chair. Thank you. Now it's time to felicitate, of course, the chairman of the session and the co-chair. And for felicitating them, I would like to request on stage Engineer Sri Satyabrat Behera, Engineer-in-Chief, Works Department of Odisha. Let's give a big hand and let's welcome Satyabrat Behera, sir, on stage. And first, we're going to felicitate the chairman of the session, Sri A.K. Jain, sir. Requesting, ladies and gentlemen, let's give a big hand. Now requesting the respected co-chair of the session, Sri Ashok Basha, sir. Thank you so much, Engineer Satyabrat Behera, sir. Thank you. And thank you, our respected chairman of the session, co-chair, and all the respected presenters over there. So with this note, we are winding up the technical session 19. And thank you, ladies and gentlemen, for joining us on 84th annual session of Indian Road Congress. We have the entertainment part, music and dance, the gala night in another hall. Please go and enjoy. Thank you.